Thank you, Hannah. All right, if I could have everyone's attention, we're going to get started. Thank you. So good morning. Welcome to the Spur Center and the 51st Annual One Health and Zoonoses Conference. We're excited to be at the Spur Center again this year, and we're excited to see all you people here and all of you online, even though we can't actually see you. So a couple things before we get started. Bathrooms. If you go back out this door you came in and kind of go around that piece of wall, you'll find bathrooms right there. Folks online, when you have questions, please put them in the chat, and our chat moderators will pull those for the folks up here in the panels. Okay. I am very happy to introduce 3 veterinarians from the state of Colorado. I have Dr. Maggie Baldwin, the Colorado State Veterinarian at the Colorado Department of Agriculture. Dr. Baldwin manages CDA's Animal Health Division through planning, directing, and executing all programs, policies, and cooperative agreements with other governmental agencies. We also have Dr. Allison Kohnen, the designated state public health veterinarian for Colorado and our voting member for the National Association of State Public Health Veterinarians. Her work at CDPHE focuses on control and prevention of reportable zoonotic diseases and providing expert consultation to veterinarians, academic partners, and local public health agencies. And last but not least, Dr. Peach Van Wick is a Mississippi native who attended Mississippi State University for undergrad, grad school, and vet school, and after graduating, spent 4 years at the Wildlife Center of Virginia, practicing clinical medicine on native Virginia wildlife and researching sarcoptic mange in black bears. In 2020, Peach moved to Wyoming, where she assumed the role of Assistant State Wildlife Veterinarian for the Wyoming Game and Fish Department. And then as of July 2025, we were lucky enough to have Peach take over her current role as the State Wildlife Veterinarian for Colorado Parks and Wildlife. So if you could all help me welcome Drs. Baldwin, Kohnen, and Van Wick, we will hear their comments.
All right. I'm just going to hold it because I'm really awkward with microphones, and that would have just dropped. Good morning, everybody. Thank you, Natalie, for the introduction, and welcome everyone to the 51st Annual One Health and Zoonoses Conference in Colorado. If we can get the slides going, that would be great. All righty. All right, so I am very excited. I am Allison Kohnen, the State Public Health Veterinarian, as you just heard, with CDPHE, to start us off this morning. And we're, obviously we're here for One Health. This presentation is just a Kickstarter into the conference. We are a One Health Colorado. We are trying to put that into practice at the state level and integrating with everyone else at the local level. And so why are we all here? Well, this conference started in 1975 by the state Zoonoses group and some local animal control. And it initially started to focus on zoonotic diseases only, and a lot of the topics discussed were focused for animal control officers and epidemiologists on rabies control. Throughout the years, it's shifted, and in 2020, Dr. Marzak actually changed the name of the Zoonoses Conference into the Colorado One Health and Zoonoses Conference, and so we're now expanding into more topics broader than just zoonotic disease. What is great about this conference is that we have a very diverse audience here in the room. Last year we had over 30 different specific job titles in the audience, spanning from our public health workers, epidemiologists, environmental health specialists, veterinarians. We also have animal control officers and researchers, and the list goes on and on. So we're happy that you're here, and we hope that the diversity of the attendees remains this way. This is just a word cloud of all of the professions that were listed on our registration in 2025. So today, we are focused on everything One Health, And these images are representing some of the topics from the speakers that you'll hear from throughout the day. And the big thing is that from our perspective at the State Health Department, the Parks and Wildlife, and Department of Agriculture, is that we're doing all of this work every day and intersecting on all of these topics by looking at sorry, your thing's locked. Looking at how we are working together from a different perspective on different missions, but on the same issues. So our goal in Colorado is, of course, to have healthy people, healthy animals, and a healthy environment. And all three of these things intersect. Where we start from is from our mission statements. So the CDPHE mission is to advance Colorado's health and protecting the places where we live, learn, work, and play. The department serves Coloradans by providing high-quality, cost-effective public health and environment protection services that promote healthy people in healthy places. We also are looking for healthy animals, and CDA and CPW really lead the charge there for Colorado. The Department of Agriculture's mission statement is to strengthen and advance Colorado agriculture, promote a safe and high-quality food supply, protect consumers, and foster responsible stewardship of the environment and natural resources. And the environment. All three of us are responsible for the environment, and here I'll share CPW's mission statement, which is to perpetuate the wildlife resources of the state, to provide a quality state park system, and to provide enjoyable and sustainable outdoor recreation opportunities that educate and inspire current and future generations to serve as active stewards of Colorado's natural resources. Now, I didn't put all those words up on the slide because that would be annoying to read, but if you heard the themes, they are pretty concurrent throughout the three about protecting the ecosystem, the environment of Colorado, and promoting healthy populations. So with that, I'm going to transfer to Dr. Baldwin to discuss some of the work we're doing at the state level.
Great. Thanks, Allison. Good morning, everybody. It is great to see a lot of familiar faces in the audience. I'm going to talk about our One Health MOU. Hopefully you guys have seen this. This came out last year. So a little bit of background. We did have previously a zoonotic or Zoonoses MOU with CDPHE. That was put in place in 2007. For those of you that knew Dr. Rohr, he used to say, we did One Health before One Health was cool. And that it really is reflected in the work that we have done through the years, but certainly having a Zoonoses MOU in place since 2007 does demonstrate that. But we decided after our latest ongoing HiPathAI response that we wanted to update that MOU to include our wildlife partners and really solidify the partnership that we have across all of our state agencies. So we did sign the first ever One Health MOU in the state of Colorado that was announced on International One Health Day. So that was a very exciting moment for all of us. This MOU really outlines our agencies, our roles, our jurisdictions, our authorities, the different things that we do in our roles. And it also works to protect data and data sharing. So we have some protections at the CDA level that we want to make sure if we are sharing case information that with our other state partners that data is also protected. So a lot of it revolves around data sharing, data protection, information sharing, but really how do we actually work together? And I think one of the cool things about this MOU is that the scope is not just zoonotic diseases. So One Health is much bigger than zoonotic diseases. One Health includes not only our zoonotic and reportable diseases, but things like food safety, contaminants. We talked about PFAS last year at the conference, and that has been a really big growing concern in the One Health space. Emergency response on the all hazard side as well as disease response. And all of this really requires close coordination between all three of our agencies. So I'm going to go through a couple of examples on my side of One Health in action. And the first one is something I spoke on this maybe in 2018 or 2019 at this conference. We talked about Q fever and coccidioidomycosis, and this was the first time that I had a really big introduction in the public health space and understanding the importance of having our public health partners with us in disease response. So Q fever is the disease in humans. Coccidioidomycosis is the disease in animals. And one of the challenging things with Coxiella is that it is ubiquitous in animals, meaning that they just carry it and they shed it. And sometimes it becomes pathogenic. So recently, CDPHE had a case of Q fever in animals. A case of Q fever in a person that was diagnosed, and they reported that to us, and that person happened to raise sheep. And so we have, over the years, since 2018, created this joint response where we have public health come out with us to our on-site visit, and we do a joint case investigation. Public health is seeing the same stuff that my veterinarians are seeing on site. They're getting the same information, and we're able to provide the same recommendations to that animal owner. One of the challenging things when we work in different spaces is if they're hearing different things from public health and hearing different things on the animal health side, they're not sure who to believe. So, and it becomes really confusing and challenging for the owners. So showing up with a joint response has been one of the strongest things that we've done. This is actually a risk assessment matrix that we had one of our interns put together years ago on our joint investigations. So how do we determine what we do on the animal health side as well as the public health side? And I'm just going to give a plug for you to attend Dr. McGrath's session. This is another ongoing and emerging risk that we're seeing coming from Mexico, New World screwworm. The good news is she's talking about this right before lunch. And there will be really great pictures right before lunch. So this is a pathogen that we do have a really big One Health focus in our response. In our preparedness and response efforts, we want to make sure that we have our public health partners, our wildlife partners in that response with us. So feel free to attend that. Hopefully I didn't scare folks off. And then I'm going to turn it back to Dr. Kohnen.
All right, just to continue, some examples of how in Colorado we are integrating One Health into our mission and responses is that Dr. Baldwin did mention PFAS just a moment ago. So this is our non-zoonotic example of how the three departments have integrated. And so at CDPHE, we have both the communicable disease aspects, the public health aspects, and environmental protection and regulation under a big department. And so on our environmental health side, they have been working on PFAS for years and have a PFAS action plan. But what happens when that contaminant enters into the livestock system, and what are the downstream effects of that? And so there's a lot of research work at the national level trying to determine how do we handle this problem. And last year we hosted a joint workshop between CDA and CDPHE to bring all the experts on PFAS and on agriculture together to talk about that problem where we don't have solutions yet, but we're talking through the scenarios of what happens when that is detected and how do we inform the public, how do we create those joint statements and make sure there's alignment between, as Dr. Baldwin mentioned, making sure that our communication is effective and also consistent between our departments so that there isn't a lot of confusion and we continue to build the trust of the public as well as our local partners. So I'm not going to go into details on PFAS. Hopefully you heard our talk last year, but that is one example. And then I'll go back to zoonotic disease just because it's the easiest to show. And in 2025, every year seems to highlight some new things. So in 2025, we had an interesting tuberculosis case. So this story started with a veterinarian reporting to the Department of Agriculture, actually, of suspect foreign animal disease in a cat. This cat had recently been imported from Liberia in Africa. And the history on this cat was that it lived on a chimpanzee sanctuary. So the real critical moment of this investigation was that this veterinarian who saw this cat in critical care on an emergency visit actually thought to report this. So what happened is the Department of Agriculture got involved. The clinician suspected tuberculosis in this cat and so Dr. Baldwin shared with us at CDPHE, and we started implementing recommendations for the vet staff to protect themselves as they were working with this very sick cat. It turned out that through great partnership with the CSU Veterinary Diagnostic Laboratory, who received samples from this animal, and actually ultimately this animal was euthanized due to its illness, collected samples and had consistency with acid-fast bacteria. And so it was forwarded on to the National Veterinary Services Laboratory, another part of our holistic approach to investigating emerging and unknown zoonotic diseases. And they confirmed Mycobacterium tuberculosis complex. Well, with our public health partnerships, we were actually able to get samples sent to National Jewish in Denver, which is a world-renowned TB center for treating humans with tuberculosis. That's a great history in Colorado that we should probably bring back at some point. And they were able to do some novel sequencing techniques out of these samples and confirmed the case as being infected with Mycobacterium tuberculosis africanum. Not to be, not surprising because this cat came from Africa, but this is the pathogen that infects people in Africa, most commonly causing human tuberculosis. So it's a great example of how this coordination, data sharing, and now with the MOU, the protection of that data, the personal health information for the client, the animal's identification, and if there were any livestock involved, the producer and premises information. So just wanted to highlight that. It was a success. No humans were infected in this investigation, but we learned a lot. And animal importation, of course, is something that we don't always think about in public health as impacting us, but it certainly does. And like having the coordination at the state level so that we know what the regulations are and where we could stop the importation of foreign diseases is really critical. And now I'll hand it off to Dr. Van Wick.
Thanks, Allison. Oh, this is it. Great. Okay. Good morning, everybody. As Natalie said earlier, my name is Peach Van Wick. I am the state wildlife veterinarian for Colorado Parks and Wildlife, and am happy to be here and happy to stand next to such great colleagues and collaborators who are interested and receptive of including wildlife in this conversation. So I'm happy to be here for the first time and hope to continue to be involved in this conference. Kind of following up with what Maggie and Allison presented, I wanted to give a couple of examples of One Health response and coordination and collaboration with our partners whenever it comes to wildlife-specific diseases. So this past year, we tend to see a case or two of tularemia in beavers and or rabbits each year, but they're pretty far and few between. This past year has been kind of interesting in that we've had more than one beaver that has come up positive for tularemia. So this case, back in the fall this past year, we got a call from one of our biologists who through kind of the chain of events, a member of the public saw a dead beaver floating in a body of water. Oftentimes when people see a dead or injured or sick animal, then they might just Google on their phone, Colorado Parks and Wildlife or Colorado Wildlife and get routed to a call center or their local CPW office. And so our front desk staff are really, they tend to act as that first line of defense. And when they get this report, they often reach out to the officer or the biologist in their area, report that, and then the biologist or officer ends up communicating with us. This is the situation. What do we do? Can we get it up to the lab? What are we thinking? How do we protect ourselves? We have those conversations in real time. Sorry, Allison. So that's what happened with this beaver, and got this beaver up to the lab. It did come up positive for tularemia. I keep wanting to say tuberculosis. So what happens next is that our staff ends up working closely with CDPHE to understand, did anybody get exposed to this animal? Is there continued risk for exposure? One of these beavers, I'm not sure if it was this one exactly, was found outside of a water park in Gunnison, and so there was a press release put out about that case and some signage that was posted in that area to let people know that this could be a risk. Please, avoid any sick or dead beavers. Avoid the water, don't let your pets get in the water, that sort of thing. And so we work with CDPHE to put up signage when it's appropriate, and then we also make sure that our staff is aware of these types of risks and these types of concerns. And then one other example that I'll share with you, as well as kind of a future hope. So as Maggie mentioned earlier, our MOU that was signed this past fall, one of the big things that it kind of covers is how each of our agencies can protect the data and the personal or public information that we are required to protect while still being able to share pertinent information with each other. And so as of right now, I think we would all really love if we had some sort of collective disease dashboard that we could enter in information and really see, what a specific disease may look like across all of our sectors in the state of Colorado to help us understand risk and, our messaging to the public and to our stakeholders. While that is not that's not a reality right now, I think it's a big, pie in the sky hope for us in the future. What we're working on internally at CPW is creating a map. This is HPAI, for example, but creating a map of these types of cases that our internal folks can use in order to communicate to the public when they receive calls about a dead goose in Weld County, for example. Then they can look at this map. They can see where we have, detected those positive cases across the state, and we're working with our data team to make something like this available to the public. So that is something that we're working on and hope to be able to work with our partners in the future. So we've kind of, all three of us have given examples, different case-specific examples, how we work in this, One Health realm within our own agencies. So we encourage you that throughout the rest of the day to think about, where you sit in this room and who you are and what role you perform and who you work with. And this is just a short list of, Allison mentioned a list of everybody that has been in the room in the past and currently. And I want you all to think about where you fall within this One Health triad, and to recognize that the saying "act local, think global" is kind of used in these spaces and in these types of conferences, but it really is true. We all work with front desk staff. We work with general practitioners. We work with producers. We work with animal control officers. We work with researchers. We work with law enforcement. And just having those moments, those conversations, picking up the phone, answering those questions can really lead to the issues and the cases that we all talked about earlier. So we encourage you to think about that as we go on throughout this day. And with that, thank you. I don't know if we don't have time for the questions, but probably if you have some, we're around later.
Can you all join me in thanking Drs. Wick, Baldwin, and Kohnen? Thank you. You're welcome. Okay. I also just realized that I never introduced myself, and that's a huge, sorry. I'm Natalie Marzek. I run the Zoonoses and One Health program at CDPHE, and I'm also a co-principal investigator in the Rockies and High Plains Vector-Borne Disease Center. I co-PI that with Dr. Foy up at CSU, who would be here except that they have a competing meeting related to entomology and mosquitoes. So for our next session, I'd like to welcome Dr. Christie Mayo and Samantha Allen. So Dr. Mayo is the head of the virology section at Colorado State University's Diagnostic Medicine Center, where she's actively involved in diagnostic test development. Currently, her main thrust of her research has led to characterizing the ecology and genetic diversity of an economically important arbovirus that affects livestock, Bluetongue virus. Additionally, her research has focused on developing novel diagnostics for the veterinary diagnostic community and utilizing next-generation sequencing to monitor and characterize infectious agents. Samantha Allen is the supervisor of veterinary services for the Wyoming Game and Fish Department and the wildlife veterinarian for the state of Wyoming, and is the current president of the American Association of Wildlife Veterinarians. Dr. Allen's practice of veterinary medicine has been guided by her deep interest in wildlife health, infectious disease, and wildlife pathology. So let's welcome Drs. Allen and Mayo, and we'll hear some about Bluetongue.
Okay, everybody, are you excited to be here? A colleague of mine once said that if you want to waste 2 hours of your time, introduce Culicoides or Bluetongue with me, and here we go. And I met Dr. Allen last week virtually, or over the phone, and I think we could waste probably 18 hours of your time with the collective interest in Bluetongue. So without further ado, though, I want to start here with this quote. And as I entered this journey for a grant that I received for Ecology and Evolution of Bluetongue virus, I think this quote can speak to all of us in a One Health context. And today I hope we're going to flourish. That's my main goal with Jane Goodall. But we also have some local heroes here. Temple Grandin, she's been somebody that I've always admired in the way she's approached to research. And if you notice, they're in the ecosystem. They're in the ecology that they study. And that is something that I've taken to heart in my own research. As you can see here, some of my students with me, with our sheep, with our ecology, with our populations, because we cannot understand One Health unless we're really in it, right? So that's where I'm going to approach this talk today. And I'm going to be talking about a very broad scope of work. I'll probably have to bebop through the later portions of my slides so that Dr. Allen can take the stage. But the big context that I want to get across is we received a grant for the ecology and evolution of Bluetongue virus, trying to understand a very complicated system, everywhere from the natural ecology and the landscape to understanding what is actually going on between invertebrate and vertebrate species, all the way down to the genetics. And the genetics of Bluetongue virus can be complicated. It's a segmented genome, much like flu. So it has this ability to swap segments and reassort and evolve in very curious ways. But I was the PI, fortunate enough to be the PI, which most of my lab says, where's Waldo or where's Mayo when I'm not around? But I had the great fortune to have so many co-PIs taking on this work with me as we experienced the journey for 5 long years. And I'm going to focus mainly, though, on these 2 parts. So mainly the ecology out in the landscape features, and then some of the stuff we've learned from the evolution pieces. So with that, we're going to do some interactive exercises because we got to wake up, right? So fun facts about Culicoides. First of all, they're small. That's the Culicoides, also called a midge. Next to it's a mosquito. So we're dealing with very small creatures, and this is what transmits Bluetongue virus, okay? But why do we care about all the things of their species in nature is that the fact they have different distributions. So when we're going to species identify, and some of our students have found novel species in different areas, which is really cool, some of them have been Bluetongue positive. Trying to understand the ecology is very difficult in a vector-borne system, so you have to understand where the vector is actually moving and transmitting the virus. But to have some interaction, do y'all know how we species identify for the most part for Culicoides? Anybody? What'd you say? 10? Yeah, maybe. What I'm looking for, yes. Wings, you got it, you nailed it. So the wing patterns are exactly how we species identify for the most part. We've come to genetic components as well, but really morphologically, this is the way we identify. Can you imagine looking at the wings on that little creature? It's very difficult, especially when you have a lot of them. So just focusing on what we've done in the lab, it's pretty cool stuff. We've investigated the invertebrate species, looking at everything from habitat to looking at species identification. And Carly, Dr. Barbera here now, who's graduated, she really challenged me. For a long period of time, we've thought wastewater lagoons at dairies were the primary larval habitat. And she said, no, I think there's other habitats. And sure enough, she proved me wrong. She found a lot of different larval habitats that were actually able to foster Culicoides. Why is that important? It really alters our management and how we might be able to create or eliminate some of these larval habitats. So really pretty cool stuff. She also went out and wanted to look at different host species. So what would the host diversity look like? And I've grabbed a few, this is the places that she actually went and surveilled. These are the traps. So you see they're next to larval habitats and there are vertebrate species. But the one thing I wanted to grab, she did some camera trap data. And in this photo, not only do we have vertebrate species ruminants, which is the primary vertebrate species that gets Bluetongue, but they're commingling in these different larval habitat and environments. So wildlife and domestic interface is really important in understanding this viral disease. So that leads me to the vertebrate. So when we think about Bluetongue virus, we typically think about it affecting primarily morphology or pathology in sheep, clinical signs. and we think about its cousin, epizootic hemorrhagic disease virus, which I'm not going to talk much about today, we're typically thinking about that in deer, and Dr. Allen will get to talk more about that. I just want to highlight that there have been significant die-offs. This is a very impactful disease when it wants to have its day. So just recognizing this has a lot of impact as we look into the ecology. That's the wildlife picture, but I also want to highlight that it does affect our domestic ruminants. So our cattle, our sheep, and not only is that bad for disease, but it also has big impacts on trade. So I want to highlight that sometimes even just based off serological data in 2015, Canada shut down the markets. That has a massive impact on the financial constraints for trade. And so I have to highlight Dr. Burton. She just defended her work a couple weeks ago, and she went out and looked and to see if we had active, with active surveillance, do we have Bluetongue circulating? And by evidence of PCR and ELISA, which is looking for nucleic acids and antibodies, we do see the big picture in 2022 and 23. We do have antibody prevalence as well as RNA prevalence out in the world. This is a bit more detail on looking at the ELISA and PCR results in sheep and cattle populations. But the primary point of the data on this slide that I want you to highlight is that we also have a number of what we call serotypes circulating throughout the years. Classically, we've had about 5 endemic circulating serotypes, but I want to highlight that we've also had novel circulating serotypes. So why is that important? I want to come back to the fact that this is a segmented genome, and largely we're giving a name, as I call serotype, just based on one, sorry that's kind of jumbled, but just based on one segment. There's a reason we do that, because it encodes for this outer surface protein that gives antibodies the ability to neutralize. So it makes sense that classically we've named it that way, but now that we have genomic next-gen sequencing, is that the appropriate way to name? Question. So as we're thinking about those serotypes and novel serotypes presenting, this is a fun story. And one of my former grad students, Dr. Carpenter, years after we had collected the sample, said, let's sequence it. And she found BTV6. And I'm just going to bebop through this because this is what One Health is, and the integration of what we've been talking about is the kickoff. Several agencies were involved in the fact that we were able to move through this and actually get a novel serotype that I formerly would have to report to Dr. Baldwin into a place where, I'm just going to bebop through this, we could actually have impact working together. So what is that? How is that impact meaningful? It allowed us to revisit classifications. So I want to just recap, slow it down a bit. That novel serotype, something I would have been reportable earlier, allowed us to come together and say, wait a minute. We know we're going to get novel serotypes introduced. We know this is going to happen in our future. We know that right now, at the time, I could not operate in a BSL-2 capacity because these were classified then as BSL-3 pathogens. So the USAHA and we worked together to make a resolution. This will probably be where I end on this topic, but this resolution allowed us to reestablish or reclassify how we make these different categories. And the biggest impact in 2023 and 2024, we were actually able to move with the BMBL into different biosecurity classifications. That allows me to work with all the viruses that we find. We know we're going to find them, except for BTV8, which is a whole different story, in my environment, so my students can work with it. I'm just going to highlight the fact that we're building scientific community no matter where we go. We've actually had impact in order to have these studies impact a greater portion of international work. And I'm going to allow Dr. Allen, I promise, to get some time here, but I just want to highlight we've done a slew of next-generation sequencing and co-infection studies and reassortment studies. We're identifying patterns of reassortment. The work that all these folks have done has been over the course of 10 years. But what I really want to highlight here is this is actually something called RNA scope, and this is a co-infected midge. So not only have we taken that little midge and co-infected it and identified green and red represent 2 different staining features of 2 different viruses, but we're identifying actually where they co-infect and where they commingle. Okay. So I'm going to just end here because I want you to have some time. But where we're going with this is the fact that we are in a changing world. This is a segmented virus, a vector-borne disease. Climate is variable. One would say it could be changing. We could be getting hotter environments where Culicoides can outstretch their manes. The global distributions could be getting in different areas. And with that, I want to highlight that we have had major outbreaks in Europe consistently, having massive impacts. And so what I want to end with is that with our work and with good collaborations, with good One Health approaches, you can actually accomplish quite a bit, and big problems can be taken care of. And I do want to leave here because I think this quote, if people in my lab would know, singing often when not prescribed is something that we like to do. It's something we should celebrate and highlight. The massive amount of work that goes into research projects like this could not be done without having broader impacts in the world and having outreach. And so that's something that we take very seriously, to the point where we've actually been able to create a whole cures lab, a whole cures course about Culicoides. If that's not an accomplishment, I do not know what would be. So these are all the folks that allowed us to make this happen. And with that, I'm going to turn it over to Dr. Allen for her talk.
Hi, everyone. Thank you so much for having me here today. Please think of me later as I try to drive back through the traffic that I managed today somehow. And also, I made a silly decision to go after Dr. Mayo, so also give me some kindness as I go through some of these slides here. So today, we're going to carry on a theme. We're going to be talking about hemorrhagic diseases, but the lens is going to shift a little bit more to the wildlife area and more to the management kind of area. There we go. I think everyone in this room has seen a version of this slide probably a million times. Now, I took this one because there's a bear on it, but I also think everyone in this room really sees the importance of the animal environment and human health being interconnected. We're woven together, right? Like a scarf, and if you pull a little piece of it, the whole thing kind of unravels. But as I go on and talk a little bit more about Wyoming and hemorrhagic disease, I really wanted to highlight the wildlife health aspect. Wildlife play a key role to a lot of these different sections here. One, they're excellent sentinels, right? We always use them as the canary in the coal mine. I can think of a number of infectious diseases and otherwise that have kind of showed that to be the case. But the other thing with wildlife is they're a huge part of our biodiversity. They make up the most of it, and they're also very important for our well-being. I also would be remiss if I did not highlight some of the folks in the unit that I work with day to day. All of this wildlife work could not happen if it was not for our veterinary services unit. This is a small group within Wyoming Game and Fish Department where we focus on wildlife health. Obviously, I kind of gave that away a couple of slides ago. But through our wildlife health lab, our Thornton Williams Wildlife Research Facility, we do investigation, diagnostic, education, and research on a number of different pathogens. And I've listed some of the ones that give me a lot of consternation every night when I go to bed. But you'll see that a lot of these pathogens that we work on are not just wildlife-centric. We may come at them in our unit as a wildlife lens, because that's what we're supposed to do. That's why we get paid. But all of these primarily deal with external stakeholders and other sectors. And that is no different than when we're talking about hemorrhagic diseases of deer. These diseases really occupy a multitude of different people in different groups, varying from different walks of life. And in Wyoming, this is a very typical presentation for hemorrhagic disease in deer. We'll get a call about maybe 1 to 20 dead white-tailed deer in the middle of a cornfield somewhere, and we get asked a lot of the similar questions. 1, am I going to die? So that's always my favorite question. I always say it depends. I like to keep people on edge a little bit. 2, I get asked, is my dog going to die? Because for some reason the dog was there too, which is fine, that's how it is. And then 3, it starts to really expand out. One of the things that kept happening to us, though, was people started to have really good long-term questions. We really got away from the Am I going to die? I licked it. Is that a problem? And we went more into the, can we prevent this? I hate seeing deer die every year from this. I had 10 this year. Is it going to be 20 next year? And that really started to shape some of the questions and potentially what we wanted to provide to the state and our external partners, because we were already doing this work, right? We're already taking the call and saying, yes, you have hemorrhagic disease and your dog is fine, but could we do something more than that? So to give you just a general background for Wyoming, hemorrhagic diseases are endemic to the state. So Wyoming, this isn't their first rodeo. It's probably their 800th millionth rodeo dealing with it. And the first case of epizootic hemorrhagic disease was diagnosed in 1955. A number of different species have been impacted over the years, from wildlife to domestic animals. Wyoming tends to fall in a 4 to 7 year cycle. We like to be special, not that 5 to 10 that other people are using. And basically what that means is between that 4 to 7 year period, we will have a larger than typical outbreak. And that normally includes multiple counties, multiple species, and more than like 2, basically. And this is just a really fun map that we have online that we can talk about later. And this is just a really old map of the USA looking at hemorrhagic diseases, but I only put it in just to show people that while it happens throughout Wyoming, the eastern and northeastern part of the state, this is typically where we find these cases over and over and over again. So when we start to think of the big picture and people are asking long-term what this looks for, we really had to evaluate our surveillance program internally and see what could we do and what could we provide. We kind of went to a passively enhanced surveillance scheme. This isn't a real scheme. Please don't look this up somewhere and be like, Sam lied to me. Mainly what this is we're utilizing how we already get reports, but we're changing the messaging, and we're trying to provide something externally for folks. Internally, for a really long time, you'd have folks that are like, I know it's hemorrhagic disease. I don't have to collect a sample. I don't need a diagnosis. We can go on from there. But we really wanted to say, hey, we want your samples. We want to test for this because we need to track this going forward because we're dealing with a climate-driven disease. So just because 20 years ago it looked one way, it doesn't mean it's going to be the same 20 years from now. So in 2020, we focused more on our key messaging to staff, what data we could collect and maintain internally. We started switching our diagnostic methods to doing more of an internal diagnostic. So we have a lab, let's do that. And then we wanted to provide that data to external partners. Again, a lot of our surveillance depends on the public and our field staff through field necropsies or full postmortem examinations, and we would get typically submitted lung, liver, and spleen. And this is just very preliminary work. We started this again in 2020. So, we just started looking at it because, again, climate-driven disease, we have to give it more than 2 days to start evaluating things. But just to show you, based on our 23 counties across the state, and we have our years above from 2020 to 2025, this is some of the work that we've started to generate and be able to provide externally to folks. And you can see that 2021 and 2025 year, we did have larger years. About 11 out of 23 counties were impacted. We had multiple species, and we had both viruses. And that's really interesting and important to note, too, because typically with wildlife, as Dr. Mayo said, we're talking about EHD, but we are picking up Bluetongue sporadically in our cases as well. We've also confirmed, the species that we typically thought. I mean, I know people think science is boring if you find the same things over and over, but that's cool too, right? Like, that's good. We weren't totally off maybe 20 years ago. We found co-infections between Bluetongue and EHD, which I'm going to talk to Dr. Mayo about later because those were fun for someone who likes this disease. July 14th to December 2nd, we've noticed that cases are extending out of what we would typically think of a hemorrhagic disease season. So we're picking up potential shifts and when these things are occurring. And then we picked up chronic cases. So anecdotally, we've definitely had cases of chronic disease. And this is very similar to some of our southeast colleagues, but Wyoming is also picking up on some of these too. So it's an important thing to document because this means it's been going on for a while and we potentially have a shift at that host kind of area. And then our serotyping started in 2022. We haven't found anything massively abnormal. We found a Bluetongue 13. Maybe rare for Wyoming, probably not. It's not rare for the US or the West, so it's probably been found many times before. And just overall trying to highlight that all of this work now has allowed us to start understanding the epidemiology better in the state of Wyoming, provide that information to others, and build capacity internally and externally. So getting away from, I know it has hemorrhagic disease, I don't really care, to sharing that to people outside of our network. And if you know how to use Google, which a lot of you look like you do right now, you can actually pull up our maps online. They are updated in real time. It's not just this disease that we look at, but all this information is available as folks need it. And that is it. Thank you so much.
Okay, thank you, Doctors Allen and Mayo. If you could hang out, if you want to take some seats, hang out toward the front. We'll do questions and answers after our next two presenters. So next, I would like to introduce Dan Tripp. He has been a wildlife disease researcher for the Wildlife Health Program in Colorado since 2009. Currently implementing research to address the management and ecology of plague in Colorado's shortgrass and shrub steppe ecosystems, and investigates the efficacy of several plague management tools to mitigate the impacts of plague on Colorado's native wildlife. He chairs the Related Species Subcommittee and serves on the Disease Subcommittee of Black-footed Ferret Recovery the Black-footed Ferret Recovery Implementation Team and the Colorado Black-footed Ferret Work Group. So welcome, and thank you. Let's hear about plague.
Thank you for that introduction. All right. Well, thanks for everybody for coming out today. We're going to talk about plague management for wildlife conservation here. We're going to give a little bit of context on what plague is. We're going to talk about the scales, local and global scale. We'll go over the basics of plague ecology as it relates to wildlife and fleas. Then we'll also talk about plague control, why we would do plague control and how we might do it. Well, first off, what is plague? Plague is the disease that's caused by the bacterium Yersinia pestis. And Yersinia pestis is usually transmitted by fleas. And infections with Yersinia pestis can quickly lead to septic shock and death in wildlife and humans. We've had 3 major global pandemics with plague. The Justinian's plague in the 6th century, the Black Death that we're all familiar with in the 14th through the 17th centuries, the modern pandemic beginning in the 20th century, still occurring today. And these pandemics have caused millions of deaths throughout Europe, Asia, and Africa, and have been a major source of social and political distress throughout our recent history. So where did plague come from, and how did it become such a global pathogen? There's over 200 mammalian species reported with plague worldwide, and these arrows on these maps show the hypothesized routes of spread of plague during these pandemics. The orange arrows represent Justinian's plague. The red arrows are the Black Death, with plague emerging in Central Asia and moving via the Silk Road into the Middle East and Europe. And the black arrows are the modern pandemic, where plague was spread around the world, likely on shipping routes. It's important to note the introduction into the west coast of North America in 1900 at the port in San Francisco. And it was this event that likely seeded North America with much of the plague that we see today. Human cases in the United States are sporadic. You can see there on the left, human plague cases for the last 23 years. And on the right, you can see locations of human plague cases. 1983 was a bad year, 40 cases. We average about 7 cases per year. And you can obviously see a big cluster of plague cases in the Four Corners area and throughout Colorado. So in Colorado, I think it's important to note that Yersinia pestis is a non-native invasive pathogen. It was first reported in San Miguel County in the southwestern part of the state in 1941. That was only 85 years ago. So obviously, Colorado's native wildlife have not had enough time to evolve any resistance to this pathogen. It's currently very well established in Colorado. You can see from all the symbols up on the map, those are wildlife and domestic animal cases in Colorado. Is there a way to cycle the animation? There's a background slide, background image that these photos are over. It's all right, I'll wing it. It's all good. There we go. Good job. Okay. All right, so go ahead and hit it again. Okay, so why would Colorado Parks and Wildlife care about plague, right? This is a human pathogen, pandemics, Black Death. What does it have to do with selling hunting and fishing licenses, right? Hit it. Let's see if it... Okay, so but plague is a huge problem for our native wildlife. It creates a ton of conservation issues for us. And here are a few of the species that we're really quite concerned with. Black-footed ferrets are a critically endangered species, and in 1985 there were only about 10 known alive in the wild. Most of these animals were captured, brought into captivity, and every black-footed ferret alive today is a descendant from these few animals. Black-tailed prairie dogs and Gunnison prairie dogs were also warranted for protection under the Endangered Species Act, with plague listed as the #1 threat against these populations. So clearly prairie dogs and black-footed ferrets are heavily impacted by plague. But it's not just these species that we're worried about. In Colorado, we have mountain plover and burrowing owls that make much of their home ranges on active prairie dog colonies. Swift fox and American badger also build their home ranges around large active prairie dog colonies and use that as a resource which was to raise their young. And then there's a whole suite of raptor species that really key in on prairie dogs as a prey source, like the ferruginous hawk and the golden eagle. I think maybe more importantly is that prairie dogs are recognized as a keystone species, which means they have a disproportionately large impact on their ecosystem, and they're real drivers of biodiversity in the shortgrass prairie and shrub steppe ecosystems where we find them. So at this point, we have to ask, is there anything that we can do to help wildlife? Maybe we could use insecticides to kill the fleas and break the flea-rodent transmission cycle. Maybe we could use a vaccine to boost host immunity, in this case in prairie dogs or ferrets. We're going to shift gears a little bit, and we're going to talk about plague management tools. We're going to ask some questions about, do they work? How do we use them? And what innovation is needed as we move from research projects into management. And by management, I mean here wildlife conservation at a landscape scale. I'd also like to thank some of our collaborators. City of Fort Collins Natural Areas Program has allowed us access to some field sites where we've conducted much of the research that we'll talk about. And then also Colorado Parks and Wildlife and Colorado's Species Conservation Trust Fund have been major funders of the work that we're going to talk about. So the first tool that we use is deltamethrin dust to control fleas. Delta dust is a synthetic pyrethroid insecticide, and it's labeled for control of fleas in rodent burrows. And it controls the fleas topically. We try to put 4 to 6 grams of this dust down into the inside of prairie dog burrows. And this can actually be pretty hard to achieve, mostly because there's no purpose-built equipment with which to do this task. To give you a sense of what this looks like, here these maps show dusted colonies. All these squiggled lines are GPS track logs on technicians as they move through the colonies, dusting burrows, either on foot or with an ATV. The map on the lower left, all those dots, those are the locations of individual prairie dog burrows, and that plot is only about 100 acres in size. So you can see that dusting is very labor-intensive. It's especially labor-intensive when you have unreliable equipment that you're always trying to repair. Through this research and that of others, we've determined that the deltamethrin dust really only works for about 8 to 10 months after application. This started us down the path of really focusing on the equipment that we're using for these projects. We took commercial dusters. These are dusters that we're able to purchase from a supplier, and we dusted 65,000 prairie dog burrows. I reached out to some engineering students, and we built these prototype dusters that run on high-pressure air, and with these new prototypes, we dusted 130,000 burrows. And this is the data from that experiment. The gray swath through the middle of the graph is our target dose. That's 4 to 6 grams per burrow. The x-axis is time, operation time of the machine to achieve that dose. The red and orange dots are the commercial dusters that we buy. And you can see that through a lot of effort, we're able to get most of those dots inside our target range. However, it takes us between 5 and sometimes out to 14 seconds of operation time to achieve that dose. The new prototypes that we built, shown in the green and the blue dots, are much more clean and concise with inside the target range, and we're able to do that in only 1 second of operation time. So what we learned here is that with a standard 5-second operation time, 60% of the equipment that we would purchase would fail to reach our target dose, and that quality control monitoring was absolutely necessary with all types of dusters. Without quality control monitoring, underdosing was likely, and that this would lead to a lack of efficacy and potentially even speed the evolution of resistance to the insecticide. So at this point, we have these prototype dusters up here shown in number 1. We published a paper with a how-to guide so that anybody that wanted one could build one for themselves. At this point, we got feedback from the field, and folks said, Dan, that's really cool, but what we need is we need one that we can put on the front of an ATV that has an onboard compressor and works with low pressure air instead of high pressure air. So we built the one there shown in number 2, and we tested that, and it worked really well. So we published another paper with another how-to guide so folks could build these for themselves. Again, we got feedback from the field, and folks said, Dan, this is really great, but we don't want to build these. We're biologists. We're not mechanics and engineers. Will you do it for us? And I said, no, I'm not a mechanic or an engineer either, but I'll find a manufacturer that will. So we had a manufacturer, and they looked at it, and they made several design improvements, and they are making the production model shown here in number 4. And this is what's being used to do most plague management in North America today. Shifting gears just again, here's another flea management tool. This is fipronil grain. Fipronil grain is on an edible bait, in this case oats, with the systemic flea control, fipronil impregnated into the oats. And this is a product that's labeled for control for fleas on prairie dogs. In this case, we're using a half a cup, which is 90 grams or about 4 ounces, at the entrance of active prairie dog burrows. And our major research questions here is, could we get a longer duration of efficacy? Could we get out to 12 months or maybe even 24? Anytime you're using insecticides in the environment like this, there are obviously safety questions. And those safety questions can be about the target species, in this case, prairie dogs and black-footed ferrets. You can also have safety questions on the non-target species, which is everything else that lives on these prairie dog colonies. So we expanded our research here over the last few years to collect more data on safety and really focused on small mammals, arthropods, dung beetles, and pollinators. We've done a ton of work and collected a bunch of data, and our safety research is ongoing, and I hope to have some results on these safety research for you maybe next year. A third plague management tool that we can use is sylvatic plague vaccine. The plague vaccine was developed at the USGS, National Wildlife Health Center. It's a recombinant raccoon pox virus vectored vaccine, and it expresses the plague antigens F1 and V. Greater than 90% of prairie dogs survive laboratory challenge with Yersinia pestis after vaccination. And we found that young prairie dogs were more responsive to the vaccine than older ones, just like you would expect in a human population. The USDA Center for Veterinary Biologics granted approval for us to start using and testing this vaccine in the field in 2012. We started with safety trials. In these trials, we used the vaccine in the field. We captured prairie dogs and other small mammals and checked to see if we were observing any adverse effects. Once the vaccine was deemed safe, we moved into the second phase, which was efficacy trials, where we used the vaccine to see if we could limit plague mortality as epizootic plague moved across the landscape. The conclusions that we made from these experiments was with the vaccine, there's no evidence of adverse effects in prairie dogs or other wild rodents. Both dust and vaccine appears to work, at least to limit the collapse of these colonies from plague. Neither of the treatments is perfect. We still see plague mortality on areas used with either of these treatments used. Both insecticides and vaccine are likely going to be needed for an effective plague management program. And then we were obviously going to need to treat whole colonies or complexes of colonies and not just small plots. And then we were going to need to scale up. If we wanted to do this at a landscape scale, we were going to need to figure out how to do that. So one of the first questions were, can we mass produce these vaccine baits for wildlife management? In the photo there, that's my colleague Rachel. She works at USGS. And if we could zoom in and get a better quality photo, you would see that Rachel is using cheesecake pans to make slabs of vaccine bait. And then she's using a kitchen knife to cut them into those cubes. That worked pretty good for research, but Rachel said, Dan, you got to find a different way. So we did a bunch of experimenting at CPW, and we made a series of formulation and manufacturing improvements to the process. And we're currently able to make lots with 4,000 baits per lot. So we've gotten at least 10 times more efficient at this. Currently, CPW manufactures about 1 million baits per year, and this supports plague management on about 15,000 acres throughout Colorado. This is really focused on conservation efforts for black-footed ferrets, Gunnison's prairie dogs, and white-tailed prairie dogs. So if you make 1 million baits, you got to figure out how to put 1 million baits on the landscape, right? Photo number 1 is how we used to do it, and that's technicians walking down transects with a Ziploc bag. A motivated technician can cover 5 to 7 acres per hour. Some of our colleagues at the Fish and Wildlife Service and World Wildlife Fund developed this machine. It shoots a bait out the right side, a bait out the left side, drops one out the bottom. You put it on the front of an ATV, and with that machine, you can do 50 to 80 acres per hour. The problem with these machines is they're pretty unreliable, and they're really difficult to maintain and service. So that started a new collaboration between Parks and Wildlife and Colorado State University Rapid Prototyping Lab to build and design the new machines you see in photo number 3. Some of these new prototypes that we're developing are able to achieve about 130 acres per hour. So we're moving in the right direction. And then kind of lastly, some of our colleagues have started work, first attempts anyway, at using drones to dispense these baits for wildlife conservation. Fish and Wildlife Service, World Wildlife Fund, Arizona Game and Fish have all done some first attempts here. Some successes, a lot of failures, and this is a zone here that I'm hoping that CPW and CSU can really work together to make some improvements on our efficiency. And then lastly, if you've seen anything in this talk today that you want to hear more about, you want to understand how we do this, or you're interested in protocols to how to manage plague for wildlife, we put together this plague management manual, and it's available for download off the Colorado Parks and Wildlife website. Thanks for your patience, and we'll chat later.
Okay, thank you, Dan. We will bring Dan back with the former 2 speakers at the end for questions. Next, we have a presentation from Dr. Claire Tucker, who is a small animal veterinarian, graduated with a DVM and MPH in 2019. She is the first One Health, One Medicine Fellow at CSU, completing a residency in small animal emergency and critical care and a fellowship in translational medicine. She's currently working as a veterinary criticalist, as a fellow at the CSU One Health Institute, and as a PhD student, studying the dog as a natural animal model for human trauma. She's passionate about highly effective and efficient teams and how to support the future One Health practitioner. She's online. So Dr. Tucker will be presenting online.
Can you all hear me okay?
Yes.
Okay, great. We did test run this morning. Hi, everyone. Apologies that I'm not in the room with you today. It's hard to get a little bit of a day off in the critical care world, but I'm very excited to be with you regardless and very honored to be asked to present. I'll keep an eye on the chat, but obviously can't see those of you in the room very well. So please, bring your questions to the end of this talk, and I'm very excited to be able to engage with you here. Let me just get my slides going and we'll go from there. All right. I'll assume, unless I hear otherwise, you can see these okay in the room. Like that introduction noted, my name is Claire Tucker. I'm a veterinary criticalist and have been involved in the One Health world now for over a decade. I know many of you professionally and am excited to be able to extend one of my passions in this space today. Before we get started, I want to ask you a couple of questions. One of them is, when you started to identify as a One Health practitioner, this is an identity that I don't think was easily given, especially to folks who, aren't in their graduate or undergraduate educations right now. When did you decide that this kind of work was going to be the right thing for you? For me, I was lucky. This is my kind of linear bio. I got a One Health graduate assistantship during my MPH and have been working in this space ever since. However, I know many other people don't have that linear luxury. They have to decide at some point that this is something, this value of collaboration, this idea that we're working in a transdisciplinary way, that's not something that's inherent to many of our jobs. And I know doesn't always come easily. So try to pinpoint that moment in your head. When did that happen? What led up to it? Were there inputs that really made a difference for you to now be sitting here today saying, yep, I like One Health and I'm going to be passionate about it in my work, sometimes when it's difficult and sometimes when it's easy. My other question for you is, how effective are your teams? These are my teams. I could rank order them in terms of effectiveness, especially in the way that One Health defines effectiveness. I suspect many of you can rank order your teams as well. How do you know that a team is working in a way that is collaborative, that communicates well? Those are the questions that we're really going to try to answer today. How do we get more of the people that all of us, both online and in the space you're at today, we're all going to be mentoring people, bringing up students, trainees, the people that we work with. How do we help them feel that not only that they are One Health practitioners, but they are part of a team that supports that from both a culture perspective, but also from logistics. Hey, we're going to protect this time and we're going to protect you to be able to do this kind of work. My questions for us over the next 17 or so minutes, I'm going to introduce the idea of interprofessional education. For the MDs in the room, this is going to feel like a no-brainer. You know what this is. But for the One Health space, bringing together the ideas of interprofessional education and One Health has been fairly novel over the last 5 years. I'll demonstrate how it overlaps with One Health, and then how our last question will be how we implement this strategy. As I'm talking, I want you to think about the people that you are going to mentor in the future. How are they going to be able to have these collaborative, communicative skills that help them to look at these big transdisciplinary problems? And what of my talk today could be applied to the people that you teach, mentor, that you directly supervise, that helps all of our teams and all of the people coming into our jobs in the next 15 or 20 years be able to do this a little bit better? We really like the idea of a highly effective team in One Health. This is a figure from a paper we wrote a few years ago. It's really easy to understand. We don't like the individualist approach as much. That's the blue side. We really want those puzzle pieces to fit together. That's the green side. I love One Health because it makes, ideas like this fairly simple. What is challenging is you want these puzzle pieces, but how do you make the environment for those puzzle pieces to find each other and to align appropriately and then actually fit together so you can get to that solution? In my One Health work, we've tried other ways of sort of thinking about how to organize ourselves. Apologies, this is probably a little blurry, but this is the only place I could find this was in a PDF from over a decade ago. We've been trying to say, how are we going to do this work? We've tried to organize it on an analytical scope, an organizational scope, a geographic scale. We've also tried to come up with diagrams that have a lot of different inputs and outputs. I think this is helpful to sort of understand how decisions are being made. However, when I look at this as a One Health practitioner, I don't really know where me individually and my work can plug in, and I don't really know how to make goals for myself as an individual or for my team based on some of these structures that have been put into the One Health space. I think One Health is really good at strategizing, at big idea generation, but it's not as good as the logistical piece of things. In One Health, obviously veterinarians are some of the first to the table, but MDs came very quickly. And as those collaborations have gotten stronger, one of the things that we've learned from our human medicine colleagues is the idea of interprofessional education. In the veterinary world, a lot of our big idea generation, a lot of our collaboration takes the form of One Health lectures, of One Health clubs. What happens in human medicine is not identical, but it is a corollary. And in most human medicine programs, they have what we call interprofessional education. They want to create practitioners of whatever health service, whatever sector, that want to work well with other people. And I think that is absolutely what us in the One Health world and certainly in the veterinary world strive for as well. When you look at the definitions of interprofessional education, they're pretty simple. It occurs when two or more professions learn about or from or with each other. That could be a definition of One Health. When you transition that from education, classroom, to practice, your job, then you have multiple healthcare workers from all these different backgrounds that are trying to deliver the highest quality of care. I would argue, again, that is something that we are passionate about in the One Health space, even if we're not always calling it quality of care exactly. You all have experienced this interprofessional education. When you go to the hospital, you have multiple people coming into that room who have different degrees, different goals with you that day, different people who want to hear certain sides of your story. And the folks who have been trained in interprofessional education, they want to know what all of these other people in the circle know. They want to talk together. They want to make sure that you get the best care, as opposed to having 5 or 6 or 8 people come into your hospital room individually, make individual decisions, and then your treatment plan becomes quite segmented and sometimes doesn't lead to the best outcomes. With the idea of interprofessional education comes the quintuple aim, and every decade or so they add another aim in, but right now we're at quintuple. This is the idea of improved patient outcomes and experience. So not only do you feel healthier, but that all the time in the hospital room is better. How do we bring health equity to folks, making sure that some of the people in this circle are representing some of the more social and behavioral and familial sides of things? How do we lower cost of care so the same test isn't done twice, so that patient doesn't bop back into the emergency room? And then how do you as a provider feel better about some of that information? So overall, the human medicine side of things thinks this is really important for the way that healthcare will be delivered, both now and in the future. Interprofessional education is based on 4 competencies. You can see those in the circle around the kind of inner circle. So values and ethics, roles and responsibilities, communication, and teams and teamwork. And this is basically allowing people to understand their role, the roles of others, and how all of these different competing, job titles, job scopes, and needs of the patient can be balanced so that this patient gets as good of care as possible. When you make that a little bit more tangible, this is, for example, from the University of Washington, you take those 4 competencies and then you put them into a syllabus. This is what you would expect of a student who has gotten trained in interprofessional education. And as you peruse some of these buzzwords, I suspect that you find some similarity to One Health. You see some things that you as a One Health practitioner might resonate with. So again, as we're evaluating this idea of interprofessional education, there's more and more synergy along the way with One Health. Just to be clear, interprofessional practice is not some of these things that you maybe have seen in your own healthcare or sometimes even in the One Health space. I'll point out specifically the one in the bottom left, reporting out at interdisciplinary team meetings. Sometimes I feel like in our One Health space, we are all coming from different spaces. We stand up and we do our 5-minute talk and we're like, I'm glad to know about that, but it doesn't have any impact on my work. Arguably, that's not really interprofessional practice. So how do we get to the level that people are giving and taking in a way that's both more readily easy to do, but then applies to that outcome and improves the outcome at the end of the day? Now, let's add on One Health. So again, let's look through these words. We already know interprofessional education and interprofessional practice. One Health just adds in sort of that bigger geographic scope, that sector scope that allows us to say, yep, we want to work together. One Health is challenging us to do that across a bigger sector, a bigger set of disciplines, and of course, across a different set of health goals, because we're including people and plants and the shared environment. These are some of the competencies that were just put out by our One Health leaders within the last few years. And again, the words communication, collaboration, equity, all of those are happening between both interprofessional education and One Health. The question now becomes, are these two ideas that are sort of the two sides of the same coin, or do they support each other and need to be overlaid to be able to be applied to the work that you and I do every day? I love this figure because I think it summarizes really well all the slides I've just gone through. The domains are different, but the competencies are the same, the goals are the same, and the outcomes are the same, except IPE is more focused on individuals and One Health is more focused on populations. So I think this really shows we have the same goals in mind and can start to borrow and collaborate and steal and use frameworks that work on the IPE side and use those in the One Health space, and start to talk to our students about both IPE and One Health and bring those ideas together. So how are we going to do something with this? You know, it's a great topic. Medical students probably get something out of it. How does it impact you as somebody who's interested in One Health, who does potentially zoonotic disease work, maybe not on a specifically clinically medical team? My argument is that a lot of the structures and the logistics of IPE work that the human medicine facilities have done really can benefit us in the One Health space and in the zoonotic space specifically. So this is what the CU Anschutz curriculum looks like for IPE. The medical students get this interprofessional content from day one. You can see the IPE orientation all the way up to their clinical rotations, with the hope that they leave there saying, I want to work in an interprofessional way, regardless of where I practice. However, we know that it takes a lot more structure and support to take, you know, these two first blue circles, the foundational education and the graduate education, and then turn that into, you know, us as professionals defining ourselves as interprofessional, and for the workplace cultures to be able to support that. So, you know, you probably resonate with this. You probably think of yourself as somebody who wants to work in the ways that I've just described, but those green box items sometimes limit your ability to do that. So to be able to actually deliver this kind of care and this kind of outcome, you need educational structures, both formal and informal, at the you know, the school level, the educational level, the professional educational level, and then in a way that's harder to make tangible in the culture and the policies of the place that you work, all while hoping that the learning outcomes of the individual and the health and systems outcomes of whatever service you work in start to improve over time. We also know that people are not going to come around to this idea immediately. You know, if you put them into an interprofessional team, some of the nuances on the way in which that team works are lost on that student initially. They just don't know what they haven't been exposed to. So it requires this sort of build of professional identity from, hey, let's talk about what it means to be in a collaborative workspace. Let's identify a problem that needs multiple disciplines to solve it. Okay, great. If you can do that, now let's take it into simulation. So there's no real patients, there's no real critical problems, but you have to talk with other people and make some of these problem-solving links yourself. And finally, let's put it into a work-based setting. So now you are a professional and you are asked to work in this way, you're rewarded to work in this way, and that socialization from sitting in a classroom learning about this to getting a professional identity attached takes some time and allows you to build on that over usually several years. One of the organizations that has done this well are our antimicrobial colleagues. They've really decided that they expect their antimicrobial practitioners or antimicrobial resistance practitioners, I should say, that they expect them to work both with interprofessional tenants and in a One Health way. And what they did is they basically took a bunch of different aspects of the work that was happening and labeled them in really clear ways, saying, this is the way we expect you to practice with these, interprofessional and One Health competencies. In our work, this is how it manifests. And then we hope that it will improve One Health outcomes at the end of the day and reduce antimicrobial resistance across a number of different settings and populations. You could sub in a number of different zoonotic diseases into this. I suspect that you could take almost all of these arrows in some capacity and extend them into the zoonotic space, change the outcome on the right just a little bit, but continue to hold your staff and your trainees to this level of interprofessional collaboration, of interprofessional practice, and the competencies I've described. We've tried to do that a little bit at Colorado State. I've been teaching in our One Health Institute now for several years. We have a certificate that really focuses on interprofessional education and was designed both for professional students, CSU employees, and graduate students at CSU across a number of different disciplines. Again, not exactly interprofessionality, but enough to get the right people to the table. We teach a truly interprofessional course where all of the different instructors have different backgrounds, all the speakers have different backgrounds, so trying to get at that curricular level. And then we work with folks who are actually doing this really well in the zoonotic disease space. So our colleagues at Minnesota, Florida, and Western, all of whom have veterinarian medical schools, have programs, I'm highlighting 3 here, that say, we think that having people who do interprofessional work and people who do One Health work working on zoonotic disease is really valuable. So University of Minnesota puts them through a zoonotic disease escape room using a lot of the educational tenets I've described. University of Florida visits family in their homes during they have several visits over the first several years of each of the professional programs. The students go on interprofessional teams and work on a number of different issues, zoonotic diseases being one. And then Western University does weekly zoonotic disease case rounds, inviting folks from all of these different disciplines together and asking people to solve these problems in a way that is structured around interprofessionality. I'll close with a little bit of research, and I want you to think about this, the findings of this research again within your own setting. We looked at a bunch of different universities that had medical and veterinary schools and talked to them about interprofessional education and One Health, and then did some informational interviews about how those things manifest within their campuses. And if you're not in an educational setting, I think a lot of these things apply to workspaces, to professional, sectors. So I think, don't get scared off because this was in academia. We grouped with themes and developed codes, as you do in qualitative research, and really came out with these 4 themes. I have just a couple of highlights from each of these themes. The definition I really love about IPE is not that two or more professions learning from each other, but it's this idea that every time we work interprofessionally, we're modeling, and you can see here, this flexibility, this adaptability, and this resourcefulness as we build relationships. So, while we have these fairly rigid ideas of definitions, the work that we want to do is actually very harmonious across a number of IPE and One Health spaces. We tried to look at where the overlap was between IPE and One Health. So we asked a bunch of these questions to our interviewees. And I want to highlight this one. Again, we got really lucky because we had the structures in place to talk with human physicians about their interprofessional experience and got exposed to what is a really well-researched and organized and funded section of human medicine and human medical education. But there's still a huge divide between people who identify as IPE trained and people who identify as One Health trained. And even though they want the same things, they don't know that. And that's still a huge barrier here. And one of the great things about interprofessional education is that it allows you to advocate for your ideas, for the value of your profession. And time again, we heard veterinarians and other zoonotic disease PhDs, folks like that say, yeah, we just don't know how to advocate for ourselves, or we don't see our students advocate for ourselves in these broader spaces. This is a challenging thing to do. I know you're probably doing the mental math, like how do you find time to get all these people from different backgrounds into the same space? And I'll be honest, nobody has really figured this out. Oftentimes in these medical schools, the IPE education classes are happening from 5 to 7 p.m. on a Monday, because that's the only time you can get all of those professions into one room. And that's not ideal from a mental health perspective, from a physical health perspective. So, are we really actually doing some detriment? Some people come out of those rooms being pretty, having a lot of animosity towards IPE just because it allows you to stay late on a Monday. So how do we figure out how to do this connecting work when there are so many barriers to do it in our already busy lives? However, I think all of you can find empathy with this. It has helped me to do all kinds of work because I am a One Health practitioner and because I believe and want to encourage the tenets of IPE. We know that modern medicine and all of the other health challenges that we work on, zoonotic disease, water quality, water availability, all of those improve when we have people working together. And really being able to work like this is just rising to the demand of the problems that we seek to solve. We heard that time and time again in our interviews. This is how problems get solved, and we think this is essential for their success as future professionals. So think about the people that you mentor and how this helps them. I'll leave you with what has impacted me as a veterinarian, as somebody who works in the One Health space, how IPE has really improved my understanding of my own competencies, the competencies of my team, and how I want to train the folks that are coming up after me. I think IPE really helps you to reflect on the value of your specific profession and how your teams come together and do the most important work. I think being able to name those core competencies, so things around value and ethics, collaboration, communication, teamwork, those are really important things to call out in your work that you do. You also can start to highlight these for your mentees. So looking at the practice that you have, whatever it is, and highlighting for people through the power of practice, hey, these are spaces where values and ethics are really driving the decisions that we're making. Here are places where communication and collaboration have been improved in the last 5 or 10 months or something like that. You can role model some of these things that, we all have people who shadow us, who watch how we interact with these. And you can do a systematic assessment. How easy is it to do work across all of these different disciplines? Most of us are not going to be organizing large professional programs, but these are some of the best practices in IPE. And what I take away from this is, I feel like as soon as I move away from One Health work, I start to lose some of that identity and I start to do things in a more traditional way because that's the easier way. It's easier to stay within a discipline, a silo, a profession, and not seek out other ideas. So the more touch points you can have across a practicum, a clinical experience across a profession, across a career, the more likely it is that you're able to then be a leader in this space and truly have a team that works in this way. So wherever you are, whatever institution, I would encourage you to find some places where the identity of being a One Health team, of being a One Health practitioner, where those could be strengthened and where you can start to really push your team to do all of their work in a way that puts those values of communication, collaboration, teamwork, values, and ethics at the highest point. You can be a champion of this, but there are other folks who really care about interprofessional education out there. Just look to your MD colleagues who are also doing One Health work. Talk with other universities and programs. I know CSU is really excited about doing research in this, and I think to do interprofessional education research in other places besides clinical medicine would be really cool. Think about how to recognize people who do this work like this already, and potentially are there ways to fund this? I think we've seen many groups get creative and find ways to make this sustainable. And then with whatever healthcare team you're building, whether that's preventative or at the emergency room where I usually spend my time, think about who's missing and how to invite folks who maybe haven't been part of that interprofessional team to the table. So in conclusion, we know that the work has to happen this way. And to do this work, we have to educate the folks who are coming behind us, whether that's in a formal way, in a graduate or professional education, or in all the informal and formal things that you do at your job site. How do we make sure that people are getting this throughout their time as a trainee? And because of this, how do we model this on a day-to-day basis? You are really the folks who have done the hard work already. You're sitting in this room. That isn't a guarantee. So I think taking some of these tenets and thinking deeply about how we can make it easier for somebody to identify as a One Health practitioner and somebody who works in an interprofessional way, if we can break down those barriers, our teams and our jobs and all the problems we are trying to solve will be better for that. With that, I'm happy to have any emails about this from a research or education perspective. There's lots of resources out there I'm happy to share. And I'm also happy to take any questions. It's like there's maybe one in the chat, but not for me. Anything there in the room?
Excuse me. I think what we will do now is have all of our first session speakers come up and take a seat. So that we can all stare at you while you answer our questions. So we have 10 minutes for questions.
Can you keep Claire on?
Claire
Claire
on.
You keep up her up there?
Are we able to?
I'll stand. I think we're good.
Well, yeah, we'll start with an online question.
So to Dr. Mayo and Allison, or doctors, how long do you see chronic infections last, and are the serotype-specific differences in viremia or chronicity? I'm sorry, chronicity.
Okay, well, so Bluetongue's really cool. It's very interesting. So viremia can be, in terms of being able to isolate a virus, can be up to 60 days, 60. So it's quite a long viremic window. This comes up all the time because PCR is not the same as virus isolation as a virologist. So PCR, you might want to take a guess how long that can be? Up to 7 months. Forever. So I want Dr. Allen to speak to the chronic cases, but in surveillance, when you're doing the active surveillance, you can actually identify that. And we have clients sometimes that are like, why is it still positive? Well, it's just the nature of the beast. And double-stranded RNA, this is a cool part of the genome, it's really hardy. So these are all things that are inside the animal, and then otherwise that can make it really long-lived, it seems. Eternal.
Yeah, forever. I think I'll just come at it from like a clinical science side, because that's one of the things that tips us off that we're dealing with more of a chronic case. So we have acute cases in hemorrhagic disease in deer, right? And they'll die very quickly within like 24 to 48 hours after being infected. And then we have our chronic cases, and these animals can live much longer, up to months. And so these are the animals that we're picking up on because they look wasted, meaning that they're very thin, right? Their body condition is terrible, and they're also very lame. And so these viruses, and again, Dr. Mayo and I were just like nerding out front here a little bit, but they really like the lining of blood vessels. So they attack the coronary band where all these fun little capillaries and vessels are causing lameness. So for us, when we pick up a lame, very thin looking deer, it's Wyoming. So right away we say this is probably chronic wasting disease. So that's a nice other fun thing we get to deal with. But we now know in some of these areas to also test. And because of PCR, and that's what we tend to use, it lasts for a long time. So sometimes it does become challenging just from like an overarching viewpoint to really nail into some of these. But because of the chronicity of the viruses on the landscape and because of some of these creatures we're seeing, we do think like with time, we're just starting to get animals that are just not dying right away because everything is evolving.
Hello. Thank you all so much. What an amazing morning. Thank you for being here. For the organizers, this has just been fantastic. My question is about one welfare. I hear that word sort of used almost interchangeably with One Health, and I'm just curious if anyone can comment on, is that in fad? Should we be using that? Does that mean something different?
Do you want it? I can. Yeah, good morning. Thanks for the question. You know, I don't know that it's something that we've brought to the state level and really thought about holistically across our agencies. I think we do it innately. You know, I think that is something that I can give maybe a couple examples. One example would be in foreign animal disease response, right? Highly pathogenic avian influenza specifically, that as we look at response to that, you know, we are considering, and it is in part of our objectives to consider the safety and welfare of our human responders, as well as the animals that, you know, we are responding to that are infected on a facility. So I think that in practice we're doing it. I don't know that we're preaching it. Right? I don't know that we specifically use that phrase, one welfare, but something certainly for us to maybe consider and, you know, adjust to. So I'll give it to Allison.
Yeah, I mean, I'm just going to be an echo box here, but we haven't used the term one welfare, but I think as you think about like the complex systems that we're trying to address, that we are looking at the mental health aspects of the people that are responding, but also impacted by the issues that we're addressing, and then the component of animal welfare and like how those really translate to each other, because poor animal welfare will impact mental health as well. And so I think you know, Dr. Baldwin already addressed that piece of it, but it's sort of informally ingrained into the way we are responding. But appreciate the comment and the question.
Should we be using One Health? It seems to be more in literature. I just see some presenters use One Welfare. What's the best term for us to really solidify around?
I don't know. Claire, do you have any thoughts on that?
Yeah, I think One Health is probably the broadest and best organized term. I mean, we certainly have both national and international coalitions who I think more commonly use the word One Health. I think the One Welfare, you know, group, to the best of my knowledge, really wanted to push the idea of, you know, this isn't just physical health. This isn't just diseases and ways in which the body is impacted by food and water and things like that. It's really this other level of mental stability, of ability to sort of work in a resilient way. And I think that just challenges people who work in the One Health space to continually ask, you know, who is at the table who can speak to that, who is representing those interests, and really continue to push that definition of health. We're not just looking for somebody who doesn't have a certain infectious disease, but, you know, if they have something like West Nile and they have long-term symptomology from it, who are the people that are going to be supporting the long-term mental health burden of that, and how do we bring them to the table as we're making as we're making West Nile virus decision making? I think it's just a push and sort of a continual encouragement to say welfare is part of health, and we are making sure that the right people are at the table when we do that work.
Hi, thank you all so much for these wonderful presentations. This might be like kind of a silly question, but I was just curious. When you're in the field doing like surveillance for BTV, and you're looking at carcasses and like collecting samples, are there still like midges on the carcasses, and then you're kind of doing double surveillance or collecting samples, or have they like fled the scene and it's just carcass?
So I don't do as much of the carcasses. Usually I don't find Chelocoides on them if I've seen them. But we've, in my PhD years, I actually did a whole study vacuuming cows. So, I mean, you do get abundance if you actively go to vacuum a cow. It's a practice done. The visual on that is just weird. But usually we're trapping Chelocoides, more in those traps, those CO2 traps, and it's dry ice that are in those traps to emit the CO2. But several semiochemical, I mean, the idea of attractants has been out there as like a long time. What might be more attractant than just CO2? But you know, light traps are also out there. But I don't typically see them on carcasses.
I mean, they're very small, you know, so you're out there sometimes, and if you're during peak, like dawn and dusk period, there's probably a potential, right? We normally don't ask folks to go out in the dark, though, to get some of these things. I think sometimes we just miss them because of their size, but they can get very swarmy. So yes and no, potentially. When I've gone out and collected carcasses, it's normally flies and stuff that tend to be my major problem, so maybe I'm not focusing so much. But I'm sure, depending on the weather and like what stage we're in, they're probably out there. I'm just not, you know, evaluating that effectively.
My name's Ray Soto. I'm from Adams County Health Department. And also, it's questions about Bluetongue virus. I was wondering, functionally, the serotypes that were discussed earlier, how do they differ in, say, their immunologic response? Is there any cross protection that's offered or that's seen between the different serotypes? And mainly, I'm kind of wondering, like, you know, since you see co-circulation of different serotypes in the same area at different times, and then emergence of novel serotypes, and then my other question was, I think Dr. Maggie, you talked a lot about or mentioned the co-infection within the vector, and then the generation of novel species. There is co-infection within the mammalian host also a possible time for reassortment. And then finally, I promise this is my last question. Is there I'm sure there has been vaccine trials or research looking into ways to prevent Bluetongue virus. Is there something that is close to being available that could be used for livestock? And if not, I think there's somebody on the panel that has a track record of very successful development of tools to get things like that out. So thank you.
Yeah, what a great question. So to speak to from a laboratory perspective, when we were doing virus neutralization back in the day to identify the serotype, you did get some cross reactivity. So there's potential, there's probably cross-reactivity, but not enough that we know of with that BP2 that, there's probably unique immunological responses for every single one. But there is, in the lab, there's some cross-reactions. So there's that. Yes, there are co-infection in an invertebrate and then co-infection in the vertebrate. I think there's likelihood that there's potential for reassortment in either host. In the lab, we were often wondering, was it more likely in the invertebrate or the vertebrate? And I think that question's still out there. I don't think we can definitively, with the studies we've done, say one way or another. But that hopefully answers that question to your lab. And we do get co-infections. So Molly Burton, she did find on one of her sheep farms 2 different infections. So that can also occur. The last one is to the vaccine. So the vaccine is an interesting thing. We've had killed and modified live vaccines. The big downfall for modified live is the potential they're not as modified. So could we have reassortment and actually be fueling the fire? So a lot of people have gone to killed vaccines. Now, if you look at the literature, it's sad. I mean, it's great, but it's sad that we're not using some of the novel, like there's a canary pox vaccine platform. There's a lot of different platforms, a subunit platform. The research's there, the market's not there. So we're going after killed vaccines. So I put up the European outbreaks from, the big one was 2006, right when I was starting my career in Bluetongue. Good time to get funding. The other two have been 23, 24 with BTV3. Still, I think the introduction of killed vaccines because of the market and the safety is what we're really utilizing and going after. But I'll stop there. I would love to hear Dr. Allen's. Okay. Okay. We good?
I have a question here, unless you're doing a question. Okay.
Thanks. This question is for Mr. Tripp. You mentioned all these great plague prevention strategies, and I was just curious, when you encounter communities that are wanting to jump straight to exterminate the colonies because their kids or their neighborhoods are up against these colonies, how do you, I guess, advocate for, persuade them to embrace these other prevention strategies rather than jumping straight to extermination? If you do, try to persuade them.
That's a tricky question. We focus a lot of our conservation around large, intact prairie dog colonies that can support all of these other associated species. And where we have the most conflict is potentially in more of the suburban and urban areas where we have a much more fragmented system, and those habitats potentially provide fewer benefits to other associated species. And it often falls to the local community to decide what they're wanting to do. So I don't know that I have a fantastic answer to that question, but it's definitely an issue with this suite of species that you either love them or you hate them, and there's very few people in the middle.
Okay, I think that will be our last question. Thank you to our panelists.
small mammals, and then as they grow into adults, will feed on larger mammals and give them different opportunities to both pick up a pathogen and potentially transmit it to a different host. And when ticks are looking for a host, they actually do some interesting behavior called questing. So they essentially climb up to the top of some vegetation and stick their legs out like this. On the ends of their legs, they actually have sensory organs called Haller's organs that help them detect hosts. And they kind of just sit here on the vegetation waiting for a host to walk by. And they generally hitch a ride whenever you make contact with that stalk of vegetation that they're actually on. So talking a little bit about ticks that we have in Colorado and some of the pathogens that they transmit. So one of the biggest ones that we have is the Rocky Mountain wood tick. What's interesting about this tick is it tends to be a high elevation tick. Makes sense why we have a lot of it in Colorado. And you can see kind of the distribution here of where this tick is distributed throughout the continental United States. And what's particularly important about this tick, Dermacentor andersoni, is that it can transmit Colorado tick fever virus. I'm not going to get into this too much, but just some basics on Colorado tick fever virus. It is endemic to Colorado. It is one of the more common tick-borne diseases in humans that we see. And the prevalence is likely pretty underreported due to the way that it presents in people, not everybody getting very serious disease. And also not everybody necessarily remembering if they were ever exposed to a tick. Another one that this tick, along with others in Colorado, can carry is RMSF, Rocky Mountain Spotted Fever. This is a bacterial pathogen. It's pretty rare in Colorado, and I just mention it here because the Dermacentor, genus of species, is pretty famous for transmitting RMSF, even if we don't get a lot of it here in Colorado. Another Dermacentor species we have here is Dermacentor variabilis. And this is kind of different from the Rocky Mountain wood tick in that it actually kind of prefers these lower elevations, and it's pretty widely distributed throughout the eastern United States. And it can also carry Rocky Mountain spotted fever along with tularemia, although both of those are pretty rare in Colorado in terms of tick-borne transmission. And this is what we'd expect a lot in Colorado, especially at the lower elevation areas. What you'll notice kind of is I can't see how well this is actually showing up here, but if you can see in Colorado where the distribution is, it's a pretty small yellow area. But I can tell you from personal experience, this does not actually reflect the distribution of this tick. However, it is the data that CDC has on this tick. So I'm going to come back to this later and why we're going to be working on trying to fill in that gap. Another one I wanted to talk about is the brown dog tick. So this is Rhipicephalus sanguinus. Also potentially carrying Rocky Mountain spotted fever, although it's a lot more common, and there are other areas that are endemic for this in the southwestern United States. But we do still see it, especially attached to hosts like dogs. And I've been talking a lot about hard ticks, but we also have something here in Colorado called soft ticks. So they are still in the same order that makes them a tick. However, they have a different family, and they operate pretty differently from a normal tick. Like a normal tick that you would run into when you're walking in the grass, it stays attached to you. I'm sure many of you have unfortunately probably had a tick attached to you. A soft tick does not stay attached to its host for very long. Their feeding is pretty short, generally 30 to 60 minute intervals, and they tend to actually live in the dens of their hosts. So small mammal dens, things like that. They'll live in those dens and then feed opportunistically on the hosts as they return to their den at night to sleep. And the reason we care about soft ticks in particular in Colorado is soft tick relapsing fever. So they can carry something called Borrelia hermsii, which is soft tick relapsing fever here in Colorado. And we will see these in this pathogen in humans, particularly in high elevation cabins which have rodent infestations. So the ticks are actually there living in the nests and the areas where the small mammals live. However, when people also are occupying those areas, especially low to the ground, they will kind of opportunistically feed on people as well. And people may not even know that they've been exposed to this tick because, as I mentioned, they tend to feed at night, and they also tend to feed in really short intervals. So you might not even know that this thing has come out and fed on you, which is really unfortunate. And this kind of has an interesting clinical presentation because after the initial fever occurs, there are some periods where you have no fever, it comes back, and so on until treatment. And then shifting a little bit, I also want to talk about some ticks that we do not necessarily see in Colorado, but we do want to keep an eye out for, and may carry pathogens that we see with travel-associated cases. So the biggest one, probably public enemy number one when it comes to ticks, is the black-legged tick, specifically Ixodia scapularis. You can see here, and this map is a little bit outdated, but you can see it's pretty widely distributed all across the eastern United States. And then there's also Ixodia pacificus all across the western United States. And you can see Canoralo here in this, for now, Ixodes-free region. And this is kind of a problem because, as you can see from both sides, we kind of have encroaching ticks. You know, on this side, we happily kind of have the continental divide, so maybe not super worried about that right now, but we are worried about the westward expansion of Ixodia scapularis in particular. And as I kind of mentioned, we are concerned about this westward expansion. In fact, last year, some of our partners in Montana actually found a Ixodia scapularis attached to a dog with no travel history in an eastern county in Montana. So this is the furthest west documentation, and literally every year it just seems to be getting closer and closer to the central United States and therefore Colorado. Very unfortunate. We still don't have any evidence of establishment in Colorado, so we have never seen this tick here, not attached to a travel-associated case, but we are definitely keeping an eye on it. And of course, one of the reasons we care mostly about this tick is Lyme disease, which we do get cases of travel-associated Lyme disease. However, we don't have evidence of its establishment in Colorado because we do not have any vectors in Colorado that are actually competent to transmit Lyme disease. But it is, of course, the most common vector-borne disease in the United States, and so always something that's on our radar. Another tick I wanted to talk about is the Lone Star tick. And as you can see its distribution here, we have kind of a similar issue where every single year it seems to be getting further and further west. And this tick in particular is really adaptable. And so definitely one that we're concerned eventually could make its way to Colorado and unfortunately bring all of its problems with it. One of those being alpha-galactose syndrome. That's been in the news a lot recently, and I'll talk about that later. Also carries ehrlichiosis. In terms of alpha-gal syndrome, this has kind of made headlines recently because unfortunately we had our first alpha-gal related death this past year, not in Colorado, but in a state where it is endemic. So how this occurs is kind of through the bite of a Lone Star tick. So they carry the alpha-galactose molecule in their saliva, and when they feed on a host, it can trigger an immune response. And then later exposure to that alpha-galactose, which is found in many mammalian products, most famously red meat. If you've heard of red meat allergy, it also goes by that name, but also cheese, dairy, things like that. And Lone Star ticks are a good example of how we might actually respond if we were to find one of these ticks in an area in Colorado where it was not travel associated. There's no travel history with the animal or person who found the tick. So this our team did a few years ago in response to a Lone Star tick. So what we'll actually do is go out to this site. We'll bring our drag cloths with us. I'll talk a little bit about how these function later. But essentially what we do is we take this drag cloth and put it all around the ground, all in the vegetation where you might normally expect to find a tick, and then look at the drag cloth. And this is what we would normally do to actually go out into the environment and see if we can actually find those ticks. I've kind of hinted at this already, but in the last several years, we've seen like unprecedented levels of tick expansion, and that can be for a lot of reasons. Primarily, it's to do with the movement of the hosts that the ticks actually feed on, and they kind of just hitch a ride, and wherever the host goes, they go as well. And this can occur for lots of different reasons, but obviously we have, as Dr. Mayo said earlier, climate variability with altered seasons. So ticks are pretty hardy. They don't necessarily come out when it's freezing, but even if it's a little bit above that, they can be pretty active. So shorter winters, less cold winters, things like that can definitely influence if an area is like habitable for certain species of ticks. Also land use changes, so increasing urbanization, changing things over to agricultural land, deforestation is a classic one, but also reforestation. So in some areas that might have previously been deforested and then the trees go back up, you have the hosts that return to the area, and those hosts often bring the ticks with them. I did want to mention a little bit about personal protection because this is a question that I get a lot. So how do people actually protect themselves from ticks? Well, number one is just to stay on the trail. The reduced vegetation is less of an opportunity for you to get a tick on you. But there are also a lot of other methods. Insect repellent, DEET, permethrin work really well. You can also apply permethrin to your clothes directly if you're going in like a tick-heavy area. There's some really great guidance on how to do that on CDC's website. In terms of proper clothing, when you're going into an area that you might find a tick, we'd normally recommend light clothes, definitely long pants, and then you want to tuck your shirt and your pants into your socks, just so that if there is a tick crawling on you, you have a better likelihood of actually seeing it before it like becomes attached to you. And then, of course, classic, just do a quick tick check when you're finished. Another question I get a lot is how to actually properly remove a tick. And again, there's really great guidance on this on CDC's website. But this is in particular, I think, an area where there's a lot of misinformation. Really the only safe way and recommended way to remove a tick is just simply by like cleaning the area off a little bit and then taking those tweezers and just like holding it as close to the skin as possible and pulling it directly up. Okay, so moving into the types of surveillance that we have currently done in Colorado, especially at CDPHE. So we've had a passive tick surveillance since 2022. I'm sure many of you guys are familiar with that and have participated in. If you have, thank you for your ticks. So this is ongoing, but some things about this program. So we generally get about 200 to 400 submissions per year, and they come from community members, veterinarians, some of you at LPHAs, et cetera, et cetera. The bulk of these submissions are dermis interspecies, so the two that I introduced kind of in the beginning, which is what we'd expect, but we do occasionally get a little more exciting species. So we get some Rhizocephalus, especially that are attached to animals. And then we've also gotten some soft ticks as well, which is interesting. We have a pretty good distribution of like where these samples actually come from, which is nice to kind of give us an idea of what ticks we might find. I'm going to kind of skip over most of these. So in the passive tick surveillance, one of the big things that we're doing is trying to improve ongoing collaborations. And one of the ways we're actually doing this is we recently submitted a grant with some partners at CSU to actually test ticks from domestic animals in Larimer County. So this is another method of active or passive tick surveillance. And then this year, I think this is maybe the most exciting thing when it comes to tick surveillance. We actually received some money from ELC this past year to start an active tick surveillance program. And I'm sure many of you have heard about this or gotten an email from me. So what we're going to be doing is actually training people within LPHAs and also academic partners to go out, use these tick drags, actually collect ticks directly from the environment. And then we're going to be able to take those ticks and actually send them to CDC directly to be pathogen tested for Colorado tick fever virus and other endemic bacterial diseases in Colorado. And this is really exciting because it kind of allows us to fill in those gaps that I was talking about earlier when it comes to what ticks we have, where they are, and what times of year they're most active, and also what types of pathogens that they might be carrying. And so far, we've already got a lot of people signed up for this. And if you are one of these, please come introduce yourself to me afterwards so I can see your face. That'd be really nice. And if you are not a part of this program, but you would like to be, also please come talk to me. This program is going to be going until 2028. And over the next several years, we're going to be working on building out that initial capacity and then hopefully maintaining it past 2028. So if you are interested in doing tick surveillance, please contact me. Here is my email, and then also you can contact the state medical entomologist, Chris Roundy. So I kind of talked a lot about ticks, but what I kind of just wanted to reiterate is that Colorado is endemic for several tick-borne diseases. Invasive ticks are a growing concern, and one of the primary things that we hope to kind of look at with the active tick surveillance program. We've had a passive tick surveillance program for several years now. It's been very successful, and we're hoping to kind of expand that out even more in the coming years. This year, we're launching our first active tick surveillance program and including pathogen testing, which is really, really exciting. And then this pilot program, like I said, will run until 2028. So even if you're not signed up for this year, we can start working to get you guys trained up for next year. And that's all I had.
Thank you, Cassie. Our next speaker is Dr. Erin McGrath. She serves as the Assistant State Veterinarian for the Colorado Department of Agriculture. She has leveraged this experience to enhance Colorado's emergency preparedness and disease outbreak response strategies. She's dedicated to protecting the state's livestock and food supply through close collaboration with producers, veterinarian, and industry stakeholders. And today she's going to be talking about the emerging problem, New World Screwworm.
Thank you, Tracy. Okay. All right. Good morning, everybody. Thank you for having me here today. As you heard, I have the pleasure of talking to you about what has maybe disturbingly become my favorite topic, flesh-eating maggots, otherwise known as New World Screwworm. There we go. A little bit of a lag. Or as its scientific name means, man-eater. So we'll dive right into this. So this is a zoonotic pest, so as you all know, it can affect any warm-blooded animal, which unfortunately does include humans. And what sets this species of maggots apart from other species of maggots is that it feeds off of living tissue or living flesh, whereas other maggots only feed off of dead or decaying tissue of wounds and carcasses. So this has the potential to cause really extensive tissue damage and can be potentially life-threatening. This pest historically has been endemic to South America and areas of the Caribbean and really prefers a warmer climate. And this here is an overview of its life cycle. So it starts with the adult flies, the male and the female, mating. And then that female fly will seek out and lay her eggs on a host. And then within about 12 to 24 hours, those eggs hatch and the fly enters the larval stage. And this is pictured down here. Sorry, my pointer doesn't seem to be showing up well. But down in the corner there, that is the larval stage. That's a full-grown third stage larvae, and that's what is essentially our flesh-eating maggot. That is the culprit that causes all of the tissue damage. That larval phase has 3 stages within it, and it takes about 5 to 7 days to complete development. And then once it does, it falls off of the host, and then it pupates in the soil. And that pupal phase takes about 6 to 8 days typically, although it can be longer. And then the adult fly will emerge, and the cycle starts all over again. Now, this entire life cycle is weather dependent, and all of the phases within the life cycle are temperature sensitive. So they are killed by freezing temperatures, which is an advantage that we usually have here in Colorado, although maybe not this last winter. And then the flies themselves are inactive at temperatures under 65 degrees Fahrenheit. The larvae themselves are also temperature sensitive, although this can be a little bit variable because they can produce their own heat when they're feeding in mass. And then the pupal phase also is temperature sensitive and can't survive sustained temperatures under 46 degrees Fahrenheit, although how long these temperatures have to be sustained for is a little bit variable based on other weather factors as well. These are the adult flies, so they're slightly larger than your average housefly. They have a bit of a metallic green body with several black stripes across their back, orange eyes, a little yellow face. The male fly only lives about 2 to 3 weeks at a time. The female flies usually only live about 10 days, although they can live a little bit longer. And these flies generally don't cover long distances at a time when they fly, and they don't fly for long periods of time. They do prefer to stop to rest and feed and groom. And then one thing that's really, really important about these flies, and I'll touch on this a little bit more later, is that the female fly only mates once in her lifetime, and I'll get into why that's important. And then how far these flies will fly over their lifetime is a little bit variable and depends on host density in the area they are in. So in lower host density areas, they will fly further over their lifetime, seeking a host. So populations at risk include any animal or any person who has a wound or who has recently had surgery. We just talked about ticks. These wounds that can attract these flies to lay their eggs can be as small as a tick bite, so it really doesn't take much. And they'll also lay their eggs on normal body orifices, and they're really particularly attracted to the newborn umbilicus, which is what is pictured here as a calf umbilicus. So if you're wondering what to look for when looking for an animal that might have a screwworm infestation, unfortunately this isn't in the US currently, But animals that are affected might act abnormal. They might act irritated, agitated, or they might act depressed. They might separate from the herd. They might go off of their food, have decreased milk production. And of course, you're going to be looking for any animals that have wounds, particularly enlarging or odoriferous wounds. And I'm sorry for the graphic photos here. I always do seem to be giving this presentation around food time. At least you're not actively eating at the moment. But a veterinarian in Central America who had some experience in treating these cases reported that these wounds are one of the foulest odors that she has ever smelled. So that's also something that might cue you into that this is something a little bit abnormal. And then, of course, you're going to be looking for any wounds that have active maggot infestations. Now, because these maggots feed off of living flesh, they do tend to burrow really deep within those tissues, so they're deep in those wound beds. And so they might not be as apparent as you might think, and sometimes you might just see some subtle movement within that wound bed. And then affected wounds also might be co-inhabited by other species of maggots, and you might have different populations up on the surface of those wounds. And then the female flies lay their eggs in a characteristic shingle-like appearance, which is what is pictured down in the corner there. Just another thing to keep an eye out for, because those can be visible on wound edges. And then I did want to touch on a little history here, because again, this is not in the US currently, but it did used to be here. So it was eradicated from the US in 1966 with the use of the sterile insect technique, which I'll touch on a little bit more here shortly. But because of its persistence in Mexico, the US did still experience incursions into the 1970s. And at the time, this did prompt US and Mexican collaboration to push those screwworm populations back into southern Mexico by 1986. And then those eradication efforts continued, and those populations were pushed back through the remainder of Mexico, back through Central America, and by 2001, they were pushed back behind the Darien Gap here in Panama. So the sterile insect technique, this is a really brilliant technique, and this is what was used to achieve those eradication efforts. This actually was conceptualized in the 1930s, but then implementation was delayed due to World War II. But what this involves is the strategic release of irradiated sterile male flies. And these sterile male flies will seek out a mate with the natural fertile female flies, and their union results in unviable eggs. And if you remember, that female fly only mates once in her lifetime. Now, she can lay multiple egg packets, but she only mates once in her lifetime. And that's really what's key for this technique being successful. And with this technique, these fly populations can be eradicated in a pretty short period of time or over just a few life cycles. One thing I forgot to mention on the life cycle slide, in optimal weather conditions, their life cycle can be as short as about 18 to 21 days. So their populations can be eradicated in a relatively short amount of time through this technique. And then this technique is what has been used to maintain what we call a biological barrier down in Panama. And that's been maintained historically by the Panama United States Commission for the Eradication and Prevention of Screwworm, also known as COPEG. And that's the COPEG facility there down in Panama that produces these sterile flies. So to touch on a little bit of history again and some of the outbreaks that have been seen here in the US, in 1972, there was an incursion out of Mexico during favorable weather conditions where screwworm-affected animals and flies moved north. Multiple states were involved in this outbreak. Texas in particular was hit quite heavily and had about 90,000 cases that year, whereas the year prior they'd had under 500 cases. And this single incursion cost the U.S. livestock industry about $372 million. So this is hugely impactful, very, very costly. In 2016, in Florida, they had a much smaller outbreak. This affected their endangered key deer population. About 136 key deer and 9 domestic animals were involved in this outbreak, and the source of this outbreak was never actually identified. But despite this being much smaller, it still reduced that key deer population by about 15% and still costs about $3.2 million just in eradication efforts alone. This is looking at another incursion in 1976 that occurred in Texas. And what's really interesting about this outbreak this chart, is that there's an inflation adjustment. So this is looking at what an outbreak of this scale would have cost in modern times. So looking at that second column bottom row there, in 1976, it was estimated to have cost the Texas economy about $329 million. If this had happened in 2024, they estimate it would have cost about $1.8 billion. So again, very costly, very impactful, not something we want to deal with again. But unfortunately, it is approaching our borders and it's creeping north. So why we're talking about this today is because in 2023, that biological barrier that had been maintained down in Panama was breached. And since that time, we have seen an explosion of cases moving north up through Central America and into Mexico. Since the start of this outbreak, there have been over 164,000 cases reported in animals. Over 19,000 of those cases have been reported in Mexico alone. Multiple species have been involved. Cattle have actually been the most commonly affected species, and they have been followed by dogs. There's a lot of stray dogs down in this area. And then 21 Mexican states have been impacted by this. So this is looking at a map of Mexico and where we're seeing a lot of these cases. And then to touch on some of the most recent cases and also the cases that have been closest to our borders, between September and November, several cases were seen in the state of Nuevo León. Now, these cases were all movement related, so they all involved single animals on shipments coming out of southern Mexico or Central America that had screwworm infestations, and then were moved into Nuevo León. These affected animals were identified pretty immediately upon arrival inspection. They were treated, and then the USDA conducted surveillance in the area and also implemented sterile fly release in the area. Unfortunately, no spread was seen from these cases. One case to highlight is the October case. What was really interesting about this case is that this calf was actually pre-treated prior to movement, about 72 hours before movement, with an injection of ivermectin. And so when this calf and its screwworm infestation were identified upon arrival inspection, all of the larvae were actually dead or already dying, so none of them were viable to continue the life cycle. So just a good example of a pre-movement protocol being effective here. Now, unfortunately, since December, we are starting to see or have been seeing non-movement related cases in the northern state of Tamaulipas, which does border Texas. And sorry, I'm losing my pointer here. But so these cases are animals that are just in the area that we're getting reports of them having screwworm infestations. And why this is important and concerning is because prior to this, the only established fly populations in Mexico that were self-sustaining were in southern Mexico, but now we're seeing a self-sustaining fly population in that northern bordered state of Tamaulipas. There are currently import restrictions in place for animals coming from Mexico into the U.S. You might have heard this did make national news, but as of May of last year, they did ban all importation of livestock through the land border ports from Mexico into the U.S. Horses could still be imported by air after completing a pretty rigorous pre-movement inspection and treatment protocol. And then there are some different criteria for other species to be moved here as well, but all livestock are banned. So this is really impacting trade at the moment, and we're impacted in Colorado here by this as well. Now, there has been talk about a phased-in reopening of the border, starting with the westernmost land border port. That one is about 800 miles from any active cases at the moment. That was just actually announced last week that they're considering this, so it hasn't actually been actualized yet. But hopefully that'll be coming in the near future, and that'll just be for the movement of feeder cattle. You might have heard recently of a horse that was imported into a USDA import quarantine facility in Florida that had a New World screwworm infestation. This horse actually came from Argentina, so it was not from the current outbreak zone, but from an endemic area. And it was identified very quickly, again, treated routinely, no spread was seen from this. But this is just another good example of some existing protocols that we have as another layer of defense against this pest. There also was a human case reported in the US last year, which some of you may have heard of. This was an isolated travel-related case of an individual who went to El Salvador and then returned to Maryland and was found to have a screwworm infestation. This also was caught quickly. The patient was treated, and then the USDA did conduct surveillance of a 20-mile radius around where that individual was, and no transmission was observed. But this is just a good reminder that this does affect people, and to be vigilant if you're traveling to a screwworm-affected area. CDC has released recommendations for travelers, which are very similar to the recommendations for personal protection with ticks. You can find full information of that on the CDC's website. This here is a picture of a man's leg with a wound that has a screwworm infestation. So again, this affects people. Within the outbreak zone, since the beginning of the outbreak in 2023, over 1,600 cases of screwworm infestation have been reported in people, and that has resulted in 7 deaths. Unfortunately, one of those deaths was a 19-day-old baby who had an umbilicus infection. And then we do have to keep in mind that a lot of these cases in people, that this is probably underreported. A lot of these cases that are observed are in areas that are very rural or remote or have really limited access to healthcare. So there's probably far more cases than we actually know of. So what's being done for this? There's a lot of work being done to try and stop this northern progression in Mexico, and then eventually try to re-eradicate it out of Mexico and Central America, and also prevent it from reaching our borders. USDA is leading these efforts, both in Mexico and here domestically, and they have partnered with multiple state, international, and other national agencies. Originally, at the start of the outbreak, they invested about $110 million towards these eradication efforts. That value has grown substantially, as you can imagine. But their eradication strategy relies on 3 key factors. So increasing outreach and education to improve our surveillance, or our passive surveillance, so people can identify this and report it when they see it. International animal movement restrictions, which I touched on, and then the use of that sterile insect technique. So COPEG can ramp up production to 100 million flies a week during an outbreak, which sounds like a lot of flies, but unfortunately is not enough. So they have been attempting to establish a barrier in Mexico, again, to stop this northern progression. They've not been successful with that so far, as you see, and part of the problem with that is we don't have enough flies. This is a much larger area of land to cover across Mexico than where that barrier had previously been maintained down in Panama. And historically, for those successful eradication efforts, we actually had around 500 million flies a week that were being produced at that time. So they are trying to increase our fly capacity again and eventually reach that 500 million flies a week. How they've been doing this is they have opened several dispersal centers in Mexico and domestically down at the Texas Air Base. So last year, a dispersal center opened in Tampico and another in Tuxtla, and then earlier this year we had a dispersal center that opened at Moore Airfield Base in Texas there. And then there's 2 production facilities that are also underway. So they have a fruit fly production facility that exists in southern Mexico here in Matapa that they are converting into a screwworm production facility. And then they're in the early planning phases of a production facility here at Moore Air Base as well. That Matapa facility hopefully will be operational this summer. And when it is, it'll be able to produce about another 100 million flies a week. There's not a definitive ETA for the Moore Airfield Base production facility. They're hoping by summer of 2027, so it's going to take us a little bit to get to that full 500 million fly capacity. But once all of these facilities are online, that should be reached. One thing to note, since they don't have enough flies currently, they really have to be strategic with their fly dispersal. And so they have what USDA terms a fly dispersal polygon, which is what is outlined by this green shaded area here. And with the northern progression of the cases that we've been seeing in Tamaulipas, they've now shifted that fly dispersal polygon into Texas a little bit. So they are releasing flies about 50 miles into Texas. There is a lot of surveillance being conducted in the area. This is going to highlight fly surveillance, but there's a lot of surveillance being done with wildlife and with animals as well. All of these orange squares represent fly traps in Mexico, where they're actively catching and surveying flies in the area. But what's not shown here is that we have traps all along the US-Mexican border here too. So in Texas alone, since June of 2025, US has trapped and identified over 37,000 flies. Now, as I noted, that sterile fly dispersal polygon has shifted into Texas now. So because of that, they've started dyeing the flies with a fluorescent dye so that they can be differentiated from wild flies. So if we're catching them in our Texas traps, we know if we have a wild incursion or if these are just the sterile flies that have been released. So prevention for this pest, which obviously is really important and hopefully is not something we're going to have to deal with ever, but really relies on 3 key things. So animal monitoring is really key, inspecting all animals. Previously, when this was in the US, they had herd riders who would go out and daily inspect the herds looking for wounds and evidence of screwworm infestation. Now, that's a really challenging thing for our producers to re-implement. You know, having employees is challenging in agriculture in general right now. So they are looking at other technologies to kind of supplement this, so things like detection-trained dogs or the use of game cameras and drones. So there's a lot of research being done in this space to see what we can do and how we can improve this. Also making management changes, so eliminating or changing the time of wounding procedures, doing it in cooler weather where you're less likely to get flies and to get maggot infestation, and then also reducing the potential for wound development, so removing sharp objects, checking pens for things that can cause wounds, treating all umbilical cords and wounds with an approved insecticide, general fly control, etc. And then also reporting. Very, very key to being able to prevent this is being able to identify it, treat it, and try to contain it as early as possible. And this is a reportable disease here in Colorado in animals. So if you have an animal that has a maggot infestation, it does need to be reported to our office or to the USDA area veterinarian in charge. And we do request photos. Again, sorry for the gory photos. But we do request photos of the maggots in the affected wound and then of maggots after removal, which is what is pictured here. And then these maggots are sent to the National Veterinary Services Laboratory, and that is where they identify them. And they also are capable of identifying flies. And then we do have some specific sample handling and submission instructions, and we have a myiasis case report form on our website where you can report this through as well. For treatment, I'm going to kind of try to breeze through this because I'm getting a note that I'm getting close on time. But general pain management, wound care, but also spraying larvicide in the wound, trying to encourage those larvae to self-expel. And then really important, what I want to touch on is that FDA is trying to ensure we have animal medications available to us because this was eradicated so long ago. All of the drugs that were used historically actually are no longer available to us. So they've been working on granting emergency conditional approval of certain medications as well as granting emergency use authorization. And I won't go into great detail there, but you can find more details of that as well as what drugs have already been given approval on their website. And then here in Colorado, we've been working really hard on our own state preparedness. We did contract with a subject matter expert to draft our state specific response plan, and that is in its final phase of development. We are working to align it with the USDA's playbook, which they just released their second draft yesterday. And then we've also been working on integrating some insights that came out of a multi-agency workshop that we held back in December with a communications and operations focus. And then just to make you aware of some resources out there, we do have our own Screwworm webpage on our website, and USDA has their kind of one-stop shop federal government resource, screwworm.gov. These are great resources if you haven't checked them out. Everything you need to know, general information, sample submission and handling, updated situational case reports and sit reps and everything are all there. And I guess that's it. You. Oh, thank you.
Thanks, Jessica. Okay, our last speaker for the session is Emily Gallichotte. She's a research scientist in Dr. Greg Ebel's lab at Colorado State University. Her background is in molecular virology and adaptive immunity, but now studies arboviruses and virus host interactions in mosquito and avian hosts. And today we'll be talking about St. Louis virus encephalitis virus surveillance. And we're getting your pointer ready for you right now.
All right, thank you, everyone. So I'll be talking about St. Louis in Colorado. So this is just a quick overview of what I'll be talking about today. And so to start, I'm talking today about St. Louis encephalitis virus. It is a orthoflavivirus in the family Flaviviridae. It has an 11 kb genome with the structural proteins at the start, followed by all of the non-structural proteins. St. Louis is genetically related to West Nile virus and Japanese encephalitis virus, whereas our other mosquito-borne flaviviruses are here, and some of those tick-borne flaviviruses down here. St. Louis is maintained in nature in this enzootic cycle, where Culex species are the enzootic vector, and small songbirds serve as the amplifying hosts, and occasionally humans and other mammals become infected, but only serve as dead-end hosts. And in the US, the mosquito species that are the most important are Culex pipiens, Culex tarsalis, and Culex quinquefasciatus. And there's many different birds that can serve as hosts, but especially birds like sparrows, finches, robins, and doves are all important in maintaining this virus in nature. So St. Louis was initially discovered in St. Louis, Missouri in 1933, where there were over 1,000 cases in people. And this is just showing up until 2001, from that initial discovery in 1933, some of the really large outbreaks that occurred in America. So there were some really big ones in Texas, a couple in Florida and California, but just to make the point that St. Louis was endemic really throughout the US. And while there's not great yearly CDC data in this time period, in this 30-year window, there were almost 5,000 cases throughout the whole US, with almost every state reporting cases. And so just to appreciate, again, it was spread throughout the whole country, causing disease in humans up until the late 1990s. And so in 1999, it was announced that St. Louis had made its way to New York City. Tracy McNamara was the chief pathologist at the Bronx Zoo at the time and had noticed there were a lot of dead crows. This was in August in 1999, and seeing birds, including exotic birds, at the zoo exhibiting encephalitis. And so it was announced in the Lancet in September that St. Louis was now here, causing this outbreak in humans. And thanks partly to Dr. McNamara really insisting that this seems different from St. Louis and what they had previously seen. A few weeks later, it was then updated that while they initially thought it was St. Louis, this was actually a new virus, and this was West Nile that had been introduced to New York. And there's a great essay about this from Carl Zimmer if you're interested in learning more about the history of this introduction and the role that Tracy and the zoo played. So in 1999, West Nile was introduced in New York, and it very quickly spread throughout the country. So especially by 2002, 2003, it had wiped through, had made its way to Colorado, and by 2004 it was on the West Coast. And when we look throughout from 1999 to 2024, it's really established itself and is endemic throughout the whole country, with almost every county reporting human or non-human cases. And so as West Nile made its way through the country, it really seemed to displace St. Louis. So there's not great St. Louis data up until this point, but starting in 2003, it's reported. And so again, it was averaging over 100 cases a year. And by 2003, there were 49 cases, and it very quickly kind of plummeted down to the teens. And so West Nile pushed St. Louis out and established itself. And while I've showed that during this time period, St. Louis was present in North America, importantly, it was also circulating in Central and South America as well. So while the scale of the outbreaks in humans are much smaller than what was seen in North America, there have been many outbreaks, especially in Argentina, causing disease in humans, a couple in Brazil and Peru, and while not shown here, the virus has been detected and isolated, and sero surveys have shown that birds, mosquitoes, humans have been infected. So the virus has really been endemic in Central and South America during this time period as well, where West Nile never really established itself the way it has in North America. So in 2014, St. Louis was detected again in Arizona, and some phylogenetic analyses found that it was actually virus from Argentina that had kind of bounced around to Brazil and came back, that was reintroduced to Arizona and then spread to California. And importantly, these follow these bird migratory paths. So birds serve as the vertebrate reservoir, and birds are present here, and it seems that birds, or a population of birds, brought this virus back up to North America and introduced it into Arizona. And so going back to this graph, now in 2014, when the virus was reintroduced, we can see the vast majority of human disease cases in the US are in Arizona and California, compared to before where it was spread really throughout the whole country. They made up a very small fraction of those cases. And so just showing where those other cases are, again, most are in California and Arizona, but there's also been 9 cases in Texas, a lot of the Southeast, but even places like Pennsylvania and Washington have human disease cases. And this is not travel associated, this is local transmission. So that's the history of St. Louis. I'm now going to talk about our West Nile testing that we do in the lab. So for most folks in this room, you probably are aware that Colorado is kind of an exceptionally bad place for West Nile. We have some of the highest human neuroinvasive disease incidences in the country. And so the EBO lab at CSU has been doing mosquito surveillance testing for West Nile since 2013. And this is with many different partners in the city, county, VDCI, which does all of our mosquito trapping, the Raptor program, which I'll talk about, and CDPHE as well. And so on the right, this is just a map of Fort Collins. It's divided into these 4 quadrants, and each of these symbols is a trap location. And importantly, we've been using these exact same trap locations since 2013. So we have this consistent data in these same sites over 10 years now that we have data from. So for the actual testing itself, VDCI sets traps, collects the mosquitoes, pools them by species. We in the lab only test Culex pipiens and Culex tarsalis mosquitoes. They bring us these pools of mosquitoes, we homogenize them, spin them down, and then test the supernatant for West Nile viral RNA using qRT-PCR. And I'll just walk through a little bit of the type of data we get from this. So one of the first things is mosquito abundance can vary really dramatically year to year. So 2023, for folks that were around and remember, it was a really wet summer, and we had really high mosquito numbers. Whereas thankfully 2024 and 2025, we've had below average abundance of mosquitoes. We can also look at the pooled infection rate, so what % of those mosquitoes are infected with West Nile. And you can see this varies a fair bit by year as well. And when we put these two values together, we get the vector index, which is the relative abundance of infected mosquitoes. And this is important because it quantifies transmission risk to people. So if we have those two values together, we can see 2023, again, was a high abundance and higher than average infection rate. 2024 was very low for both. And 2025, while we had a really low number of mosquitoes, a lot of them were infected. And so kind of anything in here is this high vector index. And importantly, this correlates really well with human disease cases. And so this is in Larimer County. In both 2025 and 2023, we had over 50 cases. So even though the kind of numbers and infection rates in the mosquitoes were quite different, they both led to this high vector index, which correlates with disease. So that was West Nile. When we get back to St. Louis, it hasn't been detected in Colorado since pre-2000s. But our neighboring states do have it detected in either mosquitoes or humans. Colorado, it's a West Nile hotspot. They use the same mosquito vectors and birds, which we know there's abundant of both of those. And it was already talked about, viruses are moving for various reasons. And so starting in 2024, we added St. Louis testing to our mosquito surveillance. And so this is just adding the St. Louis primer probes to this dualplex assay, and it's using the same primer probes that is used in the triplex that a handful of states use. And so it's really minimal additional cost and effort, and yet we double the amount of data that we get. So here's now showing, again, a map of northern Colorado, but expanding. So in the EBO lab, we also have sites in Loveland and Berthoud that we test. And again, while our mosquito numbers were low, in 2024 was low for West Nile and very high for West Nile in 2025, we detected a single positive St. Louis mosquito pool in 2025. Brian Foy's lab at CSU also has a mosquito surveillance program they've been doing the last 2 years. And while it includes some regions in Fort Collins as well, It also expands east to areas like Windsor, Greeley, and Evans. And these have really different land use, human density, types of land, and so we get a lot more data. And they had very similar trends in terms of mosquito numbers and our West Nile positivity year to year. And they detected 4 additional St. Louis positive mosquito pools in 2025. And I will say we went back and retroactively tested a subset of samples from 2023 from both sets of these sites and did not detect any positives for St. Louis. So this is now showing where those actual St. Louis positive pools are. So this was the one in Fort Collins that the EBLE lab detected, and then the additional ones, and there's 2 sites here as the 5th one. And Claire Stewart in Brian's lab noted that the Poudre River kind of generally follows this diagonal path through town. And so maybe that's interesting, we're not sure yet, but it was pointed out. So these are just a little more info on those 5 pools. And one thing we noted is that they were detected much later in the season. So West Nile, especially this last year in 2025, we're detecting West Nile positive mosquito pools in June. And we only detected St. Louis later in August. We detected it in both Culex pipiens and Culex tarsalis mosquitoes. And of these 5 pools, 2 of them were also positive for West Nile virus. And we think it's unlikely that there's individual mosquitoes that are co-infected, especially because these pools have up to 50 mosquitoes, but more likely that the areas that are hotspots for West Nile are probably also just hotspots for St. Louis because they use these same mosquitoes and birds. So this led to a press release by Larimer County just informing the public that St. Louis has been detected here. So we also work with the Rocky Mountain Raptor program and test bird samples every summer for West Nile. And about 10 to 15% are positive for West Nile any given year, and we have not detected St. Louis in these last 2 years. These are the most common bird species that we test there, and that's pretty consistent year to year. And while none of these have been positive, a study from Argentina over this kind of many-year time period tested a bunch of different raptor species. St. Louis is endemic there. And they found a handful of birds, including ones that we have here as well, have antibodies to St. Louis. So while we haven't detected it in raptors yet, we think if it really does establish itself, we might start to find it here as well, and we're at least prepared to detect it in these birds. But importantly, we have found evidence of St. Louis in the actual avian reservoir as well. So Jenny is a PhD postdoctoral fellow in Angela Bosco Louth's lab. And last summer, she collected 20 sparrows and found that one of them have antibodies for St. Louis, so 5%. Kind of similarly, Michelle Savrin is a DVM PhD student shared between Brian Foy and Greg Ebel's lab, and found that in a separate group of both sparrows and house finches, 20 to 40% have West Nile antibodies. So just as an example of a virus that's very endemic with a bad year last year, we can expect pretty high seropositivity rates. And so we haven't done it yet, but we'll now test these samples for St. Louis as well, just to see if there's more evidence or to better understand how many birds have evidence of St. Louis infection. So the virus is here. We now want to try and better understand where it came from and where it's spreading. And so we can use phylogenetics to do that. So St. Louis, unlike other viruses like West Nile and even Zika, is very understudied. So there's fewer than 600 sequences available. Of those 600 sequences, only a third of them are post-2013, so since the virus was reintroduced. And of those, 3/4 of them come from this one study that sequenced viruses from this mosquito surveillance, primarily in California and Arizona. So we have a lot of information about the virus circulating there, but very little data on virus in other locations. So as part of this project, we also wanted to expand and hopefully fill in those gaps and collect samples from other places. So late last summer, there was also a single positive pool in Durango. So we were able to get that sample, and then we received samples from collaborators in Nebraska, Lubbock, Texas, New Mexico, and then a bunch of different sites in Utah. So this is showing of those publicly available sequences, the genome, again at the top, and each of these lines represents a different sequence that's available. And you can see that for almost half, they have the full genome available. But for many of them, they only have the envelope gene. And so we chose to just sequence the envelope gene as well, partly for cost reasons and to be able to compare to all these other sequences. So here's just zooming in on the envelope gene. It has these different domains, but importantly, that's what covers the entire surface of the virus. So this is what binds to host cells, it's what your immune system recognizes, and you'll accumulate mutations there. So we can learn a lot from the envelope. So St. Louis has 8 distinct genotypes. I have them color-coded. There's also clades within them, which I'm not going to get into today. And this is just a maximum likelihood tree. And importantly, only genotypes 1, 2, and 3 are known to cause disease in humans. So a lot of these other sequences come from mosquito samples. And looking at the sequences from genotypes other than 2 and 3, you can see that genotype 5 and genotype 1 used to circulate in the US, including a sample from Colorado back in the 1960s. And the other genotypes are generally in Central and South America. And importantly, these sequences are from 2013 and earlier. I now want to zoom into genotype 2. So this circulated in the US until 2003. Part of this is limited by the sequences that we have available. And again, unlike other viruses, there's not necessarily a ton of surveillance and sequencing being done. But this was the original virus in 1933. It was circulating in a lot of the US and then places throughout Central America. There's 2 really common lab strains that are both genotype 2 from Florida and Texas, and I'll use these later. But also when we were doing this sequencing, we found that there's 2 of these contemporary sequences, one from Nebraska in 2022 and Texas 2025, that group within genotype 2 really close to this virus that was detected in 2003. And so to us, this was surprising because it hadn't been detected since 2003, and we were trying to understand where these viruses maybe came from. And just last week, a colleague at Baylor in Texas went back and sequenced samples from Texas from mosquitoes going back from 2009 to 2024 and found that genotype 2 has actually been present in Texas that whole time. So maybe it wasn't quite as displaced as we thought. And so that was kind of validating for the results we had as well. But I then just want to focus on genotype 3 because that's the majority of this. So these are all these sequences here in green. And again, most of these come from those sequences from California and Arizona. But if we first just focus on the top part of this tree, this is the virus that was reintroduced from Argentina. So again, the virus was in Argentina and Brazil, and it was then brought by birds, we assume, to North America. And that's what all these sequences, and really all of this part of the tree is those sequences. What was interesting to us, though, is that 4 of the sequences from northern Colorado, including the Fort Collins one, grouped together, and they're more closely related genetically to the virus in Argentina in 2013 than the virus that's currently circulating in Arizona and California. The one Durango sample groups here, and geographically that maybe makes sense. When we focus on the rest of the tree, again, these are almost all Arizona, California sequences, and a bunch of the other sequences we generated also group here. So from Utah, New Mexico, Texas, Nebraska, and then that 5th northern Colorado sample from Windsor groups here as well. And so it seems that we have what I'm just calling US genotype 3 in northern Colorado and that more Argentinian-like genotype 3. So as I just said, we have this kind of US genotype 3 that we know was introduced and has been detected in all these states. And then starting in 2025 only, we've now detected this more Argentinian-like genotype 3 that's present in states that have the other virus as well. And so we then wanted to characterize these viruses and see how similar they are actually in the lab. So these were those 2 historic genotype 2 strains, our Fort Collins Argentinian genotype 3, and then we have this sample from collaborators that was from Arizona in 2015. And at this point, we had just been working with the sequence of the virus. So Marina and Kate in the lab took that original tube of mosquito homogenate, put it onto 2 different cell lines, and was able to get infectious virus out of it. So we now have a virus, a contemporary, locally acquired virus that we can work with in the lab. And so we wanted to look at how well this virus replicates compared to those others in a couple different cell lines. So to look in the avian reservoir, we use DF1 cells, which are a chicken fibroblast cell line, and pretty standard. There's also suggestions that there might be a bat reservoir for St. Louis. So St. Louis has been isolated from bats in Texas in the 1960s when there was this really big outbreak in humans. And serosurveys have found that many different bat species have antibodies against St. Louis as well. So to do that, we use an AJ6 cell line, which is from Jamaican fruit bats, and kidney cells from the Schounts lab. And to look at the vector, we use a CT cell line, and they're from Culex tarsalis mosquitoes. So these are just growth curves, so infecting these cells with our 4 different viruses. And as you can see, both the chicken and fruit bat cell lines, all 4 viruses replicate really well, and they reach high levels with not many differences between them. And in our mosquito cells, it's slower replication, and it doesn't reach quite as high levels, which is consistent with other studies. And there's a lot more variation. Our Fort Collins light green reaches higher levels than that California or Arizona genotype 3, but it's kind of within the range of just replication in these cells anyway. So Jenny in Angela's lab put these viruses into birds to really try and understand what's actually happening in the avian reservoir. So Jenny experimentally infected sparrows with an old genotype 5 virus, which I won't really focus on, a different California genotype 3 virus, and then that same Fort Collins virus that we provided. And what she found is that birds infected with this kind of US genotype 3, only about 40% of birds became infected and had detectable viremia, whereas 90% of birds infected with the Fort Collins isolate became infected. So potentially this virus that seems to be reintroduced might be more infectious to birds. Of the birds that became infected, though, she looked at the viremia, so the level of virus in the blood, and found that between the blue and green, our 2 genotype 3, the levels of virus and the kinetics were actually pretty similar. So if a bird becomes infected, it seems to have similar levels of virus, but the likelihood of it becoming infected might be higher with our Fort Collins isolate. So just for some conclusions, St. Louis has reemerged in Colorado. We've detected the virus in mosquitoes and antibodies in birds. We have 2 different strains circulating in northern Colorado specifically, and they're co-circulating in areas of high West Nile virus transmission, so it seems they both can be supported. This Argentinian-like genotype 3 has been detected in many states now, only starting in 2025. And collaborators in California, we shared this data with them a few months ago. St. Louis has been circulating there for quite a while. And they'll now are planning on going back and sequencing their mosquito pools from 2025 to see if they can detect it there as well. And we also have a colleague in Argentina, and they collected samples in 2024 and sequenced St. Louis and found that while the tree I had shown before, the most recent sample from Argentina was from 2013, our virus actually more closely matches this virus in Argentina detected in 2024. And in just some basic characterization, it reaches high titers in mosquito cells and potentially higher than other genotypes 2 strains. And it's potentially more infectious in birds compared to other isolates as well. So for just some simple future directions, I've only sequenced the envelope portion. We plan on doing whole genome sequences of all of our Colorado viruses with a collaborator at Baylor, and then we're going to finish screening bird samples for antibodies. We want to note that it's important to reevaluate vector and host competence since it really hasn't been tested in many years, especially using these new strains of the virus and using local mosquitoes and birds. And so Jenny is doing a ton of this work, including this new virus in birds. And while we unfortunately don't have funds to pursue this in mosquitoes, Kate Kimball is an undergrad in our lab and is doing a systematic review of all the published data that already exists to see what we can learn about viral and host determinants of these kind of effective mosquito vector pairings. And then lastly, that proactive surveillance is critical. Because we have this really robust program in the EBL lab, we were able to detect the introduction of this virus from a year where we hadn't previously detected it. And as part of that, we plan on adding Western equine encephalitis virus to this assay as well. It's not been detected, but we have reasons to think that it's just a matter of time before we'll start detecting that in North America as well. So a bunch of collaborators, various people at CSU, a ton of people that have provided all these mosquito samples that I sequenced, and then all of our surveillance partners. That is it.
And we'd like to invite all the speakers up to the front so we can have a Q&A session.
Hi, it's me again. Thanks for all the great presentations by all the speakers. I had a quick question about the St. Louis encephalitis presentation. If I remember correctly, I think a lot of the displacement that is thought to have occurred between West Nile and St. Louis is based on cross-reactivity between antibodies. I know you saw in the cell culture experiments that it looked like there might be higher replication by the Fort Collins genotype. Did you also have an opportunity to look at, from any of the blood specimens from any of the infected birds, if there was cross-reactivity between the Fort Collins genotype versus previous St. Louis genotypes and West Nile?
Yeah, so we didn't in this data, but Jenny, her whole PhD is looking at in birds, especially first infecting with West Nile and then challenging with St. Louis, or St. Louis and then West Nile, to understand if it really was the avian reservoir and immunity that allowed one to exist and not the other. She has some data on looking at maybe the historic strains have less protective or cross-reactive immunity compared to the others, and so that's probably part of it. There's generally not a lot of cross-reactivity just in a West Nile infected bird in cell culture experiments looking at cross-neutralization, but it seems in birds there might be some protective immunity.
Hi, so I have a screwworm question. So back in the 70s and 80s and 90s, where we pushed it back down to South America, could you talk a little bit more about how we did that? Because I'm curious, a lot of the same challenges that you're bringing up now with how wide the strip is, in northern Mexico, I imagine we ran into the same problem. Obviously, it took quite a while. Based on the map you showed, it took about like 30 years. But yeah, were they using airplanes? Were they doing local dispersal? I'm just curious in more detail how they did it. Thank you.
Yeah, so one reason that was more successful then than what we're currently experiencing is because they had more flies at the time, and they already had established production and dispersal centers. I believe one of them actually was at Moore Airfield Base, where they're constructing those new facilities now. But so they already had that fly capacity, and then that fly release was done and is also currently being done through a combination of things like ground release chambers and then also aerial dispersal via planes. Some of our issues right now, or early on in eradication efforts in Mexico, are that the Mexican government wasn't really playing nice initially, and so they were doing things like placing import permits and fees on some of our planes. They weren't allowing planes to land. They were also placing fees on some of the critical aviation parts that were needed for those planes and equipment and things. So we faced some challenges there, although that has improved now. And also back during previous eradication efforts, this was established. We were used to dealing with it. So a lot of those things were in place at the producer level as well, like the herd riders that were were monitoring for this regularly, and we also had medications and other tools at our discretion to actually treat this and take care of it a bit more readily than what we can do right now. Again, we're kind of scrambling. FDA is making drugs available to us, but at the start of this, we didn't actually have anything that was labeled for screwworm. Ivermectin has been getting used a lot in the outbreak area off-label, but looking at it from a One Health lens, we want to be really cautious with that because we're also perpetuating resistance using just one drug. So that's why they've been trying to give us other tools in our toolbox. Hope that answers your question.
Emily, so back in the day, 20 years ago, there used to be periodic outbreaks of St. Louis and Grand Junction, the western slope. So you had that one case or the one isolate from one detection in Durango. Any samples from Grand Junction area?
Not that I know of, but we weren't even aware that anyone other than us was testing for St. Louis, and so that's probably one of the big gaps, is that most places that are doing any testing are just testing for West Nile. In Durango, their mosquito control district is using the Co-Diagnostics platform, which does test for West Nile, St. Louis, and Western. And so it's possible in Grand Junction they're doing testing and haven't detected it or just aren't even testing for it yet. So I think with CDPHE, we're going to help get, we've shared our protocols to get other places to be testing for it as well. So it's possible it's there.
Thank you. We have two questions online. The first one, thanks for the presentation. Does the West Nile genotypes exhibit different virulence?
For West Nile, do you know the question? Well, yes, different West Nile genotypes can definitely have different virulence, especially in birds and potentially in people. As West Nile has moved across the country, West Nile has been evolving and changing and spreading also, and we have people in our lab that have been studying that, and from Jenny's work in birds showing that different West Nile genotypes also lead to different kind of types of disease in birds and levels of virus in their blood.
Thank you. And then is it okay if we take the second? Okay. The second online question we have is, what can LPHAs do to help spread educational resources to communities on these varieties of topics?
I would say a big utilization that is, limited for limited resources is just social media. And I might be saying that a little bit biased because I am a Zoomer. But I think the types of, especially utilizing different platforms, that is a great way to let people know about different things that are going on within your area. And there's also multiple different types of mechanisms you can use. There's videos, don't be afraid to do graphics. There's kind of a famous example of social media, particularly with CDC. If you guys have seen the lemon poppy seed, it's really famous for trying to bring awareness to tick-borne diseases and the size of a tick. And, maybe something a little less controversial, but I think the point is that really got people's attention. So don't be afraid to think of fun or creative ways to talk about different issues in your area.
Yeah, I don't have a whole lot to add to that. I mean, we work a lot on outreach, just trying to reach the community through conferences and speaking to, for us, livestock producers and things like that. I did see something recently, to your video point, that social media is a fantastic platform, but video receives a lot more attention and views than static pictures or posts and things like that. So I do think that's something that we all need to learn to use a little bit more. It's a little bit scary, but can be a very good tool.
Yes, thank you so much. I have a question for each of the presenters. I'll start with St. Louis. I'm just wondering, at the point when you use the birds as the lab animals, did you do any immunology work to see if they shared the status, the immune status?
So that was just in a cell line. So it's in a kidney cell line from bats, and it replicated to high levels, but we haven't done experimental infections, and I'm not aware of anyone that's done experimental infections in bats.
Okay, just one last one. With the data you have for the future direction, are you looking at doing some risk transmission pathway modeling or like scenario modeling? Because you have data from the past, the current, and you could project something.
So other people in our lab are working with all the mosquito surveillance data and putting that together to hopefully get at some of that. The St. Louis data is new, and so we're even figuring out how within the city and county, how we are going to report that data and what to do with it. So it's definitely something people in our lab are working on.
Right. Then the screwworm, I was just wondering, I saw there are traps that, was it about 3,700 or 1,000?
1,000, yeah.
Yeah, just that versus the lifespan of these screwworms. What was the target of the trapping? Was it to study them or to kill them?
Yeah, so it's mostly to assess populations and where we're finding them to help guide response efforts, particularly with like the sterile fly release.
So would the traps sort of provide rapid answers before the expiry lifespan?
Yeah, and we'll see where, like, sometimes we can catch spread maybe before it's actually being reported at the ground level in, in animals and things.
Just one last one. I've seen people somewhere using maggots as feeds for for chickens, right? You're looking at putting. We are looking at it now as a problem. But then is there a way you could convert that problem into something commercial that could be beneficial instead?
I don't think screwworm would qualify for that use because of the tissue destruction that it causes, because it feeds off of that living tissue. Maggots that are being looked at for like medical uses, they're more debriding wounds, so getting rid of that like dead necrotic or infected tissue. So that's where the benefit lies there, whereas screwworm is going to go for that healthy tissue, and it's actually going to make that wound worse. Good question, though.
Thank you. Then for the ticks, have you registered any tick resistance?
Like to insecticides?
Yeah.
There is very little within Colorado, to my knowledge, insecticide use that's being used for tick prevention. I would say that's definitely more common in areas where there's really, really high tick endemicity. So like the Northeast, they are maybe doing more like active work in that area to look at different insecticide products that are effective against ticks. And there are some colleagues of, former colleagues of mine at CDC who are also looking at tick resistance for insecticides, but I think that's still a long way off from being a problem here.
Hello. I think we're going to go ahead and get started with the next session. My name is Taylor Foley. I'm the One Health epidemiologist with CDPHE, and it is my pleasure to introduce our next session for One Health and public health approaches. A lot of great speakers, and first I will introduce Dr. Tracy Webb. She received her DVM degree from Ohio State University, followed by a small animal medicine and surgery internship and an emergency and critical care residency at Angel Animal Medical Center. Tracy then completed a PhD in pathology immunology at Colorado State University, where she is currently an associate professor in the Department of Clinical Sciences and manages veterinary and translational regulatory affairs in the Office of the Vice President of Research. She is also involved in multiple committees and initiatives to encourage and support quality and sustainable veterinary research to improve all patient outcomes. Tracy?
Well, thank you so much for inviting me and for all being here. The last talk reminded me in vet school I work for the CDC Vector-Borne Disease Unit, and I should never say that I actually miss doing field work like putting out mosquito traps, but I kind of do. This is not field work, but I think has a lot of potential, so hopefully it'll be interesting. Okay, I have no disclosures. I do like to say when I talk about this that I am actually not a computer scientist or a data scientist or an AI expert. I just have a lot of ideas and questions that I want answered, and so I luckily work with people who help me do those things. Okay, so I'm just going to start out with this because originally some of the conversation was about AI and healthcare, and so I like to talk about, I think everybody knows artificial intelligence, but I love some of the definitions and things that make me think about when we're using programming to solve data problems. And so this is actually from IBM as a definition that AI is technology that enables computers and machines to simulate human learning, comprehension, problem solving, decision making, creativity, and autonomy. And I always, of course, am like, well, what's simulate and what human are we talking about? You know, we can get picky about that. And then they use terms, and this did change a little bit. It's supposed to be pointing to the they and understand that people use a lot of anthropomorphic knowledge or language associated with the AI, which I think can be dangerous. And then, of course, responding to human languages, natural language processing, which we're going to talk a little bit about. But I think the big thing of what AI is and why it's of so much interest to people is that, it's a big opportunity to handle big data, right? And we want to find out answers from data. And again, AI needs data and informatics to help us use that data to find answers. And it really depends on data quality and data quantity. And we're going to talk a little bit about that in the context of some projects that we're working on. And so informatics, just in case you weren't aware, is what actually allows us to use AI. It creates systems and processes to handle large amounts of data. And so it's all the collection, the processing, the storage, management, and sharing of data, which, of course, without that, we couldn't do a lot of the things. And I think that then allows AI to use the data to perform tasks. And I always like to, again, remind people that it's actually looking for patterns, not necessarily facts. Again, it's not us. So just being aware that that data that is used for all of these processes and the quality of that is really important. And so how does this work? How does AI work? This is just sort of a very simplified version of explaining this. So again, we have that big data that we want to analyze. We're going to have a model that can do pattern recognition, that's going to develop an algorithm, and it's going to try to help with decision making and then learn through that process. I have a star here because if you're using this in different contexts, you have to be very careful about this decision making thing. And there probably should always be a human in the loop, especially when we're talking about human health care. So as a veterinarian, I'm the only one who can really make health decisions legally because I have to have a license to do that. So I can't really have a program making decisions for me, but it can provide decision support, right? And maybe that's helpful. And we can get all more fancy with this and talk about all of the words, including natural language processing that we're going to talk about, different types of learning, and all of these things as the models have continuously learned, and they can change as we provide different data and responses to it. I think it's really interesting to think about, and one of the things that I think really changed how we can use this was the development of transformers in 2018, which is what ChatGPT is. And it really allowed these programs to consider context of words. So that's where we're getting some of the ability to use these. And I think it's just fascinating to think that these programs could analyze or be trained on 3 billion word data sets in 4 days. This is a massive amount of power and opportunity. Of course, you have to have the GPUs to do that, right? So data quantity. So large data sets are used to pre-train these models, so we need these large language models to do that. If you don't have data, you can't train the model. Although there's some catch there, you can create synthetic data. And then with the advent of electronics, matter of fact, on the drive down here, we're talking about Oura rings, you know, my Garmin watch. We're all collecting multitudes of data points all the time. So there's a lot of data out there. Whether you're aware of it or not, I'm sure Garmin is using my data. So we got a lot of health data out there. And with the advent of electronic health records, we have a lot of medical data too. And if you look at this, we think that there's probably, and this is some estimates of, you know, an average of 3 visits for a dog, a few less for cats because they really don't like to go to the veterinarian. And so about 270 million dog visits a year, 230 million for cats, and about 1 billion for people. Interestingly, if you look, the average visits per year in dogs and people, about the same. So there's some interesting overlaps, and we know that this is really interesting on the One Health side because we know there's shared diseases between these groups. We have shared environments. We have shared exposures. Infectious disease is one we've been talking about a lot, but a lot of other different things too. And then shared treatments across the medical spaces. And so how can we analyze this data and what can we use it for? This was a paper that I was involved in that came out in 2020 where we are trying to assess the state of veterinary data. And within this, we pointed out that you could use a lot of this data for biosurveillance, for systems biology, shared environment research, outcomes prediction, and then really interesting too, rare disease modeling, right? So if you have 10 people who have something and we have cats and dogs that have a similar disease, that ups the number of animals that we could use to try to find solutions if we can recognize them and bring that data together. Okay, but data quantity, I think the biggest thing is, we all know, garbage in, garbage out. So there's an example I'll use here that I think is really interesting on the health side. So if you looked in the medical record for one of my pets, it says that she's a Labrador Retriever. We did genetic testing on her, 0% Labrador Retriever. But of course it's in there because she's a black dog, she's very friendly, she has a long little otter tail, 0%. Her adoption record said she was an Australian cattle dog, and none of that in her either. And so, that's not going to really help us. This is supposed to say garbage in, garbage out, but I think the MAC thing changed this a little bit. So I have to think about what format is that data in. Is it accessible? And we'll talk about that a little bit more. And obviously, like I said, how good it is, because we don't really want to use, if we use bad data, then we're going to get bad answers that don't really apply. And so here in that same paper, when we were looking at it, actually has gotten quite a bit of attention, which is the only reason I put it up there, because people are interested in how we can use the veterinary data. But there's actually limited sources of that data out there right now. So those training models that we were talking about, the large language models, there's really not that type of data on the veterinary side available. And it's actually really siloed. So you think on the human side, a lot of places use EPIC, so they're using the same system, relatively easy, in the same formats, relatively easy for them to then share data. Of course, HIPAA compliant sharing, all of those kinds of things. Veterinary medicine, very much a different landscape. And there's inconsistent data formats. And then really interestingly, on the human side, for insurance purposes, they code all of their data. But on the veterinary side, we don't have that same driver, and so it's uncoded data most commonly. And so I think when we think about data quality now, we've talked about how there's a lot of quantity of it, we have to think about what we want the model to learn, and does that data have support that? I just mentioned standardized coding and labeling, and whether we include common data elements. So on the veterinary side, I often will be like, well, how many of your records have a body condition score in there? Because we don't necessarily have a box for that in all of the medical record systems. And so again, that's more common on the human side, but it makes it much easier for us to bring that data together if it's coded. So it makes it more generalizable and more interoperable. But we can also learn from non-standardized data, because that can be a discovery piece. So the standardized data might be for prediction, because we can be really precise with that, where the non-standardized standard might look for things we didn't know. So we are always thinking about that, right? Like, what do I not see that the algorithm would see with this data? And so that can be for discovery. And then there's ways to use data in the pre-training and the fine-tuning, which we'll talk a little bit more about, and general and specific modeling. And so related to all of the categorization, there's actually a bunch of schemes that have come out and ontologies to try to help code data across the medical space. We've worked a little bit on, I mentioned breeds, and gotten into really interesting conversations on what should be called a random breed or a domestic breed in different species. So lots of conversations on those things. Probably one of the most commonly used things is SNOMED, which is a systematized nomenclature for medicine. We had CT for clinical terms, and we actually use that in some of the things that I'm going to talk about next. And then some ways where they're trying to actually bring together some of these coding schemes, because there's a lot of different ones. Some of our collaborators over in Europe use the ICD terms instead of SNOMED. And so how do we bring those things together to be able to share bigger data sets? So in order to try to deal with some of the challenges in using veterinary data, which I really see as sort of this untapped resource that can really help us in these One Health questions, we wanted to develop a natural language processing coding tool that could help us automate veterinary diagnosis coding. And you can think about, like, if you had these millions of records, how would you go back and code them? That is a huge amount of labor, and nobody's going to do it, right? So can we use some of these new technologies that we've just talked about to do that? Can we compare it to what some of the current state-of-the-art models are? And then can we use some of those human clinical LLMs, because we don't have that data in the veterinary space like I mentioned. And so this was kind of a goal of this project that we did. And really interestingly, in Colorado, we actually have a bunch of really unique resources that make us the perfect place to do this. One being is up at CSU. We have actually invested in manual coding of records for decades now. And so we actually have a set of about 250,000 manually coded records. And that is unusual. Other places don't have that resource. And so we have a training set that we can use, and actually we are using and a couple other people have used in the past. And so some of those previous collaborations we worked with Stanford University back in 2017 and 2019, and they came up with 2 models where they were using some of our coded data. The first one, called Deep Tag, looked at 42 codes, and this is that SNOMED CT coding that I mentioned, the standardized codes. And then they had a study that they did a little bit later with quite a few more codes, which had about 4,500 diagnosis codes that they used. And they actually use, this is a little bit of this is talking about the transformer that allows us to do a lot more of that natural language processing, which they did in that second set. But a couple years later now, we wanted to look again, and we wanted to see if we could actually use all of the codes that's in that manually coded data set, which is almost 8,000 codes that we have in there. And you can see here, this is kind of a schema of what we're trying to do, of can we use, I don't think that the thing works, but can we have use some of this foundational data that's pre-trained, these large language models, and then can we have our coded records that we would feed in there and create an auto-coding model. Ultimately, what we're trying to do is get to what we call a common data model that could be shared, and that is something that then lots of different places use, these standard ways of presenting data that we could pull together from the human side, from the veterinary side, from different veterinary hospitals. So a lot of power to be gained if we can do that, and we are working on this anyway. But can we help get those uncoded records of ours coded and help other places code their records so we can actually grow that data set and not just have Fort Collins data, but have maybe all of Colorado data, maybe all of the across the nation data, maybe even international data, right? So I think some really powerful things that could happen if we could do this. I mentioned I would talk really briefly about fine-tuning because that's what we were doing here. And so what that is you have that large data set again, you pre-train it, and you create this large language model. You can have a medium language model. You can have a regular, just an LM. But we're having a large model of data that then we can use our specific data set to fine tune to the specific task that we want. So to try to make it better at what we want it to do, hopefully saving energy and using less resources at the same time. I did put a note on there just so everybody knows when you create these, the data is embedded in the model. So we have to think about that on the health side of what that means and how we use that. So we went ahead and did all this. We tested 13 different models that are out there, and the one that actually performed the best is called Gatortron, which was developed in 2021 as a partnership between University of Florida and NVIDIA. I'm sure everybody's heard of NVIDIA at this point. This model is huge. It was trained on almost 3 million human medical notes. And 91 billion words. So massive model, but performed the best of all the ones that we did. Had precision of 80.8, and then there, if you were in the space, some other metrics that we used to look at different things like exact match and recall. And so if you're me, even though that is like the best and that is considered state of the art, this is we're talking about health data, right? And I don't want to B-. I don't like a precision of 81, right? So I think there's things that we think about, even though this is much better than things that we've seen so far. What are the errors that are happening? Why do we only have 80%? We still need to look into that. Do they matter? So part of the thing we think about with coding is hierarchy of coding. So if the code actually said it was kidney disease and it was actually acute kidney disease, that maybe is not a big an error for me because it's still in kidney disease. But if it said that it was pancreas or pancreatic disease instead of kidney disease, then I care because that's wrong, right? So there's different levels of wrong that we would look at. And so do they matter is what I'm talking about with that. Can we fix the errors so we can identify where the errors are, and can we do something about it? I'll mention ensembling, which could be that we bring in another smaller model that might specifically work on the reason that it gets some of these errors wrong. And if not, can we at least flag them and say, hey, these are the ones that we need expert review on. So all of the easy stuff, let this thing do. That saves hundreds and thousands of hours of personnel time, and let us focus on what's really important. So that's some of the things that we still have to do with this. If you want to, the paper is actually published, and we actually have the model out there, which is, I think, maybe one of the first ones that is out in veterinary medicine. Some of the interesting things, because I'm not going to go through everything on this, is that we found you can use those human clinical models, and you maybe don't even need a specific context to that pre-training data. Something really important, all of the other even smaller models performed relatively closely to this. And so you may be able to get away with a smaller model. And really interestingly, I put this here because actually you can see, obviously, the more data, the better. But there is sort of a plateau here. And so if you got like 20,000 records, you got pretty close to where we are. And so the potential that you could use a smaller amount of data if you didn't have this huge 250,000 record thing. I love this term, so I just put it up here because it's like the story of my life, catastrophic forgetting. We were discussing, I wrote a few numbers on cards because I'm like, I'm going to get up here and not remember what this is. But this can happen if you try to fine-tune too much. So this is something really interesting that the data scientists talk to me about. It's like, but I want 100%. I want 100% precision. Like, I don't want 80, I don't want 90. And they're like, but there's payoffs of what happens if you try to fine-tune too much. So I love that term, so I just stuck it on there. Again, I mentioned some of the things that we're looking at is explainability. So why did the model choose that code? It helps me trust the model better if I can look and it says, well, I picked this word, and that's why I said it was kidney disease, not in this case. But I mentioned ensembling, where we can actually have several different models that are involved in this that help us get better at specific tasks. We want to see if it's generalizable. So some of the previous models, they performed well on CSU data, but when they tried to look at private practice data, didn't perform nearly as well. So can we see how this model actually works with, these are some partners that we've been working on with some data stuff already, and a couple other things that we want to do. Along the lines of this, so I'm really interested in sustainability for many reasons, but one of them is, like lots of places just don't have the compute power to run Gatortron. So can we find more efficient models that could actually be used on laptops or tablets in the field, right? And that would make this much more accessible to use across the industry and potentially then bring better quality, more data. And so we actually did a study looking at several different models to see if we could get them to work as well as Gatortron. You can see even just here in the thing, Gatortron is huge compared to the other models that we were testing. And it actually worked. So a medium-sized model performed comparably. And you can see the massive difference that we're talking about here. So if you're looking at, and don't worry about all of the different exactly what like A100 days means, but if you can look, it's 2.3 compared to almost 60,000 training days. And then if you're looking at the RAM cost, we're looking at hundreds versus tens of thousands of cost. But the performance is relatively similar, so that's 72 to about 75. And that was just on a run to see if we could do this. And the really important things about this to me are, like it says here, significantly low computational cost. So if we're looking at something that's actually feasible for people to do in practices, and again, that they could actually do this, those size models could fit on their laptop rather than we need to have a data center that's doing all of that. And we still have obviously next steps related to this of trying to collaborate again, like we were talking about with sharing data, see how it works in other places, and then actually deploying these models and see how they work in the field. So not quite there, but getting closer. So what do we want to do? So all of this is sort of to create our ability to have higher quality data that we could use in models. And so what might that look like? So another project that we are looking at, which is actually pretty unique, and again, using resources that are really unique to here in Colorado, is we are working with the University of Colorado at Anschutz to try to create a data registry that includes human and veterinary medical data. And so we started this work looking to see, is this even feasible to do? And would we be able to get enough overlap on these projects? And so we, a couple years ago, started just to see, could we look and see how many records we could get that overlap? Now you can imagine this actually took multiple years for us to get people to be like, what are we doing? Many different conversations, 2 IRBs, so we had to have IRBs at both locations, and then data use and sharing agreements. But we actually did it, and we were able to publish this paper at the end of last year. And so in that, just one-time linkage to see if we could see how many people who bring their pets to Colorado State University for veterinary care actually also get human health care through UC Health. And we found about 30% overlap in this original run, so over 12,000 matches. So that's a pretty decent data set that we can now use to ask questions of on the household level. Or, again, cross-species. Interestingly, if you look at the data, there's, we just could only do in this initial look a few quick questions. There's about just under 50% female animals, just over 50% female patients. So there's a lot of potential interesting overlap in these groups. So because this seemed feasible, we are now working on actually creating, we call it the companion care registry, but basically to make it more clear, it's a pet patient registry where we are then going to be able to link human and veterinary medical records. Now this is really made feasible by resources that they have down at University of Colorado Anschutz, or I guess here, and his are not really down there now. They have a HIPAA-compliant curl tool that allows these linkages to happen, and they have a health data compass center that actually manages bringing in a lot of the data from UC Health, Colorado, the Children's Hospital, and things, and different types of health data. And so it's really this incredible partnership, I think I'm very lucky to be involved in, of how we're actually hopefully being able to bring this all together. And so one of the questions that we're interested in as our first question, and I forgot to add, we do have some funding for this through the CCTSI there, is can we look at the companion animal and human medical data to look at household metabolic syndrome metrics. And you can think about, so there's lots of things that you could think about on the household level, but certainly things related to where your home location is. Do you have green space? Are you both walking a lot? You know, food resources, because I can tell you, yes, as a veterinarian, my dog should not be eating people food, and my dog perfectly 100% eats all the people food in the house, whether it's for me or somebody else in the family who also should probably not be feeding them. But, you know, so lots of really interesting questions that we can answer. One of the things that's come up with this that I would really love to have happen is to have a control set. It'd be so great if Epic had a box that just said, do you have pets in the home? And so then we could maybe figure out better which data doesn't have pets that we could have as our control set. So lots of potential opportunity there. And so I just pose this question, because we are actually, like I said, in the process of doing this. What questions would you want to ask using this type of a registry? And then I think of a bigger question is if we got data from across the state of Colorado, what would that look like? You know, and then if we're able to link, I have some partnerships with other universities that we're talking about, can we have, you know, maybe across the country type data? So I think there's so much potential here, super exciting. Definitely reach out if you have questions. I am like the minusculest part of this, so this is at least some of the people who are involved across different universities and different areas, and I'm so grateful to work with all of them. And if you have any questions, definitely open to that. We actually have a survey because I'm really interested in what people think about using their pet data. You know, I brought up my Garmin that is clearly, I'm sure, being used for research. But curious if anybody wants to, really short survey, all anonymous, as a pet owner or a veterinarian, we'd love to get your thoughts on that. So Thank you.
Okay, next up we have our second Dr. Webb, Dr. Colleen Webb. She is broadly interested in the evolution of traits important in ecological interactions and how evolution shapes communities and ecosystems. Her work is interested in how highly virulent pathogens persist, as well as understanding the drivers of spatiotemporal spread in pathogen host systems in order to inform management decisions.
Okay, and due to my tendency for catastrophic forgetting, I'm going to use my notes here. So thanks for having me. I'm really happy to be here today. When I was invited to talk at the conference, I was asked to focus on our work with surveillance data. And that's not the way I usually frame and talk about our work, so also need some notes because it's not just my usual things that I have to say about this. So my research group focuses on modeling the spatial temporal spread of infectious diseases and then evaluation of control strategies. And our work is known for being strongly data-driven. But where do our data come from? We use data that are often collected for surveillance and related kinds of purposes. And then we use modeling techniques to repurpose these data for a deeper understanding of the underlying drivers of transmission, which is needed in order to evaluate potential control strategies, especially for use in planning for an outbreak that may not yet have occurred. So surveillance data are expensive and very time-consuming to collect. So it's important, I feel, that we wring as much information as possible out of these surveillance data. So that's what we're trying to do. But they can also be really challenging to work with, especially because the relatively low prevalence of many pathogens inherently means that there's not a lot of signal in the information just because the prevalence is low. And surveillance data are not collected in a controlled laboratory environment, and there's often many different individuals that are involved in the data collection. So taken together, the surveillance data are also relatively noisy. There's a lot of them often, but the signal isn't super strong, and there can be some noise, even when the data are carefully collected, just because of the context. And this low signal to high noise ratio makes surveillance data particularly challenging to work with when we're trying to use them for a different purpose and wring out of them this information about underlying mechanism. But I think it's well worth it because they also give us a bigger picture in time and space than other data types might. So today I'm going to talk about our work with livestock disease. We do a lot of work in One Health, but and there are One Health aspects to this because with these diseases, there's also often a wildlife host. But I'm not going to focus on that as much, so I can highlight some of the surveillance data aspects of what we're doing and think about how that's really informed our understanding of how disease can spread in the U.S. livestock population. And then end with some best practices around surveillance data collection that can enable the use of these data for other purposes, this kind of repurposing that we've been trying to do. Okay. So this is the problem that we're working with. We need accurate enough models to inform surveillance and disease outbreak management during planning and ideally in real time. However, we have limited time and resources for data collection and for the computing that can be involved. So this is sort of the approach or the philosophy that we use in my lab. Ultimately, what we want is really this first layer, right? That we have a test bed for surveillance and management strategies. And in order to accomplish that, I want to create a very accurate model of pathogen spread in space and time, right? And convince myself that it's pretty accurate before then I go and try out different control strategies to see what the outcome might be. And in order to have that accurate model, I need some really good data in order to be data informed, and that's where the surveillance data come in. So I want to talk about two parts to the modeling that we do. The first is called USAM, the United States Animal Movement Model. And one of the issues in understanding livestock disease spread in the US is understanding long distance movements that happen due to shipment of livestock. And in the US, at least, we don't usually have exact data on where livestock move. Our animals generally aren't chipped, and so we're not taking exact data on that. But we need to develop a model that allows us to predict livestock shipments and the sort of contact networks that are created by these in order to understand the potential for long-distance transmission of livestock diseases. So here's an example of repurposing some data to understand routes of transmission via livestock shipments. And we started this work in 2008, I think. And so here's some of my lovely USDA colleagues standing with boxes of records of interstate certificates of veterinary inspection, which we would hope would be more electronic in origin these days, but also still can be quite challenging to work with. So these are data that are collected, right, for another purpose that we are repurposing. They're required for non-slaughter interstate movements, and the cool thing about them is that they contain the origin and the destination address of the shipment, the date of the shipment, and a description of what is in the shipment. You know, if it's cattle or pigs or what breed of cattle, which helps us understand whether or not they're likely to be beef or dairy cattle, for example. And we were able to gather a 10% sample of these records from 47 states. And then we did a little modeling magic to turn these surveillance data into something else. So the first thing that we thought about was understanding the probability of shipment with distance, right? So just the further you ship animals, how does that decline, right, with distance, right? So we probably ship animals less longer distances and more shorter distances. I mean, just as an example, livestock welfare rules require, right, that you have to stop and let them out of the truck after a while. Well, you don't want to do that if you can avoid it, right? And so people don't ship those kinds of distances that often. So we can fit what we would say a kernel of function that estimates what's the probability that you get a shipment at these different distances based on this ICVI data where we have an estimate of the distance of the shipment from the destination and origin information. But that doesn't describe shipment completely in the US. It's an important part, but we also have source sink dynamics that happen in the US because we have set infrastructure, right? In the Midwest, we've got a lot of feedlots and slaughter facilities, for example. So we have a source sink dynamic where we have production of livestock animals in some areas, and then they're shipped to other parts of the country for finishing and for slaughter. And so we add some additional covariates. These are ones we've used at various points in time, basically to incorporate this sort of source sink dynamic on top of that distance piece. So we're adding some additional information to our ICVI records. And then we put that all together using a Bayesian hierarchical model. I'm not going to go into the details of that because I'm focused on the use of the surveillance data. But it allows us to simulate the movement. So I've just picked 3 states that are of interest in the cattle industry here. And on the left, we've got the actual observed movements coming out of the state. And on the right, we've got simulations from our model. So you can see the match is pretty good. And we've done a ton of validation on this. And we've looked at it at all kinds of different levels. And generally, it holds up pretty well. And when we put it all together, it gives us this kind of network, right, that's data-driven of, in this case, cattle shipments in the U.S. And we can break this into beef or dairy. We have the same thing for swine in the U.S. And I've shown it here at the state level because it's too messy if I show it at finer scales, but we actually can create this same map at the county scale. So we can get pretty fine and even make some further inference to the premises level. So all of this basically comes out of these ICVI data type of surveillance in some ways, or related kinds of records, right, as well as publicly available data from the National Agricultural, from NASS. Okay, so I just want to show you a use of this. So this is for our swine shipment network, similar to what I just showed you, and porcine epidemic diarrhea virus. There was an outbreak from 2014 to 2018, and what you can see on the left here are the observed number of cases in the first quarter of 2018. I just picked one of the quarters to show as an example, and on the right here we've got, oh, I said it backwards. On the left, we have our prediction, and on the right, we have the observed number. And overall, we're able to predict pretty well. And what we're using to make these predictions is the number of swine premises in the county, information on the previous quarter's cases, and also covariates associated with that network of shipments. So we're able to show that there is a role of swine shipments in the spread of this pathogen. So this is an example of how that surveillance data or related types of data can be used to understand the drivers of transmission. That's not the reason why these data were collected in the first place, but we can put them together in a more mechanistic way to understand the drivers of the spatial temporal spread of disease. But we'd like to do this in an even more mechanistic and dynamic way. So we use an approach where we use something called a local transmission kernel that I'm going to tell you about. And we use that to describe sort of more local level transmission that happens in space and time. And we pair that with these long distance shipment networks in order to understand much, much larger scales of transmission and the possibility for new foci of infection to begin in other parts of the country due to shipments. And so together, these can inform models of the spatial temporal spread of livestock pathogens. And we do this within a model called US-DOS because I was working with government agency friends and all of our acronyms had to be pronounceable. This is why we have USAM and US-DOS, the United States Disease Outbreak Simulation. So I'm going to talk today about an example of foot and mouth disease outbreaks in cattle and some of the things that we can kind of come up with for predictions. But we also have different versions of this to explore foot and mouth disease in cattle and swine, bovine tuberculosis in cattle, African swine fever, classical swine fever in swine. My grad student, Christopher Brandon's here today with me, and he's been working on ASF, as well as high-path AI in dairy cattle. So this approach can be quite flexible for looking at a number of different types of livestock diseases. Okay, so I mentioned local transmission, right? This is a different type of transmission in terms of scale than we think about when we're talking about long-distance livestock shipments. So we've got local transmission that can happen for a lot of reasons. Fence line contact, or shared equipment, or shared delivery trucks, or going to visit your sister, or the neighborhood poker night, or whatever. There's lots of different routes by which there's the potential for a pathogen to move around locally. But we don't necessarily need to capture all of this detail. What we really want to know is about how the transmission is happening in space and in time, regardless of which one of these mechanisms it's happening by. So to do that, we fit a different kind of kernel that we call a local transmission kernel in order to estimate what the relative transmission risk is with distance. So if we have a focal premises which is infectious, sort of what is the risk of infection as you go out further away from that focal premises. And to estimate this local transmission kernel, we again use surveillance data. So we have 3 different surveillance data sets from outbreaks that have happened in other countries, from the UK, from Japan, from Miyazaki, and from Uruguay. And we use the location information and positives and negatives. So we know the location of the premises, and we know whether or not it was infectious or not, and at what point in time that happened due to surveillance data that was happening during ongoing outbreaks. And basically, we fit a kernel like this to all of that data. So what is the functional form like this that maximally is able to predict or recreate that very local temporal spread? So that gives us an idea for foot and mouth disease, for example, of how the transmission risk drops off with distance. Okay, and then we pair that with these long distance shipment networks to give us the really, really long distance transmission that can happen. And we put that together in what we call a susceptible, exposed, infectious, and recovered or controlled model at the premises level. So we have all the premises in the US laid out in our model. They start as susceptible. They are exposed either due to a local transmission event based on that local kernel that I showed you, or because of a shipment onto the premises, which we can simulate because we know how premises are connected in the US now. And then, think about what the transmission probability is, which we know, or the transmission rate, which we know from various kinds of studies, often lab studies, what is the time from exposed to infectious? So these are all data informed, right? And then what is the time to reporting, for example? How long is it before it is recovered? So we can simulate the full system in this way. And what that gives us is simulations of what outbreaks could look like in the US, even though we haven't had one here, that are very data informed. And so this is just an example where I'm showing if we start the simulation at each county in the US, and we run that a bunch of times, how many other counties are likely to be infected? So if we start in the Midwest, in California, down in Florida, we get a lot of red, which means we tend to get bigger outbreaks in that area. Does that make sense? Right? And this has mostly come from surveillance data or related type data, the ICVI and surveillance data that was taken during foot and mouth disease outbreaks around the world. And then we can do other things with this. We can try to understand what it is that drives that spread. So here I'm showing something called a sensitivity analysis. So in a sensitivity analysis, what we do is we change parts of the system a little bit and then look at how that changes the outputs of the model. So if I'm looking at, for example, if I increase the infectious rate, how much do I increase the size of the outbreak? Does that make sense? And so if we've got a bigger bar, it means there's a large positive relationship between what we're changing and the outbreak statistic. And if we have a smaller bar, we have less of a relationship. And if it's positive, then when we make that parameter bigger, the outbreak gets bigger. And if it's negative, then when we make that parameter bigger, the outbreak gets smaller. Does that make sense? The thing that's really important here is these are a whole bunch of different kinds of outbreak characteristics, right? Like size and duration and the number of premises that are involved, et cetera. And it's color-coded. It's blue if it is a characteristic associated with the demography of the system, like the number of premises, the density of premises, the size of premises, the number of in shipments or the number of outgoing shipments. And it's colored red if it has to do with parameters associated with the pathogen itself, like the exposed period or the transmission rate, and you hardly see any red on here. So what this is saying is that it's when you change demography that you get differences in how the outbreak behaves, not so much when you change aspects about the pathogen itself, which is kind of interesting since we don't always know exactly the pathogen's characteristics when the outbreak starts, but we can still understand a lot even not knowing that. Okay, and I just have a couple minutes, 1 minute, so I'm going to go really fast just to show you some other things. So then we can add some things, right? Like we can add vaccination in here. We can add culling. We can look at ring vaccination or all different kinds of combinations of control that we might want. And we can run them out in our simulation, which looks pretty good. And we can say, okay, well, it looks like this would be the best control strategy to consider. And we can do other things, like we can ask about adaptive management strategies, which is a really common thing that, that we want to use in a lot of different diseases. And we can here compare on the far left a static strategy, and on the far right, no control. And in the middle, we have adaptive management strategies that in total have the same kinds of approaches that are in the static strategy on the left. And you can see that the static strategy actually results in a lower outbreak than any of these adaptive management strategies that have a 1, 2, or 3 day window required for decision making, because just the delay of the decision making makes the strategy less effective than just putting everything out there at once. And then one last comparison here. So here's an example where we're doing almost real-time prediction with dairy cattle and avian influenza. So in the top, we have our model, but without any of the long-distance shipment that I talked about. And on the bottom, we add in the long-distance shipment. And the brighter colors, the yellows, for example, you have greater probability of having a case appear there. And if you can see, there's some little white marks on there, and that's where the first cases of HPAI in dairy cattle were found. Right? So we're able to do a pretty good job of predicting this. And these data are from before it was found in California, but you can see California is all lit up as well. So I'm going to stop there, but I just wanted to show you some examples of how we can use surveillance data in these kind of non-traditional ways. And then very quickly, I just want to make a case for repurposing surveillance data and what it's really important for us to have to be able to do that. First, we need the positives, but we also really need the negatives. And a lot of times surveillance data comes to us with only positive data. So that's something to think about, is keeping track of the negatives as well. Specific location and date data are also really important. Often we see them at an aggregated or larger spatial scale, even though they've been collected at a finer spatial scale. That information isn't always kept track of. It can be lost. And then also characteristics that are thought to be important from trace investigations or other kinds of evidence. It's really ideal when that is collected at the same time. And we've heard about that already from some of the morning sessions, right? The idea of trying to collect the veterinary data and medical data at the same time. So really trying to ensure that we have the same spatial and temporal grain of data for all of our data sources really helps, because it reduces all that uncertainty that I was talking about earlier and the noisiness in the data. Okay, so I'll stop there. Thank you very much. And as we're transitioning, I want to give a shout out to Lindsay Beck-Johnson, who is my partner in crime. She's not here today, but she is with us online, and she's been a really important partner in all this work as well.
Okay, for our last speaker in this session, I'd like to introduce Dr. Jennifer Hausmann. Dr. Hausmann is a clinical veterinarian at the Denver Zoo Conservation Alliance and has worked there for 9 years. She's a board certified in zoological medicine and treats all species housed at the Denver Zoo. Jennifer has assisted with multiple conservation projects from boreal toad reintroduction to the Colorado and Utah landscapes, as well as Argali sheep health monitoring and Nart Nature Preserve in Mongolia. I'm sorry if I butchered those names. Dr. Hausmann. Thank you.
All right. As she said, I am Dr. Jennifer Hausmann. I have worked at the Denver Zoo Conservation Alliance. It's coming up on 10 years now, coming up fast, which is surprising. But I'm going to talk to you today a little bit about an aspect of my daily job that I think, and I kind of hope that you guys are not aware of. So it's new and interesting and different. So, of course, the Denver Zoo was founded 130 years ago. And it's a little bit different today from what it was all those years ago. It's different in our purpose, in our mission, how I even care for the animals on a daily basis, and how we engage in our guests to help them hopefully love and appreciate these endangered animals. But the one thing that isn't different is that we are smack dab in the middle of Central Park. Smack dab in a green space, beautiful green space, in a full Denver metro area surrounding it, so a whole urban area full of people. So I have just under 4,000 individual animals on grounds, which are mostly non-native endangered animals in very naturalistic enclosures with free-ranging native wildlife all around them that I have no control over. So that includes bats, rabbits, squirrels, coyote, fox, raccoons, many things to think about. And then we have people coming into the system, people like me that work directly with the animals every single day, and then of course our guests that come view the animals and see them. And this makes what I call an intersection of possibility that makes my job in some ways very challenging and very interesting. Because what I say is it makes a microcosm of One Health. I have these non-native species, these native wildlife species, and humans in this environment, like I said, a very nice green space, surrounded by that urban interface, all together, all mixing together. And I want to make sure that everyone is happy and healthy and safe. So, of course, my daily job as the clinical veterinarian is to make sure all the collection animals are happy and healthy. But, like I said, there's all this interaction. So there's a lot of possibility for transmission and other things to be going in between. And so we do a lot of daily disease monitoring on grounds. And of course, we look for the heavy hitters, high pathogenic avian influenza, tularemia, plague, rabies virus, the one we've all been talking about today. And of course, as a good veterinarian, I'm always keeping my eye out for some of the other ones. Salmonella, Campylobacter, E. coli. I got a lot of primates on grounds, a lot of primate feces. Also, I always want to watch out for my reportables, Bluetongue virus, West Nile virus, all of these. And so because of our size and our number of animals and this intermixing, it is not unusual that an employee is walking along on grounds and they may find a deceased squirrel. And we ask them to bring that deceased squirrel to the veterinary hospital. And then all the vets look at it, assess that case. And what I mean by that is we say, okay, what is that species a vector for? Was it found in a collection animal exhibit? So could there have been direct contact and transmission? Or was it picked up by an employee that was not wearing appropriate PPE? And therefore transmission could occur. And so if one of those things happens, then that triggers testing. So I then have to test it and see, do I need to inform that employee? They need to go visit their doctor. Do we need to worry about that individual animal? Some scenarios. So say we have our Asian elephant. He grabs a neurologically abnormal Canada goose and squishes it. I then have to get that Canada goose back. and test it for high pathogenic avian influenza. While I'm waiting for that testing, I am putting that elephant in a quarantine status and asking all of his keepers to wear extra PPE, just in case. Another scenario, a guest finds a deceased rabbit, hands it to our security officer. I'm asking my security officer, hopefully, to get the contact information for that guest, then bring it to me so I can then test it for tularemia and plague. Make sure that guest has not been exposed. Another scenario, our Capuchin monkey troop gets a hold of a bat. I then have to place my entire Capuchin monkey troop in quarantine while I double check all of their rabies vaccine dates and test that bat for rabies. Every single one of those scenarios has happened. It's real. But we are very, very lucky that most of our testing comes back negative. But what I'm going to talk to you today is about 3 cases where it didn't come back positive, or didn't come back negative, came back positive. All right, first case up is our Siamang Lola. She woke up one day and she did not look right. She was lethargic. She wasn't eating well. She looked like she was having trouble swallowing, and we weren't sure why. We were worried enough about her that we decided to do an emergency immobilization and exam. So we anesthetized her, brought her up to the hospital, and started doing our diagnostics. Let's see if the pointer works. Oh, yes, it does. Okay, so first thing we noticed is she has these ridiculously swollen tonsils here. This is a picture of the inside of her mouth. And over here is a CT scan of the same thing. So these arrows are pointing to her swollen tonsil tissue. Now, Denver Zoo has 3 clinical veterinarians and 1 full-time veterinary pathologist. Our veterinary pathologist took one look in her mouth and said, I've seen primates with tonsils that big. She said, they had tularemia. We said, oh no. So we then, of course, took all the samples we wanted to test for tularemia and other ones that we were worried about just in case, because we weren't quite sure, returned Lola back to her enclosure, gave her a lot of supportive treatments, of course, and started her on doxycycline just to be safe, and asked all of her keepers to wear PPE, of course. When the test came back positive for tularemia, we were in direct contact with our state veterinary department and our state public health department to make sure everyone was happy with our protocols. Because even though we had been doing routine surveillance of all the deceased rabbits found inside our primate enclosures, we had not gotten a single positive for tularemia. We knew it was out there, possible, because we're in Colorado, but we had not picked it up. But, so in that case, our preventative surveillance didn't catch it. But, thankfully, our mindset of knowing what is out on our landscape and potentially transmitting allowed us to be open to this as being on our differential pretty much from the get-go. So we were very, very lucky that we were able to institute this right away and make sure that, like I said, all the departments were happy with our safety protocols to make sure this didn't transmit to any of our other primates, including our keepers. And so thankfully, Lola took her meds and has recovered fully. She is back on exhibit. You can go visit her if you like. And she is doing fine. And what's also interesting is despite this case and since it, we still haven't found a single positive rabbit come up in our testing. But we know it's there. All right, the next case I'm going to talk about is, of course, SARS-CoV-2. Now, in this setting of One Health, we talk a lot about zoonotic diseases, obviously. But in my setting, in the zoo setting, we also have to worry about the opposite scenario, not just animals to humans, but humans to animals. And that's what we had here in this case. So we, unfortunately, did have SARS-CoV-2 infection within our lions, tigers, and hyenas at the Denver Zoo. Now, when the outbreak and the pandemic first started, and we, like any good cultural institution, shut down to the public, we made sure when we reopened, we were following mask mandates. We had one-way traffic flow. All of our animals, we double-checked, were at least 6 feet distance from our guests. And all employees were wearing masks and gloves when working with any mammals. because when this came out and of course was going around, we in the zoo community had no idea which of our animals would be susceptible and to what degree, what the clinical signs would look like, who might be severely affected. Of course, we could make guesses about the great apes and such, but we just didn't know. So the zoo committee was talking to each other, saying, are you guys seeing it? What's going on? And as it started to, spread around, we did see it come up. First, thankfully, the Denver Zoo was not the first to see it in our big cats. Other zoos did. So this is the states with different zoos that had it come up in tigers, lions, and gorillas. Over here is some of the less common species that ended up getting it. That, of course, little purple rectangle is Colorado. That's the Denver Zoo. We were the first, and still, I believe, only, to see SARS-CoV-2 in our spotted hyena. Yay! But, thankfully, when this happened, I'm going to explain that, don't worry. So, when we were, back open to the public with all these biosecurity measures in place for our keepers working with these animals, we were starting to hear from other institutions that the big cats were pretty susceptible and that they were starting to see clinical signs in them. And then, unfortunately, we started to see signs in October of 2021 in our tigers. Nasal discharge, sneezing, lethargy, slightly decreased appetite. We got permission from our state vet and our state public health department to test our tigers, and unfortunately, they were positive. Very quickly after that, our lion prides also started to show the same clinical signs: nasal discharge, lethargy, sneezing. We tested them as well, and unfortunately, they were positive. And then shortly after that, our spotted hyena, who live in the same building as the lions, came up positives as well. So when this happened, of course, we were in direct communication quite a lot with our state veterinarian and our public health department. Everyone was placed under quarantine. Our keepers were wearing Tyvek, glove, face masks, a lot of disinfection, because, of course, you cannot ask a lion, tiger, or hyena to wear a face mask while they're sneezing. So we knew from other institutions that this is kind of what it looked like, but what we didn't still know at the time is how long we were going to have to do this, and when would it end? So thankfully, all the animals had very mild disease, and they self-resolved without us having to intervene. But what we decided to do is we worked very closely with CSU Veterinary Diagnostic Lab, and we did serial nasal swab testing for PCR for viral shedding from our animals, because we wanted to know, when could we back off from our biosecurity? When would we be safe? The animals be safe, our keepers be safe, and try to get some really valuable data out of this unfortunate situation. So you're probably wondering, how do you get a nasal swab from a wake lion or tiger or hyena? And this is how. So we ask them to voluntarily participate in their medical care all the time. So we ask them to present for vaccine injection. We ask them to present their tail for voluntary blood draws. This is just modifying a station behavior where they press their nose to the mesh and hold it there. And then we just insert a nasal swab into their nose, and they get a very nice snack for doing this. And as you can see, we took a lot of swabs. This chart here shows all the swabs we took, starting with October 5th, 2021, and going all the way to February 1st, 2022. So red is positive, yellow is indeterminate, and gray is negative. So we had really long shedding. And we actually had recrudescence of shedding too. And so this was very interesting, and we wanted to make sure, like I said, that we collected this data, processed it, and got it back out there for other zoos to know what they were up against if they themselves also had this infection move through their collection. Because This is probably a lot longer than a lot of them were hoping for if in terms of just staff protection and PPE. So trying to make sure, once again, everyone stayed safe and healthy. So the last case I'm going to talk to you about today is, of course, high pathogenic avian influenza. Because as we all know, it is here, it is not going anywhere. And for me, it means I am at kind of a daily possible transmission risk all the time. And so, of course, in 2022, we saw it moving down through the flyways, headed towards our state. And all the zoos in North America were talking to each other. What are we going to do? What are we going to do to protect our zoo birds? What kind of biosecurity can we do? What kind of triggers should we have in place? All these things. We weren't quite sure what this is going to look like. And so Denver Zoo set up a bunch of triggers that if positive cases became at a certain distance from Denver Zoo within Colorado, we would do certain things. And on September of 2022, multiple of those triggers were hit, and so we made the decision to pull every single zoo bird indoors to try to cut off transmission, make sure it didn't happen. Unfortunately, 2 weeks later, in October of 2022, zoo birds became sick. We pulled them all inside, but we didn't pull them in fast enough. So, nope, it's going to wait for me. Okay. So, like I said, we pulled them inside. Oh, I don't want to play that yet. Or was it just going? Thank you. Okay, so we pulled them inside, and like I said, 2 weeks later, unfortunately, we had a Barrow's goldeneye, which is a duck species that lived with our flamingo flock, acutely die. No clinical signs ahead of time. We did the necropsy, and this is its heart. All we saw was streaking on the heart muscle, and then, of course, congestion in the brain, nothing else. We were concerned it was high pathogenic avian influenza, so we tested it. Unfortunately, 2 days later, one of our flamingos in our flamingo flock that lived with this bird began showing clinical signs. All right, I'm going to have them probably trigger this, but watch that bird in particular. All right, you can stop the video because it goes for a while. So unfortunately, it's kind of unfortunate, the bird became unable to stand normally, unable to hold its head normally, was having seizure-like activity. This progressed very fast to unable to stand on its own, and the decision was made to humanely euthanize this individual. We then, of course, tested it for HPI, and this individual and the goldeneye from a few days before came up positive for HPAI. So then, of course, we put everyone in quarantine. And we were in contact once again with our state vet and our state public health department. Our keepers were in full Tyvek, full boot, mask, face gloves, face shield when working with this group. And so the lucky thing is that is the only flamingo we lost to HPI. But we were doing serial PCR swabbing for viral shedding once again to see when they would clear it. And we know that entire flock had it and was shedding it among themselves. So they were all infected and all incubating it, but we only lost one, thankfully. It did take several weeks for them to clear it and for all the tests to come back multiple times negative before we could remove the quarantine status on this flock. But thankfully, we were able to with surprisingly minimal loss. So what we learned from that episode is kind of what told us what birds of our collection were most at risk. And so the flamingo flock had this large outdoor enclosure, no meshing over the top, very naturalistic. We would often see wild bird species come and join the flamingos. This is probably how they became infected. whereas we saw no other clinical cases or testing positive in any of our other zoo birds, the ones that were housed in more mesh-enclosed enclosures or other types of enclosures that weren't quite as inviting for those native wildlife bird species to come and join them. So we took that knowledge and started modifying our enclosures. Thankfully, the flamingo exhibit was already due to be rebuilt when this occurred. And this is our new flamingo exhibit. It's still an outdoor pond. It's just a little less naturalistic and a little bit less inviting for all bird species. Mostly it's designed specifically for flamingos, and we do not see wild bird species coming and joining the flamingos anymore. We also have the capacity now to bring them inside every night so that we can remove that possible contact period and also clean the area when they come back out so that we can remove any fecal material that could be from wild birds. So we, even though that was a very unfortunate outbreak that we had, it taught us about how to care for our wild birds better and how to modify the exhibits so that we could reduce the risk of transmission as much as we possibly can. Because HPI is here, it is not going anywhere. And we cannot pull all zoo birds indoors every single time there is a positive in Denver, or even Colorado, anything. That is not a sustainable practice and a way to move forward. So we took what we learned from this outbreak to make this kind of stable, routine maintenance to reduce the risk as much as possible. So we have guidelines for staff PPE in terms of not bringing stuff into the zoo, not bringing stuff out of the zoo, and how we don't bring stuff into enclosures just by walking, fecal material, all these things, so that the chance of transmission is as low as we possibly can get it. Of course, we are still doing our routine monitoring all the time of any wild bird that enters into our enclosures, especially if they are not healthy and not neurologically normal. But thankfully, we have not had an outbreak of HPI in a zoo bird since this original outbreak has occurred. So thank you very much for listening to me today. Just wanted to make sure you all knew that they are all doing quite well since these events have occurred. Thank you.
Okay, now I'd like to invite all of our speakers back up for the panel Q&A session. And I have
It's about the zoo. Yep. Ask if she's giving tours. Hi, thank you so much for those presentations. My name is Jillian. I'm with Denver Department of Public Health and Environment. I'm one of the EPIs. Dr. Hausmann, if you ever find that your schedule is light and you have nothing to do, we would all maybe love to come visit you on a tour. I did have a question. I just wanted to know if you have a favorite animal patient.
One, you are welcome to come join us anytime. We appreciate your guys' work so much, not only in these cases that I presented, but it's amazing. So please reach out to me. We can make that happen. I, as one of the clinical vets, am not allowed to have a favorite patient because the keepers will be upset with me, and there's a former keeper in the audience that will talk to the other ones if I tell you. So.
Thank you all so much. Those were amazing presentations. I have two questions, and Dr. Hausmann, there for you. One is, do you see any conditioned response from the animals when your staff puts on their PPE, like lab coat syndrome, like, oh my gosh, one of us is sick because they're putting on their gear?
So when the COVID pandemic came through, especially with our primates. We really upped our PPE and just the amount, like we were still wearing face masks because there are so many diseases even before SARS-CoV-2 that could transmit it. We used a lot of face masks and gloves ahead of time, but we did discuss that. We were worried, like, are they going to react differently to us? And they really didn't. Like, there is that initial, for many animals, it's the initial of, oh, there's something new. What does that mean? But once it becomes part of the routine, they see it. It is no longer scary or different. They still recognize you as a human. And many of the animals do recognize me as a vet versus their caretaker. And they know what that means usually more than, say, the PPE does, actually.
So fascinating. Thank you. My last question is just a terminology one. So I think you were proposing or stating that zooanthropognosis is human to animal disease. Is that what that word is meant to?
Yes.
Okay. I'm a little confused of the order of it. I would have assumed it would be anthropognoxic actually would be the term I would have thought.
The only one I have heard used is the zooanthropomorphic, if I can talk anymore. I have not heard other forms of it. If there are, I'm game.
And it is intentionally from human to animal, even though the zoo anthro.
Yes.
Okay, thank you.
Okay, I think it's working. Hi, my question is for Dr. Tracy Webb, and I just wanted to ask about the AI model. Since this is a One Health discussion, I wanted to ask if there were any environmental risks of using such a large model like this with all this data, and if it's environmentally conscious and sustainable.
Well, that's one of the reasons we've been looking at the smaller models. So, like I said, we did that one, the second project I talked about, where we're specifically looking, can we do this with the smallest energy requirement and smallest resource requirement, because that's really important to me. It's actually something I think is, I love that people ask that question. The students that we work with are really interested in that as well. So I think the push is, can we do this with the smallest amount of resources and still get really valid results? So that's the goal. So.
Hello. My question is for Dr. Colleen Webb. You may have reviewed this in your presentation, but I was wondering what the time lag is with the predictive modeling in your transmission.
Sorry, I'm
like how fast in real time could you have a predictive model made to see like how risk areas for disease?
Yeah. So these models run on the order of at most a couple minutes on a laptop. So very, very quickly, as long as it is in beef cattle, dairy cattle, or swine, which we already have all set up. And part of the point that we see so much of the outcome dependent on the demographic piece is that it's really interesting to see that we can get pretty good results even on something like HPAI, where we don't have a lot, at least at that time, right, didn't have a lot of specific data about the pathogen. So I would say very quickly, when, like, in order to make one of the maps that I showed, that's probably what, like, I'm looking at Christopher because he's been doing those most recently. I mean, it's like 1.4 million runs or something that's included to make one of those maps. And it depends on the size of the outbreak, how long that takes to run, but a couple days. Yeah, 24 hours. Yeah, so we can do quite a lot. And when we do the sensitivity analysis, so like when we're looking at different control strategies, for example, we can run on a subset of states that we know are important and get quite a lot of information. So we can be even faster than that if we need to be. Yeah. And I would just say that's one of the things that we've worked on with these models. When we started, it's been about a 15-year project in total. And when we started, one of the big issues was actually being able to inform national scale questions because the computer models were so big and ran so slowly that you couldn't actually do this kind of work. So we've actually intentionally done some sort of computer science work in the background as well to try to speed things up. So yeah, thanks for that question.
Hello, I also have a question for Dr. Tracy Webb. Are you aware of any template data dictionary used in joint human-animal outbreak response?
The only thing that's coming to my mind, and this may be just that I am either unaware or can't think of it right now, is some of the larger data sets and these standardized terminology resources that are available currently. So things like the Mondo one that I had up there, which is really trying to look at disease, not specifically just like infectious disease, but all types of disease. I don't know if that helps.
Oh, this is for, question for Dr. Webb. Thank you so much for the pet companion and human data registry. I think my question or my first thought really pops up is, and I'm not familiar, but the rules and regulations, in the vet world and maybe human clinical medicine around privacy and data protection. So thinking about, is there work in this space as we move towards linking those data sets or with helping support staff who might not be bound by HIPAA to get, to use human health information. I'm just thinking like, are there similar, privacy rules or, work to update policies on helping staff understand what the restrictions might be with that data? That was a very convoluted, but I think you get the drift.
No, I get the drift. I totally get the drift, and it actually is funny because people are constantly like, why are you talking about data governance? Like, where is that coming up in your life? I'm like, everywhere in all of this data stuff that I'm doing. So at least you would understand where people are like, why are you talking about AI guidelines? I'm like, because it's like all, kind of like that you have to code the records to get to where we can actually use them the best. Same thing. We have to have good data use agreements and information so that people feel good about it. That's part of what's involved in those surveys is like what pieces are most important to individual people to make you feel comfortable. And one of the people who actually developed the CURL, which is this, and I'll forget, I wrote it down so I won't forget. This was my catastrophic thing. The Colorado University record linkage, which is where this happens, had done some dissemination and surveys for people to see, can we give them information so that it helps in them understand why this is important and the practices that are being used, that they feel more confident that their information might be included in this. And so part of the thing that we're doing is all of this is happening in a HIPAA compliant, the Health Data Compass CURL at UC Anschutz, because we don't want to take out the human health data because then we'd have to talk with people who don't usually deal with HIPAA needs, which is on the veterinary side. Now, we generally try to take very good care of our data, like you probably do at the zoo too. We're trying to use HIPAA-like practices, but we don't have the same laws related to HIPAA data because it's animal health data. Again, part of the reason we're asking survey questions because a lot of times people are really interested in sharing their animal health data, even if they're a little bit more concerned about their personal health data. And so that's one of the things, but is a huge part of this in the process of creating the registry is how do we 100% make sure we're doing our best data handling practices to comply by legal requirements, but also just do best practices around the whole thing. And that is actually one of the aims of our funding is to develop some of those things. And very interestingly, we've had recent conversations of, okay, so we're starting with our questions, right? But the whole goal is that this is something that people could query, right? So that you could say, well, I'm really curious about this infectious disease, and I'd love to get that data set. And so there's interesting conversations across these big data sets. There have been other human data sets, like the NC3 came out during COVID, and brought a whole bunch of human health records together, and now that's kind of being expanded as just one example on the human side that they have done some of this already. And so taking some of their experiences to bring together and thinking about who gets access to that data and what does that look like. And so one option is just that, and that's what we're currently working in, is that even me, as one of the study PIs, I'm only going to get aggregate data out of there. I don't get to see any individually identified data. And so that I can just ask the people who have all the training, who are within that HIPAA compliance system, to just give me aggregate de-identified data, and that's all I see, even as somebody directly involved, because I don't need to see it. I can tell them the questions that I want. So I think it's a great question as when we think about these very interesting questions or data sets that we could learn so much from, but how do we make sure we're doing that as securely and responsibly as we can? So it's a huge part of this that, again, seems like a side note, but I'm really glad you had asked about it. So.
Okay, I think that that's all the questions we have time for. Again, if you guys want to email us any questions or
All right, I'm going to ask everybody to take your seats for our last session. All right, we're going to go ahead and wrap up our conference with our last session. And all of our talks, of course, have had these trending themes of collaboration, data protection, zoonotic disease, and the environment. And we're going to end with One Healthy in the Environment. And our first talk is on Coccidioidomycosis. It's co-presented by Taylor Foley and Peter Kessinger. So Taylor Foley is our One Health epidemiologist at CDPHE. Her work focuses on the surveillance, prevention, and control of zoonotic diseases throughout the state and providing consultation to local public health agencies, academic partners, medical and veterinary professionals, members of the public, and other stakeholders. And I will go ahead and also introduce Peter, who will speak after Taylor, who is a PhD student in the College of Veterinary Medicine and Biomedical Sciences with the Department of Environmental and Radiological Health Sciences at Colorado State, working with Cheryl Magsamen. He is currently working on several infectious disease projects, including vector habitat suitability, fungal spore aerosolization, and pathogen habitat suitability. All right, welcome, Taylor.
Hello again, everyone. I'm going to start out this talk on Coccidioidomycosis, which I will be referring to as Coxie from this point forward because I don't like pronouncing it. And then Peter will follow up after me with some interesting work he's doing with ecological niche modeling. Okay, so just as an overview, Coccidioidomycosis falls under the umbrella of endemic mycoses, and these include blastomyces species, Coxie species, and histoplasma species. It's sort of a misnomer in Colorado because none of these pathogens are endemic here. They are endemic in other places. All three of these exist as dimorphic fungi, so both single-celled yeasts and multicellular mycelia, and they are opportunistic pathogens. So they occur naturally in the soil. That's their natural habitat under various conditions depending on which fungus it is, and then infection usually occurs when you breathe in the fungi. So these tend to be very underdiagnosed and underreported. They really tend to mimic viral and bacterial pneumonias, tuberculosis, or lung cancers. They can cause disseminated infections and death, and only a few states report cases. In Colorado, this became reportable in the fall of 2023. And I'll go over some of that data with you guys today. But the purpose of this surveillance is to rule out locally acquired cases. I said it's not endemic here. We want to make sure that we know if it ever does become endemic. And it also hopefully will help better characterize the national incidence because we don't have great data on that. So for cocci, it's also called valley fever. It's endemic in the Pacific Northwest, in the Southwest, Mexico, Central America, and South America. We see a lot of cases from Arizona. That is where it's the most prevalent. They have between 11,000 to 16,000 cases reported annually. And then across the U.S., the CDC reports about 20,000 cases and about 200 deaths per year. We estimate that the true case burden is much higher, like 10 to 20-fold higher, and that the true death rate is between 700 and 1,000 people per year. It's reportable in 29 states, but again, we don't fully know the full range. This is a map of where it could be more likely to live or possible for it to live based on modeling done by the CDC. We don't know the full extent of the possible range at this point. So this fungus grows in soil after heavy rains, and then the spores disperse into the air when the weather becomes hot and dry, and it develops into its yeast form in the host. It prefers to live in places with hot summers, mild winters, and little vegetation. So what this tends to look like in Arizona is they will have a very heavy rain season, and then everything dries out, it gets hot and dry, and then wind or other activities stirs up that dust, and the mycelia stage, the spores become dispersed through the air. It's really difficult to avoid in areas where it is endemic because it is sort of kind of all over the place. The geographic range of this fungus is expected to be impacted by climate change and expansion of industrial agriculture, removing that vegetation and creating more habitat for it to live in, which is also why we are doing this surveillance to see if it moves on into Colorado. And then windstorms have potential to carry spores to non-endemic areas and cause outbreaks, but in general, outbreaks tend to be sort of rare. So as I said, it's typically acquired through inhalation from the environment. It's very difficult to avoid breathing it in where it lives. Rarely, people might get it from organ transplants or contact with contaminated objects, such as there's cutaneous cocci infections, but those are much rarer. Pets and livestock are susceptible to infection, but it does not spread from animals to people or between people. Rarely, the infection spreads from the lungs to other parts of the body, like the skin, the bones, the joints, or the brain. And then again, outbreaks are rare. So let's talk about the epidemiology of it in Colorado, what we know so far. So I only have 2 years of data to go off of, so it's not super great data yet, but the numbers look somewhat similar between the 2 years. We have 29 confirmed cases in 2024 and 35 confirmed in 2025. The gender breakdown, it tends to be a little bit more common that males get this. The average age is in the 60s, 61.4 versus 60.4 years versus 61.6. And then both years, we had a roughly 5 to 6% mortality rate with 2 deaths each year. All 4 of these deaths were in males who were older, and all had some sort of underlying condition, from a double lung transplant to COPD and a heart transplant. It's very common for people with transplants to get this and have it cause more severe illness. So for all of these, we follow up with all of the positive cases, and we want to see where they got it, if they have any travel history. And so far, everybody we've been able to contact has had travel history to an endemic region. There are some that were lost to follow-up, but Arizona is, for both years, the highest, with about 70% of cases in 2024 and 51% in 2025, and then followed by California with 11.8 and 24.3 respectively. And this is sort of what we see on the national scale. These states have the most cases overall. California has between 9,000 and 10,000 cases annually. And like I said, Arizona has 11,000 to 16,000 cases annually. So for risk factors, it's not super surprising to see these sorts of risk factors, especially in the age group of the people and the underlying conditions that tend to be common in that group. But they do, we do see a lot of chronic heart conditions, chronic lung conditions, autoimmune diseases, and then transplants. About 35% of our cases are current or former smokers. And then several have different substance abuse disorders as well that can impact their immune system. For the diagnosis, most had acute pulmonary coccidioidomycosis, and this comes from the medical records. A lot of them were not actually specified. The doctors didn't know the exact diagnosis or did not include that in there, mostly with chronic versus acute pulmonary versus the lung granuloma. Okay, so for the breakdown of where we see these cases within the state, they tend to be pretty focused along the Front Range, which makes sense. That's where most of the people are, where we would see the most of the cases. To me, that's sort of reassuring because if it was going to become endemic in Colorado, we would expect it to be more in the southern half of the state, where those environmental conditions sort of match their conditions in Arizona and California, where they're most common. And we're not really seeing an increase of cases there, so that is good. Okay, so for the future, as we keep collecting this information, we want to assess the general trends in Colorado, see what things look like from year to year to year. For example, is that 70% of cases from Arizona down to 50%, is that a normal fluctuation, or was 2024 a weird year? We want to learn more about information about the exposures, like occupation, specific outdoor activities that they did in these endemic areas, time from exposure to symptom onset. And we want to determine the time between symptom onset and diagnosis. Some cases get identified really quickly, but since it's not super common in Colorado, it can be quite a while, and it can be hard to identify exactly when they got this disease, especially for people that have some sort of chronic lung condition. They have a chronic cough. Suddenly it gets worse, and they finally go to the doctor because they feel sicker. It's hard to say if they, got Coxie 2 years ago when the cough started, or if they just got it recently and the cough is from some underlying condition. We'd like to assess trends in seasonality, such as what time of year do exposures occur most often. And again, this is challenging due to those delayed diagnoses. And then we want to analyze risk factors for more severe infections, like age, sex, underlying conditions, et cetera. And with that, I will pass it off to Peter.
Thank you, Taylor. All right, so yeah, I'm Peter Kessinger. I'll pick up on predicting Coccidioides presence using a One Health approach. And in this case, we're going to be looking more at the pathogen itself rather than the cases. So I'm going to echo some of what Taylor already talked about, and especially when it comes to the challenges with surveillance. So I also apologize, this is going to be a bunch of text, but then I promise it turns into a picture book. So Coccidioides is difficult to detect via common surveillance methods, especially around that environmental type surveillance. You can do environmental surveillance, looking at air sampling, passive or active. You can do soil sampling, even going out and digging out your soil samples. They work, but it's difficult to find the organism. You can be picking up a positive and immediately close by in similar conditions find nothing. It comes down to luck. The air sampling works, like I said, but it can have a very low prevalence, even in areas where we know they're highly endemic, especially by caseload. Case surveillance is also tricky to use due to the incubation period, like Taylor brought up. It can be 2 to 4 weeks long, and that can often introduce recall bias. When you ask your patient where they went, they might not know where they got exposed. And also, they are often reporting by place of residence. So as noted with travel, you may be reporting from where you live, but that's definitely not matching up with where you actually got exposed. As Taylor talked about as well, those 60% of cases are actually popping up as asymptomatic. So you may have cases that you got exposed, you had coccidioides or coccidioidomycosis, but you never presented, so you didn't go in and get tested. So we have another group where they don't know they're sick. Whoop. They don't know that they're sick, so they didn't give us those presence points. Of the ones that do become symptomatic, approximately about 40% of those cases, they might self-resolve, or they might be misdiagnosed, but there's another group that we're missing for looking at presence of where we might be finding that valley fever or coccidioides. Due to this, we, as Taylor brought up, we have an estimated load of maybe 200,000 to 360,000, but we're only getting about, across the United States, about 20-ish thousand. So using cases as a proxy for presence to model habitat suitability for coccidioides in terms of the pathogen can be challenging. It's not going to line up with what we'd expect where you might got exposed, and we're missing a large chunk of data. But at the same time, when we have challenging issues with environmental sampling, it's the data we have to work with. So the challenge becomes, how can we turn our case data into coccidioides presence points? This is difficult to do with human data due to what we already talked about, as well as for the reason of their propensity for travel. So going on vacations, going on weekend hikes can change your environment drastically. To try to fill in that gap, we want to take a One Health approach with a sentinel species. Dogs get coccidioides quite similarly to their human counterparts. They have similar rates, similar clinical presentations, and they tend to be tied with us pretty closely, especially around home life or everyday life. However, they don't travel as much as humans, and so they're typically confined closer to their places of residence, and their activity is going to match up more with their exposures. Their behaviors can also mimic certain high-risk activities, such as digging in the soil or breathing in that soil, especially when your dog's sniffing around. That can mimic high-risk activities like construction or different occupations like agriculture, where you might get those higher exposures from soil disturbance. As such, we think dogs are a strong sentinel for coccidioides that are generalizable to humans. So we took both human and dog cases from Arizona. In the case of human cases, they were from the Arizona Department of Health. And for dog cases, we ended up simulating using the American Veterinary Medical Association data for a survey of dog ownership, census data for population, and then there's been some recent literature talking about the serologic prevalence in dogs, sitting around 37.6%. And we incorporated all that to simulate a dog case layer to be another layer of presence points on top of our human. We used MaxEnt and random forest models to create habitat suitability models of where cocci might be. One key thing here that we wanted to do is we took background points drawn from population density weighted rasters. So we know that our case data is going to be skewing and biasing our work in terms of if we're trying to find the actual pathogen's habitat, because all we're going to be modeling then is what's a good place for a case to show up. So by pointing out that we are already getting all our cases in urban areas, which are not suitable environments for coccidioides due to concrete, different land use that isn't conducive to having desert soil or vegetation, then we told our models to form more of our background around those urban centers and try to focus more on the points that don't line up in that urban center. So we get more focus on the points that might have habitat that is actually suitable for coccidioides. So our final model ended up looking at that presence point, and then as a function of soil temperature plus soil moisture, pH of the soil, specific humidity, wind speed, and land cover or land use type. We did 4 models. We had both human and dog represented by color, purple being dog, blue and human. And then we had our MaxEnt as circles and our random forest as triangles. We have our model performance as AUC, or area under the curve, on the y-axis. And then we have our study period from 2004 to 2023. In general, we saw that, and we have 4 colors on this plot. We have our white color here, which is going to be our poor or bad performance. Basically, we're going to be guessing. In our orange, we have an okay performance. We're able to have some ability to discern a pattern, but we're still kind of struggling with environmental noise. In our blue, that's basically our ideal zone. This is a good performance where we're able to parse out a lot of the noise and have good prediction. Our green is technically the excellent category. I would take that with a grain of salt in that there's the risk that it's overfitting once it's getting closer to that 1. Both the random forest models were sitting in that excellent category, with the human being closer to the top, dogs being slightly lower, just above the 0.9. And then our human maxent model sat in the good region, and our dog maxent model sat in the okay region. This is a map of what our presence points ended up looking like, overlaid over a habitat suitability prediction that we did for the year 2023. But as you can see, our human cases tended to cluster, there we go, around urban centers. In 2023, we managed to get some poking away from those. And then our dog layer still had signal around urban centers, but it spread out much farther. Oh, and also we had more simulated dog cases than human cases. This is what that habitat suitability prediction ended up being. As you can see, the human model in the maxent category, struggled to get away from the urban signal. So our maxent, it was able to capture some of where we expect to see suitable habitat for the pathogen, but we're still seeing it say that high concrete areas might be suitable as well. And we know that, in fact, that's just struggling to get away from, this is just a good case. The dog model did better at moving away from the urban area. It didn't diminish it completely, which we didn't want to just eliminate it, because there could be some land use, especially on the outskirts, that might be conducive, such as open spaces, parks, construction activity. But at the same time, it did better at matching up with literature of different papers that also looked at environmental suitability for the pathogen itself. So even though it had a lower performance in the AUC, it seemed to be doing better getting out of the urban areas. This is the ensemble where we just took the mean of both models to try to neutralize the extremes. And we're able to reduce the overwhelmingness of the urban centers while keeping some of that environmental or non-urban signal. And then this here is looking at a sentinel difference map of comparing where the human model was driving versus where the dog model is driving. So with purple, the dog model was driving the suitability. Orange, the human model was driving the suitability. And then white, you're seeing about equal driving by both models. Our random forest had some similar signaling. The left side here, once again, is the human model looking at the urban centers with some similar signaling as we saw with the maxent. And then the dog model with the random forest struggled a little more with the urban centers, but was able to, once again, spread out as well. We ensembled the random forest again, like we did in the last one. Urban centers were being a little more driving in this one. And then a sentinel difference map for the random forest as well. Finally, we put all of it together. So we combined the maxent model and the random forest model outputs, as well as both species. The urban centers still were poking through, but we were able to capture suitable environment outside of those urban centers. And then, once again, we see that the urban centers are mostly driven by a human model, whereas outside of that is mostly a dog model. And that's the side-by-side comparison of the maxent as well as the random forest for the driving models. And then, so the takeaway here being that we can try to use animal data to push the boundaries with what we have available data-wise, because often with the model, as to echo what we've been hearing, it's only as good as the data you can put in, garbage in, garbage out, things like that. So we are working with the data we have, and it's difficult to get the actual environmental sampling. So by incorporating both human and dog data in a One Health approach, we can try to improve our surveillance and point others to where they might be able to allocate resources for on-the-ground surveillance. This was where we took our model and put it over Colorado. We still believe this is urban signal, perhaps human population here. But in the literature, we did align with some habitat prediction. This isn't confirming it's there. This is just saying these areas could be suitable if Coccidioidomycosis.
Thanks, Colleen. I think you did get us uplifted with that talk. All right.
thanks to everybody for hanging in there for the whole day. We have one excellent speaker to wrap us up, and I want to thank all our speakers today on keeping us right on time. So I'm just going to knock on wood because that's probably unprecedented. So I'm excited to introduce Dr. Tony Schounz, who is interested in understanding immune responses of reservoir hosts, particularly bats and rodents, of emerging zoonotic viruses that typically lead to apathogenic infections in the reservoirs, the role of immunopathology during viral infection and vaccine development, and it's too late to say this, immunomodulatory therapeutics for zoonotic viruses. Current projects in the lab examine coronavirus, Henipavirus, and H18 bat influenza A virus infections in bats, bat cell responses to viral infections, transcriptional, proteomic, and metabolomic profiling, and bat T cell responses to viral infections. All right, welcome, Dr. Schounz.
Boy, can I clear a room or what? So my talk is going to be a little different than most of the ones you've seen today. My lab is mostly an experimental lab. We do a lot of hypothesis-driven research, but we also do some field work as well, because our central philosophy of the lab is that all of this laboratory experimentation that we do, it doesn't matter, it doesn't mean anything, unless it's also happening in the real animals out in wildlife. And so we try to define what might be occurring in a certain system, whether they're rodents or bats, and then see if that's also happening in the natural world. And that's the only way you can really draw really meaningful conclusions about what your systems might be doing. And so it's now 26 years that we founded our deer mouse colony. We captured our founders over by Whitewater, Colorado, which is south of Grand Junction, up on the Grand Mesa. And this was an area where Sin nombre hantavirus was endemic. We were focusing on that virus at the time because of its cause of hantavirus cardiopulmonary syndrome. And we quarantined these deer mice that we captured. A couple of them were infected, and so we just released those. But the remaining animals were uninfected after 46 days, and so we brought them in to found our colony. And we've had them ever since then. And unfortunately, the hantavirus work started to wind down around 2018 or 19 because I'd had funding from NIH for all that time, and then suddenly, the money didn't come in, and it made it really problematic. And I hate to say it, but it turned out that COVID was kind of a blessing for our deer mouse colony because they're very susceptible to SARS-CoV-2, and we immediately had funding to do SARS work with these animals because they get the same disease that Syrian hamsters do. The difference is that deer mice will live about 8 years in captivity, unlike Syrian hamsters, which die in about 2 years. So if you want to do long-term infection studies or long-term immune recall, or perhaps even develop a model for long COVID, then this is probably a small animal model for that. So we're still working on SARS-2 with these rodents, but my first love is hantavirus. That's one of the first project I got involved with when I moved to Colorado 8 years ago, however long ago it was. So there are lots of hantaviruses. I know this is probably review for some of you, but probably new to some of you as well. And they've been known about for quite some time in the old world, right, where they mostly cause kidney disease, right? So the case fatality rates, the infection fatality rates are much lower. They're typically anywhere from about 1% to 15%. Whereas those hantaviruses in the New World that cause disease, that principally are causing pulmonary and cardiovascular disease, they have a case fatality rate of upwards of 70% untreated, and even when treated, it's down to about 35% or so. And I want to point out that even though there are lots of different hantaviruses that cause disease in the New World or even the Old World, the clinical presentation is pretty much the same. And so regardless of what virus is causing the disease, you still end up doing the same clinical management for those patients. This is the most recent map that I could find at CDC from 2022 that shows the case distribution. And we're still number two in the country. We can't quite catch up with New Mexico, but Who knows, we might one day. I saw in the news the other day that we're expecting a pretty significant El Nino event this year, right? And this all started back in '93 following a really strong El Nino event. So I'm kind of curious to know how this season might unfold. I've only been doing this for 20 years, and I can't tell you anything about how things might happen because the pattern doesn't seem to be emerging that's clear. So although not a significant disease burden in the United States in terms of public health incidents, if you get one of these viruses, you're in real trouble, and you need some urgent and highly focused medical care to survive this infection. The disease, of course, was called hantavirus pulmonary syndrome at the beginning, but I think most of us now refer to it as hantavirus cardiopulmonary syndrome because there's a clear cardiac involvement in this disease, and that's probably what ends up leading to the patient's death anyway. And it starts out with these, typical flu-like symptoms that then progress to acute respiratory distress syndrome in these patients. And blood bank studies have shown that if you get Hanta, you're probably going to get disease. It's not like West Nile where only 1 in 5 persons is going to get clinical signs of disease, right? If you get one of these hantaviruses, you're going to get sick, right? And so what happens then is that you get capillary leakage, plasma gets out of the blood vessels, blood pressure drops, heart tries to compensate for that drop in blood pressure, tries to build up the blood pressure. Unfortunately, all it does is pump more plasma out into the tissue. Just like if you have a garden hose and you go start poking holes in it, the water's going to come out of that hose. And that's actually what leads to the cardiovascular event that leads to the death. The problem is that your lungs have the surface area roughly equivalent of a tennis court. And so when you have lots of plasma leaking out of that big of a surface area, that's what causes the significant burden on the heart that then leads to this significant disease. And the target cells are capillary endothelial cells. And what's peculiar is that we can infect these cells in the laboratory with hantaviruses, and they look perfectly fine. They don't seem to have any adverse effects of being infected. Yet in the patient, they end up leading to this really pronounced inflammatory response that leads to the disease. And the care now, of course, is extracorporeal membrane oxygenation, which is this heart-lung machine where they try to relieve the pressure on the heart to keep the patient alive long enough for them to recover from the infection and hopefully clear it. So if the virus isn't doing too much damage to the cells, then the question becomes what's causing the disease? And the evidence started to emerge fairly early, that this was probably an immune pathology. In other words, the patient's own immune system is what's killing them. So there's this very rapid and robust immune response against the virus that leads to inflammation. And that then leads to the death of the patient. So just bear in mind, your immune system is inherently dangerous. It will go after a pathogen and it will try to get it under control. And if you die in the process, well, that's just an unfortunate side effect, right? And that completely changes how we should think about treatment of the disease. Forget about the virus. If it's really not doing anything, what you want to focus on is the immediate threat. And that, of course, is the immune response. You have to temper that inflammatory immune response in some way that can then keep the patient alive long enough. And there are a lot of strategies that are being employed right now to maybe help move this along. Okay, so the natural cycle, as I've alluded to already, is rodents for diseases in humans. These other species, shrews, moles, and bats, are also reservoirs of hantaviruses. So there are literally more than 100 known hantaviruses globally. Only some of them are known to cause disease. It doesn't mean the others don't cause disease. They could. It's just that bats, moles, and shrews typically don't move into your homes, unlike rodents. Rodents are peridomestic. Many species are very happy to move into your basement or into your outbuildings, and they're perfectly fine living in proximity to humans. And so these are the animals that host these viruses, and in all of these cases, as far as we know, they never get disease. We've infected a couple, 300 deer mice over the decades with sin nombre hantavirus, the one that causes most diseases in North America, and not one of them has ever shown any signs of disease. They're perfectly fine. Okay, so it's an innocuous infection in the reservoir. The other concern that we have is that these viruses have 3 pieces of RNA, and they encode different proteins. And so if you get an animal infected with 2 different hantaviruses, just like with influenza, they can exchange that genetic information, which can then lead to novel genotypes of viruses. So we've seen this happen with a few of these hantaviruses, but as a rule, this doesn't happen too often because the rodents are very specific for their hantaviruses. So the likelihood that 2 hantaviruses can infect the same species of rodent is extremely low. And this seems to be a barrier to doing this process of genetic exchange. But in the laboratory, you can infect cells and get these different types of viruses to come out. Okay. All right, so here's typically what happens. The rodents get infected out in the wild. They're infected for the rest of their lives. They can't clear the infection. But who cares? It doesn't do anything to them, right? It's an innocuous infection. But then they encounter humans, and by typically moving into outbuildings, and humans will go into those buildings, or sometimes they get into the crawl spaces of homes, and then virus gets shed in the excrement of these rodents, and then they get infected in the humans. And then you get this massive inflammatory response that seems to be mediated by these immune cells. Principally, what we think is happening, at least in the New World hantaviruses, are your adaptive cells, so cells of your T cells that are part of your immune response are contributing to this. And this may be why you get this really massive immune inflammatory disease that kills the patient. Okay. All right. So my friend Rick Yanagihara at the University of Hawaii, he thinks that bats are the original sources of hantaviruses and that they jumped into other species, including rodents, and diversified and then became the viruses that we know about today that are transmitted from rodents. Okay, so there's not a lot of progress. There are no vaccines. There are no good therapeutics that have been developed. There is a really good monoclonal antibody right now that's being tested in Chile that was actually from a patient who had Pumala hantavirus, which is an old world hantavirus found in northern Europe, carried by voles. And what they found was that this antibody could bind to a South American hantavirus, which is the correlate of sin nombre hantavirus that we have here in North America, causes far more disease cases in South America than we have in North America. Unfortunately, this antibody didn't bind too well, but it did bind a little bit. And so they went in and they altered the gene sequence of the antibody genes from those B cells by sequencing them, and then they cloned them, the genes that encode the antibody, into another cell line. And all that cell line does is make this antibody. It's very efficient. And because of all this structural biology that can be done now, right, we have tools that can do molecular modeling so well that you can build molecules that don't even exist in nature to do certain biological tasks. They were able to refine this antibody, so now it works not only with Pumala virus, but also with Andes hantavirus. And so it's a very good, potent therapeutic antibody that can be used. And right now, it looks like this is really the only therapy for treating a hantavirus disease, other than supportive care with ECMO for human infections. Okay, so we also have these antibodies to sin nombre virus, but there are no pathology models for sin nombre. So you can put sin nombre in a few rodent species, but none of them get sick. And if you want to study efficacy of a drug or a therapeutic antibody, then you need a pathology model in which disease occurs. So there's no model for sin nombre. However, Andes virus has a really good model. It's the Syrian hamster, universally fatal in those hamsters in about 10 to 12 days. That's not really recapitulating what happens in real life, but it's the best thing that we have right now. So keep Andes virus in mind, because I'm going to come back to that one in just a minute. So here are some of the species of rodents and their hantaviruses that they host, right? So Hantan is in the demilitarized zone of Korea, where North and South Korea are meeting. And this was the first virus described in this group, and it was because of U.S. servicemen who were coming down with this Korean hemorrhagic fever that turned out to be caused by this hantavirus. It's actually an episode of MASH, so if some of you young people probably don't know what MASH is, but there was an episode on Korean hemorrhagic fever, and it was around Hantan virus. But down here we have sin nombre virus, and it's hosted by Paramiscus sorinensis, which used to be called Paramiscus maniculatus, and so now they've been divided into 2 different species. And this is found in the western USA and Canada. And then I just want to point out El Morro Canyon virus, which is hosted by the western harvest mouse, Rhythodontomys megalotis. This is a very common rodent in Colorado and Utah and New Mexico and Arizona. And we trapped a bunch of rodents on the east side of Colorado. We captured deer mice and we captured western harvest mice. The only ones that had hantavirus were the harvest mice, and they were all El Morro Canyon virus. So I wonder if some of those human cases that have been found on the eastern steppe of Colorado weren't caused by sin nombre, but instead caused by El Morro Canyon virus. But the antibodies cross-react, and the diagnostic test is antibody testing. So we don't discriminate it unless you go in and you do PCR and sequencing on, for example, a specimen that was taken from a human. So we may have another pathogenic hantavirus in Colorado. Okay, so we're interested in why don't these deer mice get sick? And if we know what's happening in humans, that is, it's their T cells that are probably contributing to the disease and killing these patients, then what's happening with the T cells in deer mice? And so we developed this assay many years ago where we have 1, 2, 3, 4, 5, 6, 7 deer mice that we infected with sin nombre virus. This was in collaboration with Brian Hell at the University of New Mexico Medical School. And then 10 days later, we euthanize those deer mice and we look at how their T cells respond when we put virus proteins in with the T cells in culture. And then we can measure by PCR the expression of genes that contribute to T cell responses. And what we found was that in these deer mice, they seemed to look like a mixture of different cytokines that were being expressed that suggested a mixed T cell response here. However, when we took them out to 40 days, and I think there's a missing, maybe it got dropped on the conversion to Google presentation or whatever it's called. These are actually euthanized on day 40. So they were infected, and then 40 days later after acute infection. And now all the T cells, they sure look like they're making these anti-inflammatory cytokine, TGF-beta1, right? And so this is what we think is why deer mice don't get sick, is they make the complete opposite immune T cell response than what humans do. Unfortunately, because of this, this is probably why they're infected for life, right? So they get infected and they can't clear the infection because they make this anti-inflammatory response. And I don't know about you, but if my spouse is recovering from Hanta, I don't want her to be infected for the rest of her life. I'm sleeping in another room if that's the case, right? So we need to come up with a way of controlling the infection without disease and also ensuring that we clear infection, right? So that's sort of the goal of the ideal hantavirus treatment. Okay, so I'm going to show you this map. Here's our friend Andes virus, and the question is, what happens if you put Andes virus in deer mice, right? So this is a non-cognate reservoir host system with another hantavirus, right? So that was the project that we did several years ago. And it turns out that within a couple of months, these deer mice clear Andes virus, and they don't get any disease. So they get infected, they mount an immune response, they clear it, and they're perfectly fine the entire time, no disease at all. And so when we looked at their T cells, like we did with the previous study with sin nombre, right? So we infected them either with sin nombre or Andes virus for 2 weeks, and then we took their T cells out and looked at their gene expression after we gave them the virus, the proteins from the virus to stimulate them. And I don't think I have to convince anybody here that there's a difference in the patterns, right? So deer mice make this really subtle immune response to sin nombre virus. And that makes a lot of sense. It's an innocuous infection. It's not bothering me too much. I'm not going to waste a lot of effort trying to get rid of this infection, right? On the other hand, with Andes, the deer mice haven't seen this virus before, and Andes hasn't seen the deer mice before because they're hosted by a different species of rodent, the long-tailed pygmy rice rat that's only found in South America. And what you can see is that there are a number of these genes over here that are getting expressed. And then, so these are 7 deer mice, and when we look at the antibody responses of these deer mice that have Andes virus, there are these 2 deer mice that stood out from the other 6 deer mice that received Andes. And they also had a much higher antibody response. So when we took the total gene expression profile of these 2 animals compared to the other 6 Andes virus-infected animals. It looked to us like the answer is that these deer mice make a much more robust and aggressive T-cell and antibody response to Andes virus, and we think this is why they clear it. But it doesn't lead to pathology, right? So this is the only rodent model, in which you can infect with a hantavirus and get clearance without disease. All the others are either persistent infection or they get disease and die from it, right? So this is the solution is in here somewhere. We can learn something about how to deal with hantaviruses using this deer mouse Andes virus model, right? And that's what we're working on. So what we know is that to Cassandra virus, you get this anti-inflammatory immune response, but the cost is you're infected for the rest of your life. That's not good. We don't want that. But on the other hand, if you infect with Andes virus, you get this really aggressive antibody and T-cell response that clears the infection and without disease. So we've got this model now in place that we've just started working with in the last few months where we can do these things. So the idea is that can we develop some sort of therapeutic regimen for treating humans that might have hantavirus infection in such a way that we can minimize the pathology so they don't have to go on ECMO, yet still allow them to clear the infection. So these deer mice know the answer to Andes virus. Can we learn what that answer is? And then I don't do drug discovery or any of that stuff. I handed the data off to somebody who does, and they figure out how to make that, okay? So we now have these really cool technologies that we didn't have, 10, 15, 20 years ago. And these are some of them, right? RNA sequencing. What genes respond to an infection? So you infect an animal, you take the tissue that's infected, or if you're interested in immune responses, you take the spleen or lymph nodes, and then you just look at the expression level of all the genes that are in there. All of them. There's like tens or hundreds of thousands of transcripts that you can quantify. It's just so much data, it's overwhelming. Now we have single-cell RNA sequencing where you can look at the RNA expression of individual cells, right? And this can tell you what types of cells are responding to that infection, right? So we now get to see the genes that get turned on, which cells are making them, and then finally we can do flow cytometry assays which will tell us how many of those cells are responding that have that certain genetic profile. So we have this sort of 3 sets of novel technologies that are going to, we hope, conspire for us to help us get some clarity on what might be happening in these animals. And the other cool thing is we now can knock out genes in deer mice. So if you don't know about this, if you want to know what a gene does, you disable it in an animal, right? So we all get 2 sets of chromosomes, one from mom, one from dad. In this animal, we've knocked out a gene called STAT2. It's critically important for antiviral responses. And then we can now do the experiment where we put Andes virus in them and ask the question, what does STAT-ROL do for these deer mice when they're infected with a hantavirus, right? And what happens is they get a much higher viral load compared to the wild type. So these are STAT2 knockouts on day 7. And even at day 21, we're starting to see that they're clearing the infection. So even without this important antiviral gene, they're able to get the virus under control, right? So they still don't have any disease, right? So now we have this way of looking at this. What was cool was that we did this study where we infected some of these deer mice with either Andes, the wild type, or the STAT2 knockouts. And then we let those go for 10 days. I think it was 10 days. And this is just two profiles that were generated from the expression data where red means a gene is really high and blue means it's getting shut down. And the blue ones are the interesting ones, right? Because that tells us that the virus is probably doing something to shut those genes down. And that tells us that they're probably critically involved either in persistent infection or leading to disease. And so it helps us narrow down what we want. This RNA sequencing, it generates like 100 of these figures with dozens of genes on them. It's just literally overwhelming. So you can do an experiment in a week and spend 6 months to a year analyzing the data. This is what I call big data, right? Okay. And I may retire before all this is done because it drives me crazy. So we're kind of focused on this. So the take-home message is that when we look at the wild type deer mice infected with Andes compared to the wild type uninfected, there are 299 genes that are changed in their expression level, either up or down. But in the STAT2 knockouts, there's over 6,000 genes, right? So I'm going to focus on the easy part, the 300, and my graduate student, she gets to work on the 6,000 because she has a longer life ahead of her than I do. So, okay. All right, so we're in the very early stages of this. We're still analyzing these data, but we're hoping to get this at least first manuscript out in the next month or so. And so I'll just end with thanking everybody in my lab that's been working on. Claire is the one who's driving this. She's a DVM PhD student in my lab. And then Laura and Felita are here somewhere today. Wave. Oh, I'm sorry. I'll give you a pay raise when they let me. And then Erica runs my lab, and then Luke is heading off to medical school at the University of Kansas soon. He's going to do an MD, PhD there. And then Brad and Andre are doing all my flow cytometry work, which I don't know how to do anymore. It was simple back in the day when I was a graduate student, but flow cytometry is like crazy complicated. So that's it. Thanks.
All right, fantastic. Can I have our last session speakers come up for Q&A? About bats? Okay. Topic of discussion includes bats, apparently, if you have questions.
Okay. We have an online question.
Yeah, we can start online.
Does the incidence of Coccidioidomycosis, apologies if I pronounce that incorrectly, cases compared to blastomycosis cases contribute significantly to misdiagnosis in Colorado?
I would say no. Since we started doing the surveillance, we've only seen one case of blastomycosis. And while it's true that there can be some cross-reactivity with the antigen testing, it's mostly between blastomycosis and histoplasmosis. And most of the Cocci testing is a complement fixation that gets auto-sent for immunodiffusion, and the immunodiffusion is a lot more specific. So we don't think that that's really part of the misdiagnosis. Most of the time we see like they get an x-ray, there's like nodules in the lungs, they have pneumonia, and then they're prescribed antibiotics over and over again. And the antibiotics don't treat it because it's a fungal illness. And then eventually they start testing for other things.
Any questions in the room? Yep.
Thanks for the presentations, everyone. Really great work. My question is for Dr. Schantz. Amazing research. I'm curious if the chronically infected mice, either with Andes or sin nombre, are they continually shedding virus during their infection?
So I can answer that for sin nombre. When you take some infected deer mice and add to that cage some uninfected deer mice, they never get infected. Which is a big question, right? Because the hypothesis has always been that this occurs in the dens over winter or by fighting when they encounter each other for territorial disputes. And we haven't done a contact transmission study with Andes virus yet because we're too early in that work. But my guess, at least with the STAT2 knockout deer mice, they would probably transmit quite efficiently because there's so much more virus. I mean, it's orders of magnitude more virus, right?
Thank you.
Yep.
My question is for Dr. Duncan. Just on types of pollution, I was curious about light pollution and electrical pollution, like loss of natural night as a habitat. Do those feature into some of your survey work, or is that something separate? Just your thoughts on those two pollution types.
Yeah, no, it's a good thing to bring up. That was brought up by some of our subject matter expertise, is like thinking about the diverse types of pollution. Like a lot of people, I think, tend to think of like macro pollutants, things we can hold in our hand. I think there's been a lot of really great work. Like if you look at some of the Park Service work, they talk a lot about night skies and even the county and things like that. I think a lot of those things are really great messaging to talk about across species and like the value of all of those things. It did come up in our survey, but it wasn't really part of kind of the main thing. But it's an excellent point. There are so many types of pollution, and that's an under-recognized one.
I had a question for Tony. I was curious. No. Well, maybe no.
I'm just kidding. Go ahead.
No, it's probably no. I was curious about the opposite experiment of putting some nombre into the Andes host.
The rice rats.
Yeah, and I know there's not a colony of those, but if you've thought about that or.
Yeah. So back in 2007 or 8. I have a colleague in Chile, and we had proposed to capture and quarantine rice rats. And his university would not allow us to do that because they had BSL-2 and they were risk averse for that kind of, even though we were going to quarantine them outdoors, just like we had with our deer mice. I did that at Mesa State College, right, which is BSL-2 only as well. So it could have been done. It just, there was an administrative hurdle we couldn't overcome.
I also have a question for Dr. Shantz. In your experience trying to parse apart the immune response in the deer mice, has your lab utilized any type of irradiation experiments to deplete immune cells, and then do you have the tools available to say sort out specific immune cells through flow cytometry and preferentially add those back in one piece at a time to kind of see if you can mess with the ability for the mice to clear it? And then also just secondary question, for human cases, do human cases remain viremic at high levels throughout their illness? And do you know of any type of use of IVIG as kind of experimental treatment for those cases?
So your first question, we can do some flow. We have CD4, CD8. We don't irradiate our animals. I think we probably have a cesium source on campus, but we have the ability to conjugate toxins now to antibodies very easily. And so you can target specific cell types. And the beauty of this toxin is that it only works intracellularly. So if it displaces from the antibody and goes systemic, it won't do anything. It's inert. So we have those studies in the works right now for our bats. And then we'll do it with the deer mice because the bat work is much further ahead than the deer mouse work. Your second question is, I don't know the answer to that from the treatment regimen. So what I do know is they've tried ribavirin and it doesn't seem to have an effect. So, and again, I think it's because you need to get the inflammatory immune response under control. That should be your top priority once the clinical manifestations set in. So I don't know if you recall from the slide, they administered the antibody a few days after infection in those hamsters, and that's how they get them to survive. But I would bet you money that by the time the hamsters start showing the inflammation, it's too late to use the antibody, right? And patients don't come in with Hanta saying, I've got Hanta until it's too late. So what that effectiveness will be in that Chilean study, I don't know, but I'm not too optimistic because I think they're going after the wrong target.
My question's for Tony. Hi, Tony. Do you think soft ticks play a role in the zoonotic cycle of these perpetually infected deer mice with hantavirus?
There's no evidence that ticks can transmit. I'm not saying it can't happen, but the best model for transmission are voles. Bank voles with pumalavirus in Northern Europe. Those experiments have been done at the Frederick Loeffler Institute, and they get very good transmission. In fact, they introduced some new animals to their colony, and it turned out that at least one of them was infected. So their entire colony got infected, and they had to rederive their animals in BSL-3, where they would wean, because if they had maternal antibody, you can wean those animals and they're virus-free. So they had to rederive their colony by using freshly weaned animals and euthanized all the infected ones. Because once they're infected for life, right? We have no such problem with our deer mice. We don't introduce any animals. Our colony's been closed for 26 years, so there's no new risk of that happening.
Yeah, hi, I had a question for Colleen. I recently left federal service, so I could now utter the words climate change in public. But given that the federal government is pretty much completely checked out of the climate change game, how do you envision us dealing with some of the issues that you talked about not only on a local but national, global scale?
I mean, it's an excellent question, and I will fully disclose that I am a Canadian. So absolutely, it's a frickin' insane time right now. But I think some things that give hope is that the majority of people who even don't talk about it, we need to normalize talking about it. And so when you read things by Catherine Hayhoe and people who are really trying to normalize conversation around climate, it is don't worry about making it the focus of your life work. I mean, I'm lucky I can be a rogue academic, but talk about it with your family. Talk about it over beer. Talk about it at the gym. Normalizing the conversation. A great example I gave for the students, a guy came to fix our dishwasher the other day. I talked to him about climate change because he was bent over on my floor. We just need to have all the conversations. I think sometimes we get really caught up, or I know I get caught up in maybe there needs to be this huge epic movement, but all epic movements start with a community of like-minded individuals. I think one thing that's really, for me, has been helpful or inspirational is that there's a solid body of research that shows that if you talk about health, you bridge that partisan divide. Also, this weird phenomenon seems to happen only in this country, right? The rest of the world believes other things. I think if we keep the conversation, nobody wants a little girl to have asthma from air pollution, right? Everybody agrees that that's an important thing. Nobody wants a dog to burn up in a fire. So I think even keeping the conversations quite health-focused, and again, Hayhoe's work is really great. There's a number of people who've put out some really good general, for everybody, resources about how to have those types of conversations, but quite often it starts for why it's important to you. And I think if we look at Colorado, in the Marshall Fire, 1,000 dogs died in their homes. And the reason is people didn't know their neighbors to phone to get their pets out. And so there's really basic, fundamental community building initiatives that we can do that build resilience around this. And I think those types of things are not necessarily, we can do those for the next 2 years until there's some federal money or something again. Do you know what I mean? I think we can sort of turn inward and build some of those smaller connections. But really, a super important thing is that we talk about it. So if people hear that this is a normal thing or I'm worried about it, I talk about air pollution all the time, oh shit, I don't want to go for a run, the AQI is 162. People just need to hear that, and that is a shared concern, a health concern. That's my approach.
Excellent. I think that's a great place to end for the day. We're out of time, and I appreciate everyone hanging through here. Again, we're talking a lot at academic, university, and state level, but it all comes down to you all here in the audience and how you want to use this information that you've learned today in your day-to-day work and with your families and friends. So I'm going to give the mic over to Hannah to do some announcements before our last few remarks, and thank you for our final speakers today.
All right, thank you to everyone who was able to attend here, both in person and virtually. We will be sending out updates and information to the email addresses that were used for registration by April 16th, so please keep an eye on your inboxes next week. The certificates for the continued education credits will be included in this email. We were approved for 3.5 medical credits and 2 non-medical credits through the Registry of Approved Continuing Education and 4 credits through the National Environmental Health Association. These are available for veterinary and public health professionals in attendance today, both virtually and in person. There will be a link to access the recording of the conference and PDFs for today's presentations. We will also send out the responses to all the questions that were answered by our presenters today, as well as do our best to address those that we were unable to get to. And then finally, we do have a survey for you to provide feedback for us, and we would love to hear how this year's 51st anniversary went. And please do not hesitate to reach out to the CDPHE, Zoonoses, and One Health team if you have any questions. Thank you. And then...
Okay. Tracy and I get to close you out. So, very briefly, because we're going to get kicked out in 3-ish minutes, and like really kicked out, like we actually have to not have butts in seats. We wanted to thank you all for coming. Thank you to the speakers, to the audience, to the organizers, and our sponsors. So we are sponsored by the CSU One Health Institute. Thank you. As well as the Rockies and High Plains Vector-Borne Disease Center and CDPHE. And I'm doing double duty for both today. So thank you very much.
And really, just to add a couple of things. First, we hope you continue conversations in the lobby. There's also a place for you to recycle your name tags. And then I just really want to, this partnership with One Health, CDPHE, and the Rocky Mountains High Plains Center has been amazing. And I also want to, maybe you can all wave your hands, those of you that all helped to make today possible, because we could not have done it without you. So thank you one more time to our amazing speakers. We really appreciate the expertise that you shared. It was great having you all here, and we look forward to seeing you next year, and safe travels home.